2021 grade 12 math trial examination paper, right? So we have this first question here, 1.1.1, which says 2x multiplied by 3 minus x is equals to 0. So for this equation to be equals to 0, right, it's either 2x is equals to 0 or 3 minus x is equals to 0. If one between the two is equals to 0, then their product will be 0, right? Or if all of them are equals to 0. So how do we potentially solve this? So we say that we need 2x to be equals to 0, or we need 3 minus x to be equals to 0, right? So if 2x is indeed equals to 0, then x will be equals to 0 divided by 2, which is just 0, right? And then indeed, if you substitute it here, if you substitute 0, that equation will satisfy what is supposed to satisfy, right? Which is 0. On the other side, we're gonna get minus x being equals to minus 3. So x is equals to 3, right? And then that also satisfies our equation. If x is equals to 3, then we have 3 minus 3, which is 0. And then our equation is satisfied. So let's move forward and do 1.1.2. So 1.1.2, we have 5x squared minus 4x is equals to 2. And then let's solve for x and round off to 2 decimal places. Soon as we see that we have to round off to 2 decimal places, we know fully well that we're supposed to use the quadratic formula, right? So let's rearrange our equation and write it in the standard format. So we're going to have 5x squared minus 4x minus 2 is equals to 0, right? Now we have our equation in the standard format. We know fully well that 5 will be A, and then minus 4 will be B, and then minus 2 will be C, right? And the general formula for a quadratic equation is given as x is equals to minus b plus or minus, we have b squared minus 4ac divided by 2a. So now it's just a matter of substituting into this equation and we get our values of x. So x will be equals to minus, we said b is minus 4, so minus 4 plus or minus b squared minus 4 squared minus 4ac. A is 5 and then c is minus 2, and then we divide in everything by 2a. A is 5, like we've already said, so we just have that. So we're gonna get x equals to. So when I get to this point, I don't want to put this individual term in the calculator and then put this term in the calculator and then put this in the calculator and keep going down. No, I don't want to do that. I put this in the calculator as it is, just to avoid the mistakes I can possibly make, right? So you put it in the calculator, and then for the first time you put plus here, right? And then for the second time you put minus, because you're supposed to get 2 values, right? So if you do that, your x will be equals to minus 0.35, or your x will be equals to 1.15, right? Let's do 1.1.3. 1.1.3 says we have 7 plus 3x plus 2x being equals to 0, right? We're still solving for x. So we have that square root, so we have to square both sides, right? But then if we square both sides while we still have this 2x here, then so many issues are gonna arise. So the first step, let's take 2x to the other side. So we're gonna have 7 plus 3x being equals to minus 2x. Now we can square both sides in peace, right? And not so many issues will arise. So we're going to have 7 plus 3x is equals to 4x squared, like you would, expect. And then if we rearrange this, we get 4x squared minus 7 minus 3x. Actually, let's start by minus 3x so that it can be standard format, right? Minus 3x minus 7 is equals to 0. So here we are, right? If I have an equation like this and then a is not 1, I usually resort to using the quadratic formula, right? Because for the most part, it's just too complicated when you don't have 1 there as the coefficient of x squared, right? But then if you can factorize it, then obviously you can go with that, but I really recommend that quadratic formula because you can never really go wrong with the quadratic formula. So if you factorize this, you get x plus 1, 4x minus 7 is equals to 0. I really don't recommend factorizing when you don't have a coefficient of 1. It's a bad idea. You're gonna lose marks unnecessarily. Just use the quadratic formula. Yeah, like even if it seems easy to factorize it, and then after that use the quadratic formula and see if it works out. The quadratic formula is just the way to go. So now we can say x plus 1 is equals to 0, or 4x minus 7 is equals to 0. So x can be minus 1, or x can be 7 divided by 4, right? So we have minus 1 and 7 divided by 4. So I want you to realize something. We had this equation initially, right? And then in attempt to solving the problem, we squared the two sides, right? When you square the two sides, you allow solutions that are not necessarily true to be true. Let's say, for instance, you have x is equals to 2, right? And then instead of solving x is equals to 2, you say, let me solve x squared is equals to 4, because they are essentially the same thing. If you decide to solve x squared is equals to 4, then 2 will be your solution. But not only will 2 be your solution, even minus 2 will be your solution, right? The minus 2 will satisfy what you have changed your expression to, but then it won't satisfy what you were initially trying to solve, right? So the same thing happens here. We have squared the two sides. We have introduced solutions that are not necessarily true. So it's now our job to go back to the equation and see which one between the two solutions doesn't necessarily satisfy what we're trying to satisfy, right? So again, let's have 7 plus 3. In place of x, let me put minus 1. So this will just be minus 3, right? And then 2x when x is minus 1, so this will be minus 2 being equals to 0. So you can see here we have 4 minus 2, square root of 4 minus 2, so this will be 2 minus 2, so this is equals to 0. So it seems like this one works. Let's check the other solution which we have, and then so we have square root of 7 plus 3 multiplied by 7 divided by 4 plus 2x is equals to 0. Already you can see that this will not be equals to 0, because here we're gonna get 7 plus 7, 14, 21 divided by 4 plus 14 divided by 4 is equals to 0, and this is clearly not equals to 0, right? So this solution here, it falls apart, so it's not applicable, right? And then there's actually a mark for rejecting that other solution. And then let's move forward. Let's do 1.1.4. So 1.1.4, it is saying to us we have 3 to the power x plus 2 plus 3 to the 2 minus x being equals to 82. So when I see problems like this, the first thing I want to do, I want to change everything and give it a base of 3. And then if I give everything a base of 3, then I can let 3 to the power of something be k and factorize with ease, right? But then there's no way you can put 82 to the base of 3 and then have a whole number as the power of the 3, right? So yeah, now it becomes a bit complicated, but let's see what we can do. So 3 to the power x plus 2 is the same as 3x multiplied by 3 to the power of 2, right? And then here we have 3 to the power of 2 multiplied by 3 to the minus x being equals to 82. So this is the same as 9 multiplied by 3 to the x plus 9 divided by 3 to the power x. Why are we saying divided by 3 to the power x? Because a to the minus 1 is equals to 1 divided by a. So 3 to the minus x will be equals to 1 divided by 3 to the x. So we can bring 82 to the other side, so we're going to have minus 82 being equals to 0, right? So now we have this denominator of 3x on the middle term, so let's multiply throughout by 3 to the x, right? So that we can sort of have a linear equation. So if we do that, we're going to have 9, we have 9 multiplied by, so we have 3 to the power of x, which is here, multiplied by 3 to the power of x, we are multiplying out with, right? So if we do that, we're gonna get 3 to the 2x, because same basis, you add the exponents, plus 9, because 3x multiplied by 1 divided by 3x will just be 1. So here we have minus 82 multiplied by 3x being equals to 0 essentially. Yeah, but let's see if we can. So now we can, try factorize this, but then it's very difficult when you have this kind of things, right? It's very difficult to factorize it like that. So what I like to do, I let so what I like to do, I let 3 to the x be equals to k, right? So if I'm dealing with k, it will be more easy to factorize compared to when I'm dealing with 3 to the 2x. So we're gonna have 9 multiplied by k squared plus 9 minus 82k being equals to 0. So let's rearrange and write this in standard format, right? So we have 9k squared minus 82k plus 9 being equals to 0. So we can factorize this and find k. Obviously, I don't recommend factorizing. Use the quadratic formula so that you can never go wrong, right? So if you insist on factorizing, you're gonna get 9k, and then on the other side we have k, and this is all equals to 0, right? And then with 9k you have minus 1, and then here you have minus 9, and then if you multiply out, you should get the same expression, right? Let's just check real quick and see if it's true. So you have 9k squared minus 81k minus k plus 9. So this is minus 82k. So yeah, we have factorized correctly, but I don't recommend it, as I've been saying. So now we can say that 9k minus 1 is equals to 0, or k minus 9 is equals to 0. So k is equals to 1 divided by 9, and then on the other side we have k being equals to 9. So we know fully well that k is 3 to the x, right? So we have 3 to the x being equals to 1 divided by 9, or 3 to the x being equals to 9. Yeah, so let's see. So here we have 3 to the x. 1 divided by 9, you can write it as 3 to the minus 2. And then here you can write 9 as 3 to the power of 2. So we have x is equals to minus 2, same basis. So we drop in the basis and equate in the exponents. And then we drop in the basis and equate in the exponents. So here we're going to have x is equals to 2. And then that's how you essentially solve your problem. Let's do 1.2. So for which values of x will the square root of x squared minus 5x plus 4 be real, right? So let me just write that down. So we have the square root of x squared minus 5x plus 4, right? If it's indeed real, then that should be greater or equals to 0. If the question was saying for which values of x will that expression be not real, right, then it will be less than 0, right? But then here it is saying for which values will it be real, so we're saying greater or equals to 0, right? So it should be obvious now how we should move. We square in both sides, so we get x squared minus 5x plus 4 being greater or equals to 0, right? So now let's find our CV critical values, right? So we're going to equate to 0 so that we can find our critical values. So we're going to get x squared minus 5x plus 4 being equals to 0. So we essentially factorize in here. We get x, and then this is equals to 0. So now the question I'm asking myself, which two numbers do I multiply and get 4? But then when I add, I get minus 5. So that is minus 4 and minus 1. So x is equals to 4 or x is equals to 1, right? Now this is where the magic happens, right? So there's two possible solutions to this problem. It's either the answer lies between these two critical values or outside the critical values. Let me show you what I'm talking about. It's either our answer is between 1 and 4 or is outside that domain, right? That is x being less or equals to 1 or x being greater or equals to 4. So one between these two solutions, your solutions 1 and 2, one between these two solutions needs to be true, right? So if you try out a solution in the first possible solution and then you get the right answer, then that solution is right and the other one is wrong, right? And vice versa is true. So let's pick a number between 1 and 4. If we pick a number between 1 and 4 and we substitute it here in our equation and our equation is satisfied, then our answer lies between 1 and 4. And then if that number that we pick doesn't satisfy our equation, then without testing the other solution is automatically true, right? So between 1 and 4, let's pick 2, right? So here we're gonna have 2 squared, which is 4, minus 5x, we're saying x is 2, so that will be minus 10 plus 4. So we have 4 and 4 cancelling out. No, now we have square root of minus 10 being greater or equals to 0, right? And we know fully well that that cannot be true. We cannot take a square root of a negative number at this level. So the first solution falls apart. So this is wrong, and then the second solution is the correct one, right? Try out a number that is in this, that satisfies these conditions, and tell me if that equation is not satisfied. Last but not least, let's solve simultaneously for x and y. So we have xy being equals to 12, and then x minus 4 is equals to y, right? So if I make x or y a subject of the formula in this equation, then I'm going to get a fraction, and then I'm going to have to deal with a fraction, which is something I don't really want, right? So I'll just make x or y the subject of the formula in this second equation. So let me make x the subject of the formula. So I'm going to get x is equals to y plus 4, right? So now I can substitute this value into this equation. So we have, in place of x, I'm going to have y plus 4 multiplied by y being equals to 12, right? So y squared plus 4y minus 12 is equals to 0. So let's factorize. So which two numbers do I multiply? Get minus 12, and when I add them I get 4. That is 6 and minus 2, right? So we have plus 6 and minus 2. So y is equals to minus 6, or y is equals to 2. So now we can find x, right? If y is equals to minus 6, then x will be equals to 12 divided by minus 6, which is minus 2, right? And then if y is equals to 2, then x will be equals to 12 divided by 2, which is equals to 6, right? I'm just substituting into this equation here and finding our value of x. Let's do this trick equation real quick. We are told that the pth term of the first differences of a quadratic sequence is given by tp is equals to 3p minus 2. And then 2.1 says, let's determine between which two consecutive terms of the quadratic sequence the first difference is equal to 1450. So this equation that we have here is not the equation. This equation that we have here is not the equation of the quadratic sequence. It's the equation of the first difference of the quadratic sequence, right? So let's say, for instance, we had a quadratic sequence with terms 1, 4, 9, 16, right? And then let's find the first differences. We're just using this to make an example, right? 4 minus 1 is 3, and then 9 minus 4, that is 5, and then 16 minus 9, that is 7, and then 5 minus 3, that's 2, and then 7 minus 5 is 2, right? So in this equation, we are given the equation of this sequence here, the sequence of the first differences. If the question was asking us in which two terms does 5 lie, right? It lies between T3 and T2, right? And then in between which two terms does 7 lie? It lies between T4 and T3. But here we have an equation for the first differences instead. We have Tp is equals to 3p minus 2, right? And then we know that that term that we're looking for is 1450, which is equals to 3p minus 2. So if we solve for p, then we're gonna know which position that term lies, right? Clearly here, if the term is in position 2, then it is between term 3 and term 2. And then if it's in position 3, then it's between the fourth term and the third term, just like that. So let's go ahead and solve for p. So we're gonna have 3p being equals to 1448. We divide both sides by 3, we get p is equals to 484, right? So now we know that this term 1450, it lies between the 485th term and the 484th term. So this term lies between 485 and 484th term, right? Because term number 2 lies between 3 and 2, term number 3 lies between 4 and 3. So term 484 will lie between 485 and 484, right? Now let's do 2.2. For 2.2, they tell us that the 40th term of this quadratic sequence is 2290, and then they give us an equation. Tn is equals to an squared plus bn plus c. And then they want us to determine the value of c. I want you to realize something. If we have the equation of the first differences, then we can find b and a, right? And then if we have b and a, we can substitute T40 to determine c. Let me show you what I'm talking about. Because we know fully well that Tp is equals to 3p minus 2. So the first term, in place of p, we put 1, right? So we have 3 minus 2, which is 1. And then the second term, we have 3 multiplied by 2, which is 6, minus 2, and then that is 4. And then 3 multiplied by 3, that is 9, minus 2, that is 7, right? And then this is the first difference. Now let's find the second and common difference, right? 4 minus 1, that is 3, 7 minus 4, that is 3. And then we know fully well that 2a is equals to the common difference. So we're going to have 2a is equals to 3. So a is equals to 3 divided by 2. Right? Apart from that, we know that 3a plus b is equals to first term of first difference. Right? So 3a plus b will be equals to 1, right? So we have b being equals to 1 minus 3a, but we know what a is, right? A is 3 divided by 2. So this will be equals to 1 minus 9 divided by 2, which will be equals to minus 7 divided by 2. Now we have the value of b, right? We can substitute in our equation and find c, because we know that tn is equals to an squared plus bn plus c, and then we are told that T40 is equals to 2290, right? We have a, we have b, we have n, so we can find c. So we're gonna have 2290 is equals to a, which is 3 divided by 2, and then n is 40, we square, plus b, right, which is minus 7 divided by 2 multiplied by 14 plus c. So now we can essentially find c. So we're going to have 2290 being equals to 2400 minus 140 plus c. So if you do that arithmetic, you're going to get c is equals to 30. The first four terms of an arithmetic sequence are 65, 73, 81, and 89. And then 3.1.1 says determine an expression for the nth term of the sequence we have, right? We know fully well that for an arithmetic sequence, the general expression is given as Tn is equals to a plus n minus 1 multiplied by d. So a is always the first term, right? So at this point, we know that Tn is equals to 65 plus n minus 1 multiplied by d. And then now let's pay our attention to d. D is the common difference, right? You can find d by saying that T2 minus T1, or you can say that T3 minus T2, as long as you finding the difference between two consecutive terms, right? Basically we're saying Tn minus Tn minus 1, right? So let's take T2 minus T1 and see what we get. So T2 is 73, and then T1 is 65, and then if you find the difference of that, you get 8, right? So now we can say Tn is equals to 65 plus n minus 1 multiplied by 8. So Tn will be equals to 65 plus n multiplied by 8, that is 8n, and then minus 1 multiplied by 8, that is minus 8. So now we have Tn is equals to 8n, and then 65 minus 8. 65 minus 8 is 57. So we're going to have plus 57 here, and then we have our general formula. After you find this expression, substitute one term and see if you get the right answer. For instance, put 2 here and see if you're gonna get 73, right? Just like that. So let's go ahead and do that. So T2 will be equals to 8 multiplied by 2 plus 57, right? And then that is 16 plus 57. 16 plus 50 is 66, plus 7, that will be 73. So indeed our formula is working. So now we're convinced and we can move forward. Let's do 3.1.2. 3.1.2 says let's calculate the value of the term in the 1000th position. So we want T 1000. So T 1000 will be equals to 8n plus 57. In place of n, we're going to put 1000. So this will be equals to 8 multiplied by 1000 plus 57. So 8 by 1000 is 8000, right? Plus 57. So we have 8057. And then that's our 1000th term. And then 3.1.3. It says let's calculate the sum of the first 1000 terms. So the sum is given by n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. So we want S1000, right? The sum of the first 1000 terms. So we're going to have 1000 divided by 2 multiplied by 2. 2a. What is a? A is the first term, so that is 65 plus n minus 1. So it's 1000 minus 1 multiplied by the difference, which is 8, right? So multiply by 8. And then if you put that in your calculator, you're going to get 4,061,000. That seems to be correct. Let's do 3.2. 3.2 says an arithmetic and geometric sequence have the same first term, right? The common difference and the common ratio have the same value. The fifth term of the geometric sequence is 80, and then determine the first 3 terms of the arithmetic sequence. So the first term of the arithmetic and the geometric are the same, right? It's said to be 5, and then the common difference and the common ratio have the same value. So let's do it like this. So the difference is equals to the common ratio on the geometric, right? But they're the same. So let's just put x. Let's use x, right? And then okay, let's have the arithmetic and the geometric. So for the arithmetic, we're gonna have 5 as the first term, right? And then the second term will be 5 plus the common difference. And then the third term will be 5 plus 2x, and then 5 plus 3x, and so on, right? And then for the geometric series, the first term is 5. And then the second term, we know fully well that the formula is AR to the n minus 1, right? So for the second term, we're going to have 5x. And then for the third term, we have 5x squared. We have 5x to the 3. And the fifth term, we have 5x to the 4. And so on, right? And then we are told that the fifth term, 5x to the 4 of the geometric sequence is equals to 8, right? So now we can say that 5x to the 4 is equals to 80. Now we can divide both sides by 5, right? You're going to get x to the power of 4 is equals to 16, right? If we take square roots on both sides, we're going to get x squared is equals to 4. And then if we take square roots again, we get x is equals to 2 or x is equals to minus 2. Now to actually answer our question, which is to determine the first three terms of the arithmetic sequence, if x is equals to 2, right? If x is equals to 2, then the first term will be 5, the second term will be 5 plus x, right? Here it is here, 5 plus x. So the second term will be 7, and then the third term will be 5 plus 2x, so that will be 9, right? So we can have 5, 7, 9 if x is equals to 2. But then if x is equals to minus 2, then the first term will be 5, the second term will be 5 minus 2, 3, and then 5 minus 2 multiplied by 2, that is 1. When I looked at this question, I was thinking, wow, I'm going to need a lot of creativity to answer this question. But then when I actually tried answering it, I realized that it's so easy, right? I think the mistake most people do with this kind of questions, they look at it, it looks intimidating, and they just leave it. Sometimes, just try the question and see what happens. So here, the question is saying, calculate the value of y if this expression here plus this expression is equals to this expression. And then I realize very quick that this is the sums, right? So I can just calculate S1 being that sum there, and then plus S2 being this sum here, and then I equate it to S3 being that sum there, right? I've not broken any rule in math, so that should work out. And then let me show you what happened. So S1 is the first sum. Let's see what happens when I calculate that. So that will be equals to, we can see that we go in from 1 to 5, right? So you substitute 1 into the equation, substitute 2 until you substitute 5, right? So if I substitute 1, the equation is going to be, so we have p is equals to 1, right? So 4y remains as it is, and then plus 3p. We know that p is equals to 1, so this will just be plus 3, right? And then now I can add the second term, because for a sum, you add in the terms, right? Assuming the sum is finite. And then now p is equals to 2. We're going to have 4y plus 3 multiplied by 2, because now p is equals to 2, right? So we're going to have 4y plus 6 plus 4y again plus 3 multiplied by, now p is 3, right? 3 multiplied by 3, that is 9. So for the full term, we're going to have 4y plus 3 multiplied by 4, which is 12. And then plus 4y plus 3 multiplied by 5, which is 15. So now we are just adding all these terms together, and we have S1. I want you to realize something now. We have 4y, 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 and 4y, right? We have 5 4y's. So the sum of that will be the same as 4y multiplied by 5. And then we have 3 plus 6 plus 9 plus 12 plus 15, right? We group in the like terms, so to say. So 3 plus 6, that is 9, right? And then plus this 9 here, that will be 18. And then 18 plus 12, that will be 30. And then 30 plus 15, that will be 45. So we have 4y multiplied by 5 plus 45. And that will be equals to 4 multiplied by 5, that is 20. So we have 20y plus 45. And we have our first sum. Now we can move ahead and calculate our second sum, right? You should realize now that, yeah, this question is not that difficult. It just looks scary. So the first term, right? We substitute in k is equals to 4 until we get to 7. So we're going to have 3 multiplied by 2 to the power k minus 1. So we have 4 minus 1, and then let's move to the second term. Plus, again, 3 multiplied by 2 to the power, now we have 5 minus 1, right? We're moving up until we get to 7. Plus 3 multiplied by 2 into 6 minus 1, and then plus 3 multiplied by 2 to the power 7 minus 1. Here we don't have any variable, right? So you can just put this entire expression on your calculator and get the answer, right? So the answer here is going to be 360. So now we have S1, S2. Let's find S3. So S3, we're going from j is equals to 1 to j is equals to infinity. So if we go into infinity, we obviously cannot calculate the individual terms, right? Because we'll never really go to infinity. In any case, what is infinity, right? Equation for another day. So here we have the equation being, the equation is 1 divided by 3 to the j minus 1, right? So the first term of the sequence, right? So let's say A. So A here is going to be equals to 1 divided by 3 to the power j minus 1. J is 1, right? So we're going to have 1 minus 1 being equals to 1 divided by 3 to the power 0. Any number to the power 0, we know that is equals to 1, right? So the first term here, A, is equals to 1. And then from there on, what is the common ratio? The common ratio is 1 divided by 3, right? So we have a diverging geometric sequence here. And then to calculate the sum of that, we're going to have A divided by 1 minus R, right? But then what is the value of A? A is equals to 1. So this is going to be 1 divided by 1 minus the common ratio, which is 1 divided by 3. If you put that in your calculator, you should be getting 3 divided by 2. And then now, let's finish our problem. I'm just going to finish the equation here, right? Like we've said, S1 plus S2 should be equals to S3. What is S1? S1 is here, right? 20y plus 45. S2 is here, 360. So we have plus 360. And then S3 is 3 divided by 2. So if we want to find y, we are going to say that 20y is equals to 3 divided by 2 minus 45 minus 360. Right? Now we divide both sides by 20. So we're going to get y is equals to this entire term divided by 20, right? Divided by 20. And then here we're also dividing by 20. So y is going to be equals to minus 20.175. So we have a hyperbola g of x given as minus 4 divided by x minus 1 plus 2. And then the first question, 5.1, is saying let's write down the equations of the asymptotes of g. So g of x is equals to minus 4 divided by x minus 1 plus 2. But then, what is the general formula of a hyperbola? The general formula of a hyperbola, f of x is equals to a divided by x plus p plus q. We need the vertical asymptote and the horizontal asymptote. So the vertical asymptote is given by x is equals to minus p, and the horizontal asymptote is given by y is equals to q. So let's look at our equation g of x and determine minus p and q, right? So let's start with q because it's pretty much straightforward, right? We just have plus 2. So the horizontal asymptote will be y is equals to 2. And now let's come to the vertical asymptote. We need x to be equals to something. So let's go to our equation g of x, right? We have x minus 1 here. And we're saying that the equation must be x is equals to minus p. So p in our equation is minus 1. So that tells us that minus p will be positive 1, right? So we have x being equals to 1. So we have our horizontal asymptote, which is y is equals to 2, and our vertical asymptote, which is x is equals to 1. Another way of determining the vertical asymptote, you can just see x minus 1 is equals to 0, so x is equals to 1. 5.2 says, let's determine the intercepts of the graph of G with the axis, right? So we need the intercepts. We have two intercepts, the y-intercept and the x-intercept. Let's start with the y-intercept. So y-intercept, what do we know about y-intercept? We know fully well that for the y-intercept, x is equals to 0, right? So we take our equation g of x and let x be equals to 0, and we solve for y, right? So y will be equals to minus 4 divided by x minus 1. In place of x, we put 0 because we want the y-intercept. So we have 0 minus 1 plus 2. So y will be equals to minus 4 divided by minus 1 plus 2. So that will be equals to minus 4 divided by minus 1, that is just 4, right? Plus 2 is equals to 6. So the y-intercept is the coordinate. For x, we know we need 0, and then for y, we have 6. So that is our y-intercept. Now let's move forward and do the x-intercept. So x-intercept, y is equals to 0, right? So in place of y, we put 0 and we solve for x. So we're going to have 0 is equals to minus 4 divided by x minus 1 plus 2. We just substitute in y is equals to 0 on our equation g of x, right? We have minus 2 is equals to minus 4 divided by x minus 1. You just subtract minus 2 on both sides. If we cross multiply now, we're going to get minus 2x plus 2 is equals to minus 4, right? So we're going to have minus 2x being equals to minus 6. So x is equals to 3. So our point for the y-intercept would be 3 for x and 0 for y. And then we have our x-intercept. Let's move to 5.3. 5.3, it's saying let's sketch the graph of G. Show all intercepts with the axis as well as the asymptotes of the graph. So when you sketch in a parabola, you basically just need the intercepts and the asymptotes. After you get those right, you cannot go wrong. So let's have our x-axis and see what we can do here. So we have our x-axis and then we have our y-axis, right? And then let's start with the equations of the asymptotes. We know that the vertical asymptote, we have x is equals to 1, right? So here at 1, we're supposed to have a vertical asymptote, and then the horizontal asymptote, we have y is equals to 2. So here at 2, we're supposed to have our vertical asymptote, and there we have it. Now let's have our intercepts, right? Our intercepts basically determine where the wings, so to say, of our parabola lies, right? So intercepts, we have x is equals to 3. So here at 3, we have our intercept, right? So one wing must cut here at 3. And then for y, we have y is equals to 6. So here at 6, we must have a wing cutting through. So how can we now construct our graph? We know fully well that part of our graph must cut through 3, right? And then we must not touch the asymptotes. And then the other part should go through 6, but we should not touch our asymptote. So this is how we construct our parabola in this instance. Grade 12 Mathematics, Paper 1, September 2021, right? Past trial examination question on parabolas. We have a 6.1 here saying to us, let's determine the coordinates of C, the turning point of F, right? So let's look at the equation of f first, right? F is given to us as minus x squared plus 4x plus 5. And we want to determine the coordinates of the turning point, right? To determine the coordinates of the turning point, you first find the x value of the turning point. And after you've determined the x value of the turning point, you can then determine the y value of the turning point, right? So the formula you use for the x value of the turning point, you say that x is equals to minus b divided by 2a. When your equation is on the standard format, right? We know that minus 1 will be a, 4 will be b, and then 5 will be c. If we substitute that in our equation, we get minus 4 divided by 2. We see in a is minus 1, so this will be minus 4 divided by minus 2, which is equals to 2. So our x value for the turning point is 2. Now we can substitute 2 in our equation and find the y value of our turning point. So we can say f of 2 will be equals to minus 2 squared plus 4 multiplied by 2 plus 5. So we have minus and then 2 squared, that is 4. Then 4 multiplied by 2, that is 8. And then plus 5, right? And this will be equals to 9. So the coordinates of C, our turning point, is 2 and 9. And then 6.2, let's write down the range of f. So I've sort of conned an idea for the range of f, right? So if f is concave down, then the range will be y is less or equals to y of the turning point. And then if it's concave up, we have y being greater or equals to the y of the turning point. Clearly our parabola is concave down, right? It is ultimately going down. The values of y are ultimately going down. So we have y being less or equals to the y value of the turning point. We know fully well that here in our situation is 9, right? And then when you look at the graph itself, the y values of these graphs can never exceed the 9, right? 9 is the highest point this graph can reach. Now let's do 6.3. So 6.3 says let's calculate the length of AB. So we have A here and we have B here, right? A and B are the x-intercepts of our graph. So let's find those coordinates so that we can determine the length AB, right? So we know fully well that f of x is equals to minus x squared plus 4x plus 5. Right? So we know that if you want to find the x-intercept, you equate y to 0. So we're going to have 0 is equals to minus x squared plus 4x plus 5. Right? It's a bit tricky to factorize when you have a minus here. So I'm going to divide everything by minus 1, right? So 0 divided by minus 1, that is 0. And then we have x squared minus 4x minus 5. And then now we can factorize, right? So the question I ask myself again, which two numbers do I multiply? And then I get minus 5. But when I add them, I get minus 4. That is minus 5 and plus 1. So I have minus 5 and plus 1. So x is equals to 5 or x is equals to minus 1. So clearly the x coordinate of A will be minus 1, right? We cannot say the coordinate of B is minus 1 when B is clearly on the positive axis, right? And then the x value of B, that is 5, right? So what is the length from A to B? The length from A to B is 6, right? The length from A to B is 6 units. From -1 to 5, it's 6 units. So here we can say AB is equals to 6 units, right? We're basically saying that the x value of B minus the x value of A, which will be 5, minus -1, which is 6 units. And then now let's do 6.4. 6.4 says, let's determine the equation of G. G is a straight line that passes through D and B, right? Clearly. So to find an equation of G, since it's a straight line, we need y is equals to mx plus c. So we need to determine the gradient, and we need to determine c. So how can we possibly determine the gradient? You can see from our sketch that D and B, they lie also on our equation G, right? So if we find the gradient of dB, then we have the gradient of our line G, right? So let's see how we can do that. So we have the gradient of dB being equals to y2 minus y1 divided by x2 minus x1. We have the coordinates of B. We know fully well that is 5 and 0, right? And what about the coordinates of D? It seems like we don't have the coordinates of D, right? But then we can see fully well that D is the y-intercept of our graph F, right? So it should be easy to find. So y-intercept, we let x be equals to 0, right? So f of 0 will be equals to, so what's our equation? So we substitute in 0 here, that will be 0, and then we substitute 0 here, that will be 0. We'll only be left with 5, right? So f of 0 is 5. So now we can say that the coordinates of D is 0 and 5. So now we can, go back to our equation and find the gradient. So let's take D as our second point. So y2 will be 5 minus y1, which is 0, right? And then x2 will be 0, the x value of D minus the x value of B, which is 5. So we have 5 divided by minus 5, which is equals to minus 1. So now we know fully well that the gradient here is minus 1. But what about the value of C? C is the y-intercept of G, right? The y-intercept of G is the y-intercept of F. And we know that that value is 5, right? So the equation of G will be y is equals to minus x, right? Minus 1x is just the same as minus x, right? Plus the y value of the intercept of G, which is 5. So we just have minus x plus 5. But then you can also substitute D into the equation or B into the equation. You will still gonna get 5, right? And then now let's move to 6.5. 6.5 is saying T is a point on F such that D and T, T is a point on F such that D and T are reflections of each other over CVN. Write down the coordinates of T. So let me, erase a few stuff for the sake of clarity. So we have our point D, right? Yes, our point D. Let's make it clear. And then T is a point on F such that D and T are reflections over CVN. So T should be somewhere here, since it is a point on F, but it's a reflection about CVN, right? So yeah, let's just draw a straight line. If T is a reflection of D about CVN, then D and T should share the same y value. So now at this point we know that the y value of T is the y value of D, which is 5. Now we only need the x value. If it's a reflection over CVN, then the distance between D and CVN should be the same as the distance between CVN and our point T. So what is the distance between D and CVN? We know the x value of D is 0, right? And then we can find the distance here by using the x value of our turning point. The x value of our turning point is 2, right? So from D to CVN is 2 units. Then from CVN to T, it will also be 2 units, right? So if we add 2 from 2, we get 4. Now the coordinates of T, the reflection of D over CVN will be 4 and 5, right? And that's how you essentially determine it. And then 6.6 says the line EC is the tangent to F at C. The line EC, okay, there it is. And then write down the gradient of this tangent. This line EC, it touches the turning point, right? We know fully well from definition that the gradient at the turning point is equals to 0, right? So the gradient of that line EC will be M is equals to 0, right? It's flat. You can, just see it when you look at it. And then let's determine the coordinates of E. So 6.6.2, we want the coordinates of E. So E is here, right? E is where G and the tangent intersect, right? So let's find the equation of that line EC. The equation of that line EC will be Y is equals to mx plus c. We know fully well that the gradient is 0, so this part here falls apart. And just left with y is equals to c. But we know the value of c, right? The y-intercept is right here, is the y-coordinate of the turning point. Our turning point is c, right? So the y-coordinate of our turning point, we determined it in 6.1. We know that it is equals to 9, right? So at E, g of x is equals to 9, essentially, right? It's equals to the equation of EC. So now we can say that 9 is equals to the equation of g of x. We determine it somewhere, minus x plus 5. So we have minus x plus 5. So minus x will be equals to 4. So x is equals to minus 4. So that is the x value of E, right? But then we know the y value of E is supposed to be equals to 9, because that's the equation of line EC. So now we can say that the coordinates of E is minus 4 and 9, right? If you use the equation of g of x, you should still get minus 4 and 9 also. And then let's move to 6.7. 6.7 says let's determine the value of k for which y is equals to minus x plus k is a tangent to f. So y is equals to minus x plus k is a tangent to f. If y is equals to minus x plus k is indeed a tangent, then at some point f of x should be equals to y, right? Because if it's a tangent, then they touch at some point. If we determine the y value where they touch, right, and the x value where they touch, then we can determine the value of k, right? So let's start with the x value where they touch. So this is how we can, potentially determine the x values where they touch. We can equate their gradients, right? So we can say that f prime of x is equals to y prime. So if we derivate f of x, we get minus 2x plus 4 is equals to minus 1. We're using the power rule, right? We're derivating f of x and y. So now we can say that minus 2x is equals to minus 5. So x is equals to 5 divided by 2. So at this coordinate 5 divided by 2, this is where the two graphs touch, right? Now let's find the corresponding value. So you take this x value and you substitute it in the original equation, right? So f of 5 divided by 2 will be equals to minus 5 divided by 2 squared plus 4 multiplied by 5 divided by 2 plus 5, right? So if you put that in your calculator, you're gonna get 35 divided by 4. So now we can come back to this equation here and determine our k. So we can say that 35 divided by 4 is equals to minus x plus k. But then we know the x value at that point, right? We're saying that it is 5 divided by 2 plus k, right? So we're gonna have 35 divided by 4 plus 5 divided by 2 being equals to k. So our k is equals to 45 divided by 4. So what do we have here? September 2021 trial examination, grade 12 mathematics. We have a log function here, and it has an equation h of x, which is equals to the log of x base a. And then 7.1 says let's calculate the value of a, right? So these kind of questions are very repetitive. Like all the time when a log function comes, they ask almost the same exact questions. Is either you will find a log function or you will find an exponential function. They are always almost the same all the time. You're gonna have to find the value of a, which is part of the equation, and then the way you do that, you take a point on the graph and you substitute it, and then it becomes easy to find a. So there's a logarithmic rule that we're going to use in this question. Let me show you the rule I'm talking about. So we saying that log of a base b, if this is equals to c, then a is equals to b to the power of c. This is the rule we are going to be using. So let's do 7.1. So 7.1, we're going to substitute the point on the graph like we're saying, right? So let's substitute point p. Point p, the x value is a half and the y value is minus 1. And then don't forget we have our equation here, h of x, right? So if we substitute that point in place of y or h of x, we have minus 1, and then that will be equals to log of in place of x we have a half, and then the base is a, right? Now it becomes extremely easy to see that after you substitute point p, you can find a with ease. So how do we find a? We are going to use this log rule, so to say, that we're talking about. So now we can say that a to the minus 1 will be equals to 1 divided by 2, right? So how can we determine a? If we write 1 divided by 2 in such a way that it has an exponent of minus 1, then we can drop the exponents and equate the bases, right? So we're gonna have a to the minus 1 being equals to 2 to the minus 1. 2 to the minus 1 is the same as 1 divided by 2. So now you can see that the exponents are the same, so we can drop them and equate the bases. So we're saying that a is equals to 2. So our equation h of x will now become log of x base 2. So now when you have this 2 here, you can try substitute the x value of p and see if you get minus 1 for the y value of p. And then if you get minus 1, then you know indeed what you did is correct. And then if you don't get minus 1, there is a mistake you made. Let's move forward and do 7.2. So 7.2 is saying let's write down the equation of h inverse in the form y is equals to. So how do you find the inverse of a function? Well, the first step, you'll swap x and y, right? So you swap x and y, and then the second step, you solve for y. And after you have done that, you are essentially done, right? So let's see what we're talking about. So we know that h of x or y is equals to log of x base 2. So let's go ahead and do step number 1, which is to swap x and y, right? So in place of y, we're going to put x, then this will be equals to log of, in place of x, we put y, and then base 2. So now, we solve for y, and after we have solved for y, we have essentially found the inverse of our function. So let's do step number 2. So for step number 2, we're using this rule again that I showed you up there. So we're going to say that 2 to the power of x is equals to y. So let's just write it nicely, right? Y is equals to 2 to the power of x. So y is equals to 2 to the power of x is the inverse of our function h of x, right? You just swap x and y, and then after you swap x and y, you solve for y. And let's do 7.3. 7.3 saying write down the domain of the inverse of h. The inverse of h is clearly y is equals to 2x, right? The domain of a function is all the x values of which the function is defined, right? Clearly y is equals to 2x is defined everywhere, right? If the numbers are extremely large, getting closer to infinity, the function is defined. If x is 0, the function is defined. And even for all negative numbers, the function is still defined. Now we can say that x is an element of a real number, right? Any real number, y is defined, the inverse of h of x. Or you can write it in this notation, right? So we're coming from minus infinity all the way to infinity. Our function h inverse would be defined. But what about this function? Let's say g of x is equals to 1 divided by x. What about this function? What's the domain of this function? Clearly, you should see that at 0, this function is not defined because we cannot divide by 0, right? So when the question says, let's find the domain, you just don't write minus infinity to infinity. It depends on the function. You have to analyze it first. And then 7.4 is saying, determine the values of x for which h of x is less or equals to minus 1. So when you have a log function or you have an exponential function, you basically substitute the equation of that function and solve it algebraically, right? Versus if you are dealing with a trig function. A trig function is more complicated. That's where you have to analyze the graph. But then here is safe to substitute the equation. So let's go ahead and do that. So we know that h of x is said to be less or equals to minus 1. So in place of h of x, let's substitute log of x base 2 being less or equals to minus 1. Again, this question we're going to apply this rule, right? And then if we do that, we get x it's less or equals to 2 to the minus 1, right? 2 to the minus 1, we already say that that is 1 divided by 2. So x is less or equals to 1 divided by 2. So we need x to be 1 divided by 2 or less, right? But then that's not all. Let's look at our graph in the sketch here. I want you to realize something. Log is not defined for 0 going down, right? So the value of x always has to be slightly above 0 so that log can be defined, right? So here we're just gonna add that the value of x needs to be slightly above 0. Let's see if we can find the derivative of f of x is equals to x squared plus 5x minus 6 using first principle. So which formula do we use when we want to find the derivative of a function using first principle? We say that f prime of x is equals to the limit as h tends into 0 of f of x plus h minus f of x divided by h. What is left now is substituting. On this part of the equation, right, we just write in f of x, but then everywhere where there's x, we put x plus h, as you can see in this equation, and then we minus by f of x itself, and then we divide everything by h. But then what's going to happen at some point of time, we're going to take h as a common factor in the numerator, and that h in the numerator will cancel out with the h in the denominator. If that doesn't happen, then we have done something wrong. So let's go ahead and see what happens. So we have f prime of x being equals to the limit as h turns into 0, and then now let's write f of x plus h. So we have x squared. In place of x squared, we're gonna put x plus h squared, right? And then plus 5x. In place of x, we put in x plus h, and then minus 6, right? And then we subtract the function itself, right? So we're gonna have x squared plus 5x minus 6, and we're dividing everything by h, and this will be equals to the limit as h turns into 0. So now we're solving this here, x plus h squared. So we say that x multiplied by x, that will be x squared, and then x multiplied by h multiplied by 2, that will be plus 2xh, and then h multiplied by h, that is just h squared. And then now we have plus 5 multiplied by x plus h, right? We're gonna get plus 5x plus 5h minus 6. And then now we can take the function out of the bracket, right? We have a minus there, so we have minus multiplied by x squared, so that will be minus x squared. And then we have minus multiplied by 5x, that will be minus 5x. And then we have minus multiplied by minus 6, so that will be plus 6. And then let's divide everything by h. What's going to happen now? Every term that doesn't have h is supposed to fall apart at this step, right? If you can see here, we have x squared, right? And then here we have minus x squared, so that will give us 0. And then we have plus 5x, and then we have minus 5x, that will give us 0. We have minus 6, we have plus 6, that gives us 0. So what we're left with here is just 2xh plus h squared, what else, plus 5h, right? And then let's write that down. So the limit as h turns into 0 will be 2xh plus h squared plus 5h divided by h. Now we can take h as a common factor in the numerator. If we do that, we get the limit as h turns into 0 being equals to h, and then we'll be left with 2x plus h plus 5, and then we divide everything by h. So now h and h is going to cancel out, right? And then let's let h turn into 0. If we let h turn into 0, then f prime x is going to be equals to 2x plus 0 plus 5. This is just equals to 2x plus 5, right? If you want to prove whether this is true or not, you use the power rule, right? If we use the power rule on x squared plus 5x minus 6, we're going to get 2 multiplied by x to the 2 minus 1 plus 5 multiplied by 1 to the x minus 1 minus 1, right? And then 6 is a constant, so it's just gonna fall apart. So we end up with 2x plus 5, and then that should tell you that what you did is correct. And now let's do 9.2. So 9.2 here, let's determine f prime of x if f of x is equals to 3x multiplied by the square root of x minus 4. I don't know about you, but it's very hard to multiply with the square root, right? It's better if we just write it as to the power 1 over 2. So f of x, we can write it as 3x multiplied by x to the power half minus 4, right? So now we can further simplify. If we further simplify, we're going to get 3x, right? We know that there's always a 1 here, right? So that will be 1 plus 1. So that will be 1.5, which you can write it as 3 divided by 2 minus 3 multiplied by 4, that is 12. So we have 12x, right? So now we can then use the power rule to solve this. What is the power rule again? Just to remind you, if we have some function k x to the n, right? Then if you derivate that, you should get k multiplied by n multiplied by x to the n minus 1, right? K being the coefficient of our x, right? So let's use the power rule there and see what happens. So we have f prime of x being equals to, so we're going to have 3 multiplied by 3 divided by 2 multiplied by x to the power 3 divided by 2 minus 1. And then let's apply the same to 12x. We're going to have minus 12 multiplied by 1 and then multiplied by x to the 1 minus 1, right? So this will be equals to, so we have 3 multiplied by 3 divided by 2, 3 multiplied by 3, that is 9. If we divide it by 2, we just get 9 divided by 2, right? And then now we have x. So we have 3 to the power 3 divided by 2 minus 1, right? So that will be a half. And then minus, so we have x to the power 1 minus 1. Any number to the power 0 is 1, right? So we're just going to get minus 12. And that looks like we have solved our problem. Let's do 9.2.2. So 9.2.2, see, let's find dy dx if y is equals to x cube minus 4x divided by 2 minus x. This one is a bit complicated, right? But let's see what we can do. Let's take x as a common factor on the numerator, right? So we're going to get y is equals to x, and then we're left with x squared minus 4 divided by 2 minus x. And wait a minute, now we have a difference of 2 squares, right? So we can factorize that. So we're gonna have y is equals to x, and then now we have x minus 2 multiplied by x plus 2, right? And then we're dividing everything by 2 minus x. But then our denominator here, 2 minus x. If we take minus as a common factor, right, we're going to have y is equals to x multiplied by x minus 2 multiplied by x plus 2, everything divided by minus. We're taking minus as a common factor, right? So we should get plus x, right? Plus x minus 2. So now you should be able to see that x minus 2 and then x minus 2, they cancel out. So now we're going to be left with y is equals to x multiplied by x, that will be x squared, right? This and this here. And then there we're going to have plus 2x, right? And then we're dividing by minus 1. So y should be equals to minus x squared minus 2x, right? And then now we can use the power rule. If we use the power rule, we're going to get y is equals to minus 2x to the 2 minus 1 minus 2x. So we're multiplying by 1 here. For the sake of clarity, let me just write it down, right? And then 1 minus 1. So here we're going to get minus 2x, and then any number to the power 0 is 1. So we just have minus 2x minus 2. So in this question, we're given a cubic function, right? F of x, which is equals to x cubed plus bx squared plus cx plus D. And the first equation 10.1 is saying, let's write down the value of D. Before we even look at our sketch, let's look at our equation and see what D means, right? So here's D here. I just circled it in red. I want you to realize something here, that if you say f of 0, right, you're going to get 0 cubed plus b of 0 squared plus c multiplied by 0 plus d. So f of 0 is going to be 0 cubed, that's 0, plus b multiplied by 0 squared, that is 0, plus c multiplied by 0, that is 0, right, plus d. So f of 0 is basically equals to d. And we know fully well that if we say x of 0, we're looking for the y-intercept, right? So d is the y value of the y-intercept. So let's go to our graph and see what the y value of the y-intercept is. You can see here that c is the y-intercept, right? And then the y value there is 4. So now we can conclude that d is equals to 4. And now we can do 10.2. 10.2 is saying, let's show that b is equals to minus 3 and c is equals to 0, right? So the rule of thumb in math is that if you have two variables, you're going to need two equations. If you have three variables, you're going to need three equations. So since we have two here, let's try and find two equations. So what we can do, we can substitute this point A on our graph f of x, right? So we can say sub A into f of x, right? So if we sub a into f of x, in place of f of x or y, we're going to get 0 is equals to, and then in place of x cube, we're going to have minus 1 cube plus b multiplied by minus 1 squared plus c multiplied by minus 1 plus d. But we know that d is equals to 4, right? So let's solve this. 0 will be equals to minus 1 cube, that will be minus 1, and then minus 1 squared, that will be 1. So we have plus b, and then minus c plus 4, right? So we're gonna have 0 is equals to 3 plus b minus c. So let's make b the subject of the formula, right? So that we don't have to divide both sides by -1 if we make minus c the subject of the formula. So we're gonna get minus 3 plus c is equals to b, right? And then from here we cannot do anything else, so we can name this equation 1. And now we can find another way to find another equation, and then we'll solve simultaneously. So we only have coordinates for point A and C, right? We've used point A. Now let's use point C. But wait a minute, in 10.1 we use point C, right, to find the coordinate of D. So we can no longer use point C as it is. We have to find another way of manipulating point C, right? But then point C is the y-intercept and the turning point at the same time, right? And we know fully well that the gradient at the turning point is equals to 0. So what we can say now is that f prime of x is equals to 0, right? So now we're just going to derivate x, right? Let's not forget x is x cubed plus bx squared plus cx and so on, right? I just circled it in red here. So if we derivate that, x cubed, we're gonna get 3x squared. We just apply in the power rule, right? And then plus 2bx plus cx. If we derivate cx, we're just going to get c, right? And then d, we know that it's 4. It's a constant, so if we derivate that, we get 0, and that will all be equals to 0. The gradient at the turning point is 0, right? But we know the value of x at the turning point, right? It is 0 because c is the y-intercept, right? So we're gonna have 3, and then for the value of x, we have 0 squared plus 2 plus 2b, and then 0 plus c is equals to 0. So you'll see that this here falls apart, right? And then this here falls apart. So now we are only left with c is equals to 0, right? and then this can be our equation 2. Now let's sub equation 2 into equation 1, right? So we're gonna get minus 3 plus, we know that C is 0, is equals to B. So minus 3 is equals to B. And that's exactly what we are asked to prove, right? So yeah, there we go. We just solved the problem. Now let's do 10.3. 10.3 is saying let's determine the equation of the tangent to f at x is equals to 5. So back to the basics. What do we know about a tangent? We know that the equation of a tangent is that of a straight line. Y is equals to mx plus c. If you want to find the equation of a straight line, you're going to need two things. You're going to need the gradient and the coordinates of one point so that you can determine c, right? So to find the gradient, we're gonna use f prime x, right? We're going to derivate f of x and substitute the x value to find the gradient. But then now we have the gradient sorted. How are we going to find the value of c, right? We need a point to find the value of c. We know that we are interested at the point when x is equals to 5, right? So if we substitute 5 into f of x, then we're going to be able to find the y value of that point. So let's, go ahead and do what we're proposing. So f prime x, we have already derivated, right? But then we can do it again. We know that now our equation f of x will be equals to x cubed, right? And then we know that b is minus 3, so we have minus 3x squared, and then c is 0, so this part here falls apart, and then plus d, of which is 4, right? So if we derivate this, we're going to get f prime of x is equals to 3x squared minus 6x, and then plus 4 falls apart with derivating, right? So now we have the equation for the gradient. If we substitute 5, we're gonna get the gradient itself, right? So f prime of 5 is equals to 3 multiplied by 5 squared minus 6 multiplied by 5. So 5 squared, that's 25, multiplied by 3, that is 75. And then 6 by 5, that is 30. And then this should give you 45, right? So the gradient is 45. This is the gradient m, right? So now we have the gradient. Let's find the y value of the point. We know that x is equals to 5 at that point, right? So what we can do here, we can say f of 5 is equals to, now we're substituting into the equation itself, right? 5 cubed minus 3, 5 squared plus 4, right? And then if you put this in your calculator, you should get 54, right? So now we have the point and we have the gradient, right? The gradient, we're saying that it is equals to 45. And then now the point, when x is equals to 5, right? We have 5 and 54 as the corresponding y value. So now we can go ahead and try find the equation of our tangent, right? So we're gonna say y is equals to mx plus c. M is 45, right? X plus c. So let's sub this point 5 and 54. If we do that, we're gonna get 54 is equals to 45 multiplied by 5 plus c. So 54 minus 45 multiplied by 5 should be equals to c. And then if you put that in your calculator, I kid you not, you're gonna get minus 171 is equals to c. So now we can say that y is equals to 45x plus c. C is minus 171. And yippee, we have the equation of our tangent. Yeah, such an exciting problem, such an exciting problem. Let's do 10.4. Let's do 10.4. 10.4 is those kind of problems that, people don't really want to do, but yeah, it's not that bad. So they're saying, for which values of k will f of x equals to k have 2 unequal positive roots and 1 negative root simultaneously? Okay, so let's look at our equation. In this instance, we have one negative root, right? And then one positive root. Basically, when we're speaking about a root, we're just speaking about the x-intercept, right? We have one negative root and one positive root, right? But then how can we shift our graph such that we can get two unequal positive and one negative root, right? So let me show you what you can do. So if you shift your graph slightly down, then let me just finish doing that. If you shift your graph slightly down, then here we're going to have two positive roots, and then here we are still going to have our negative root, right? So if we just shift our graph slightly down, right, then we are good to go. But then if you shift your graph too much, then problem arises. Let me show you what I'm talking about. If you shift your graph to such an extent that it's at this level, then we're going to have one neutral root, because that root will be at 0, right? And then we're also going to have one positive, and that's not what we're looking for. So we are shifting our graph down, but then we should have a limit of how much we shift it down, because if we shift it too low, then issues are going to arise, right? So we have fx is equals to k, right? And then at the roots, the equation should be equals to 0, right? So what we can do here, we can say f of x minus k is equals to 0. So minus k is what is shifting our graph. K is shifting our graph at certain units up or down, right? So let me show you something. Let's say, for instance, k is minus 1, right? If k is minus 1, then we're going to have f of x minus 1, right, is equals to 0. So we're going to have f of x plus 1 is equals to 0. And then you will realize that if we have f of x plus 1, then we are actually moving our graph up, right? And then we don't want that. We want to move our graph down. So that tells us that k has to be greater than 0 in order for us to move our graph down, right? So now what we can say is that let's make sure that k is greater than 0, because if k is less than 0, we are going to have a minus multiplied by a minus, which is going to give us a positive, and we'll actually be moving our graph up, and that's not what we want. So let's make sure that k is greater than 0, right? But then, like I said, we need a limit. We cannot just move the graph infinity units down, right? This situation that we were talking about here, when we have a neutral root, right, and one positive root, this occurs when k is equals to 4, right? When we move our graph 4 units down. And then another thing you should realize is that if we move our graph 5 units down, then our graph just keeps on going down, right? And then we don't have what we're looking for. So we need k to be between 0 and 4, right? If k is between 0 and 4, then our graph will have two unequal positive roots and one negative root simultaneously, and that's what we're looking for. Now we can do 10.5. If this is not so clear, I've done a problem that had something like this. So maybe you want to, visit the channel and look for a cubic function playlist. Let's do 10.5. 10.5 is saying determine the coordinates of the local minimum of g if g of x is equals to f of minus x plus 3. Let me just make our sketch more appealing. So the local minimum if g of x is equals to f of minus x plus 3. So you can see that g of x is the transformation of f of x, right? So let's find the local minimum of f of x and do the transformation, and then we're going to find the coordinates of the local minimum of g. The local maximum of f of x is here at C, and the local minimum is here at B, right? So if we find the coordinates of B, then we can apply the transformation like I'm saying, and then find the coordinates of the local minimum of G. So let's go ahead and find the coordinates of B, right? How do we find the coordinates of B? B is the turning point, so the gradient there is 0, right? So we can say f prime x is equals to 3x squared minus 6x is equals to 0. right? That's what happens at the local maximum and minimum. So now we can take x as a factor, right? So we're going to have x, and then 3x minus 6 is equals to 0. So x is equals to 0, or x is equals to 2, right? You can see here at C that's where we have x is equals to 0, right? So at B, that's where we're going to have x is equals to 2. So the coordinates of B will be 2 and 0 because it is the x-intercept, right? So the corresponding y value is 0. So let's apply the transformation. G of x is equals to f of minus x. So instead of x, for g of x, we have minus x, right? So if we make the transformation to coordinate B, we're gonna get minus 2 and 0. And then apart from that, we have this plus 3 here. And like we were saying on 10.4, that 3 moves the graph up or down, right? So here the y value was 0, and then we're moving 3 units up, right? So instead of B being minus 2 and 0, we're gonna get B being minus 2 and 3. We are given information here about a cubic function f of x. Here's the information here, right? And then they're saying let's use this information to draw the graph, right? Let's indicate all the intercepts with the axis as well as the coordinates of the turning points. So step number 1, when you're doing a question like this, is to determine where all your points lie, right? After you put all your points on the graph, you determine the turning points. After you get the turning points, you're essentially done because you know the general shape of the graph. So let's, go ahead and do that. So we know that when f is 0, right? When f is 0, y is 3, right? So we can put 0 here, and then we know that y is 3 when f is 0, so we're supposed to have a point here. And then when x is minus 3, y is equals to 0, right? So when x is minus 3, y is 0. So we have a point here. Let's indicate it by a cross, right? And then which other point do we have? Let's keep this for now because there we have gradients, right? F prime x. Let's focus on the points. When x is minus 2, y is 5. So here when we have minus 2, y is 5. So we have a point somewhere here, right? And then when x is 1, y is 1. So here let's have 1 for x and 1 for y. So we need another point here, right? And then now we can focus on f prime x. F prime x is the gradients, right? Every time when the gradients are equals to 0, then we know that that is the turning point. So when x is equals to minus 2, we have a turning point, right? But we know that when x is equals to minus 2, the y value is 5. So this point here, which I'm circling, is the turning point. And at 1, we have another turning point. The gradient is 0, right? But we know that when x is equals to 1, y is equals to 1. So here at this point, we have another turning point. So now you can sort of, see how your graph is going to look like. So we have this turning point here. So we're supposed to turn. And then when we come to this point, we're supposed to turn again because it's a turning point, right? And then it keeps going up. And then on this side, it keeps on going down. Now we just have to indicate our coordinates, right? So here we're saying that this is 1 and 1. And here we're saying that this is minus 2 and 5. And here we have 0 and 3. Here at this point, we have minus 3 and 0. And yeah, that's how we construct our graph. You start with the points, you determine the turning points, and now it becomes easy to see what your graph is supposed to look like. And then 11.2.1, it says, let's use the graph to answer the questions below. Determine the values of x for which x multiplied by f of x is less than 0. So x, what is x? X is the value of the x coordinate, right? And then f of x is the value of y. We need values of x for which the product of the two is less than 0. So one has to be positive, and then the other one is negative, or the other one is negative and the other one is positive, so that the product can be less than 0, right? Essentially negative. So let's look at our graph. In the positive x-axis, both x and y are positive, right? So there is no way that can be part of our solution, right? But then let's look at the negative axis. Here between -3 and 0, x is negative, but y is positive, right? So the product of the two will be less than 0. But then if you go below -3, then both y and x are negative, so the product will be greater than 0. So we only need the x to be between -3 and 0. If x is between -3 and 0, then x multiplied by f of x will be less than 0. And then 11.2.2 says if g of x is equals to minus f of x, write down the coordinates of the local minimum of point G. The coordinates of the local minimum of point G will be -2 and -5. Why am I saying that? Watch this video in the screen right now. So this is another question on the past trial examination, September 2021, grade 12 mathematics. So we have the word pandemic. So let me just write down the word. We have the word pandemic. And then 12.1 is saying that how many unique arrangements of the letters can be made, right? How many unique arrangements of the letters can be made? So let's look at our word. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different letters. And how can we arrange these 8 different letters? So let me create spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8. So in the first position, there's 8 possible letters you can put in the first position when you're arranging the letters. So we have 8 possible ways in the first position. And then in the second position, because you've already placed one letter, you have 7 positions, 7 letters that can fill that position. So we have 7. And then on this third position, you have 6 letters that you can put in that position. You can see the trend now. So here you're going to have 5, 4, 3, 2, 1. So basically you have 8 factorial ways which you can arrange these 8 different letters. And then 12.2 says determine the number of unique arrangements of the letters that are possible if each arrangement must start with the letter P and end with the letter C. So fine. Let's have 1, 2, 3, 4, 5, 6, 7, 8. Right? On the first letter, they're saying that let's start with P. It's a must. And then on the last letter, let's have C. It's a must. How many ways can you arrange the letters in this word if the first letter is P and the last letter is C? So here on the first position, we only have one possible letter, which is P, right? So we have 1. And then on the second position, there are 6 possible letters because of the 8, one letter is in position 1 and then one letter is in the last position. So this second position, we have 6 possible letters that we can place there. And then on the second position, we have 5 possible letters because we have exhausted 3. And then on the fourth position, 4, 3, 2, 1, right? So we have 1 multiplied by 6, 5, 4, 3, 2, 1. So that's basically 6 factorial. And then the last letter is C. We only have one C. So that will be 1. So 12.2, we have 1 multiplied by 6 factorial multiplied by 1. Right? This one is because the first letter has to be P and we only have 1 P. And then this one, the last letter has to be C and we only have 1 C. And then the letters in the middle, we have 6 letters remaining and 6 positions. So we can arrange them in 6 factorial ways. And then 12.3. Calculate the probability that randomly chosen unique arrangements of the letters will start with the letter P and end with the letter C. So the probability of an event A is equals to the number of possible ways event A can occur divided by the sample space. What is the number of possible ways that the arrangement of letters can start with P and end with C? That is the answer to 12.2, right? 1 multiplied by 6 factorial multiplied by 1. But then what are the possible arrangements of the letters if we don't have any restriction? If we don't have any restrictions, we have 8 factorial ways we can arrange the letters. So we basically have 6 factorial divided by 8 factorial. And that is equals to 1 divided by 56. Each passenger on ABC Airways flight chose exactly 1 beverage from tea, coffee, or fruit juice. The results are shown in the table below. We have male, female, we have tea, coffee, fruit juice, and then the totals. 13.1 says write down the value of A. We can see here that 60 is the total number of males, and then 100 is the total number of females, and then A is the total number of males and females. So we say in 60 plus 100, which is equals to 160. Or you can add these columns going down. You're going to have 60 plus 80 plus 120, which is also equals to 160. And then 13.2 says determine the probability that a randomly selected passenger is male. We know fully well that the probability of event A is equals to the number of ways A can occur divided by the sample space, right? The sample space being the total, so to say. So we want the probability of selecting a passenger that is male. So how many males do we have? We've already established here that we have 60 males, right? Is the total number of males. So we're going to have 60 divided by the total number of passengers in the flight, right? So we have 60, which is the males, plus 100, which is the females. So the probability of picking a person in random and that person being a male will then be equals to 3 divided by 8, which you can convert to decimals and even a percentage. 13.3 says given that the event of a passenger choosing coffee is independent of being a male, calculate the value of B. So keyword independent, right? So if we have independent, then we have situations where the two are dependent. So let's address independent first. So if the events are independent, then the probability of A and B will be equals to the probability of A multiplied by the probability of B. But then if the events are dependent, and the probability of A and B will be given by the probability of A multiplied by the probability of B given A, right? Given that A occurs. So here we have an independent event, so we're going to stick to this. But then if we had a dependent in a different situation, then you do what we say in here. So let's go to our table and look at B, right? B is the probability of a male choosing coffee. So probability of being a male and choosing coffee, it will be equals to the probability of being a male multiplied by the probability of choosing coffee, right? From our formula here for independent events. So we have B divided by the sample space, which is 160, being equal to the probability of being a male. We already said that that is 60 divided by 169. So we have 60 divided by 160 multiplied by the probability of choosing coffee. So let's look at the total number of people that picked coffee, right? So we have coffee here, and then we just go on a straight line, and here's the total. So 80 people picked coffee. So we're going to have 80 divided by 160. So we're basically solving for B. So we're going to have B being equals to 60 divided by 160 multiplied by 80 divided by 160 multiplied by 160. We're multiplying by 160 on both sides so that we can find B. Yeah, so basically we're going to have B is equals to 30.
Let's go ahead and solve for x. 1.1.1, we have x squared plus x minus 12 being equals to 0. Which two numbers do we multiply and get minus 12? And when we add them, we get plus 1, the coefficient of x. That is minus 3 and plus 4. So we're going to have x minus 3 multiplied by x plus 4 being equals to 0. X is equals to 3 or x is equals to minus 4. Just like that, we have answered 1.1.1. Let's go ahead and take a look at 1.1.2. We're supposed to solve for x correct to 2 decimal places. We know that we are going to use the quadratic formula. We have 3x squared minus 2x being equals to 6. So 3x squared minus 2x minus 6 should be equals to 0. We just write in the equation in our standard format. X is equals to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Let's go ahead and substitute. B is the coefficient of x, which is minus 2, plus or minus b squared, again minus 2 squared, minus 4ac. A is 3 and c is minus 6. C is the constant and a is the coefficient of x squared. We are supposed to divide everything by 2a. We know that a is 3. So x will be equals to minus multiplied by minus 2. That will be plus 2. Plus or minus the square root of b squared minus 4ac. 4 plus 72 is 76. Everything divided by 6. So x is equals to 1.79 or x is equals to minus 1.12. When you substitute these values of x back into your equation, it's going to be satisfied. You're going to get 6 on both sides. 1.1.3, we have the square root of 2x plus 1 being equals to x minus 1. This question is a very basic question. It is always there in the final exam. We're going to square both sides. We're going to have the square root of 2x plus 1 squared being equals to x minus 1 squared. So on the left hand side, we're going to have 2x plus 1. The square root and 2 just cancels out, being equals to x minus 1 squared. X multiplied by x, that is x squared. X multiplied by minus 1, that is minus x. You multiply that by 2, you're going to get minus 2x. And then minus 1 multiplied by minus 1, that is plus 1. We're going to have x squared minus 4x. If you take 2x to the right hand side, it's going to be minus 2x, which is minus 4x. And then 1 minus 1 is 0. So x squared minus 4x is equals to 0. We can take x as a common factor. We're going to have x minus 4 being equals to 0. In this case, it's either x is equals to 0 or x is equals to 4. Let's do 1.1.4. So in 1.1.4, we have x squared minus 3 being greater than 2x. So if we take 2x to the left hand side, we're going to get x squared minus 2x minus 3 being greater than 0. Let's go ahead and find our critical values. X squared minus 2x minus 3 is equals to 0. We're not changing the equation. We just want to find our critical values. After finding our critical values, we will take care of the inequality. Now we just want to find our critical values. So how can we factorize this? Two numbers of which when we multiply we get minus 3, and when we add we get minus 2. That is minus 3 and plus 1. So x minus 3, x plus 1 is equals to 0. So x is equals to 3, or x is equals to minus 1. These are our critical values. So if you've been watching my other videos, you know the two possible answers we're going to have here. Is either x lies between minus 1 and 3, or x is greater than 3, or x is less than minus 1. These are the two possible solutions we can possibly have. We are going to test and see which one between these two is correct. So let's go ahead and test this first one. How can we test that one? We take a number between minus 1 and 3 and see if our equation is going to be satisfied. If our inequality, not equation, right? So let's take 1 as it is between minus 1 and 3. We are substituting it into the equation we started with, the inequality I meant. So we're going to have x squared minus 3 being greater than 2x. If we substitute 1, we're going to have 1 squared minus 3 being greater than 2 multiplied by 1. So 1 squared 1 minus 3 minus 2 is greater than 2. Obviously, this is not correct. So it tells us that our answer is not between minus 1 and 3, but rather x is greater than 3 or x is less than 1. So this is our correct answer. This is wrong. Right, that is one way of solving an inequality. Anyway, stories 1.2. Let's do 1.2 and 1.3 on a separate video. Let's solve for x and y simultaneously. I have x plus 2 being equals to 2y. And I have 1 divided by x plus 1 divided by y being equals to 1. Well, on this equation, I can make x the subject of the formula. I'm going to have x being equals to 2y minus 2. Let's take our attention to the other equation. If we multiply the left-hand side by x and multiply the right-hand side by x, we're going to have 1 plus x divided by y being equals to x. In place of x, we can go ahead and substitute 2y minus 2. We're going to have 1 plus 2y minus 2, everything divided by y being equals to 2y minus 2. So we're going to have 1 plus 2y divided by y minus 2 divided by y being equals to 2y minus 2. 1 plus y and y cancels out, we are left with 2. Minus 2y being equals to 2y minus 2. We can multiply the left-hand side and the right-hand side by y. If we do that, we're going to get y plus 2y minus 2. Y and y are going to cancel out, being equals to 2y squared minus 2y. We're going to have 2y squared minus 5y plus 2 being equals to 0. If we factorize this, we can do that without using the quadratic formula. We're going to have minus 2 and minus 1. If we multiply out, we shall get 2y squared minus 5y plus 2. This is all equals to 0. So y can be equals to 1 divided by 2, or y can be equals to 2. If y is equals to 1 divided by 2, then what will be the value of x? X will be equals to 2 multiplied by a half minus 2. 2 multiplied by a half, that is 1, minus 2, we get minus 1. And then if y is equals to 2, then x will be equals to 2 multiplied by 2 minus 2. This is just equals to 2. Well, let's play around with those values and see if they check out. Y is equals to f and x is equals to minus 1. We're going to have minus 1 plus 2. This is obviously 1. And then 2 multiplied by a half is also equals to 1. So our equation is satisfied when you use those two values. Let's now check when y is equals to 2 and x is equals to 2. Let's use the other equation. When that is the case, we're going to have 1 divided by 2 plus 1 divided by 2, which is 1, which is equals to 1, like we are supposed to show. So that checks out. Let's go ahead and do 1.3. 1.3 given 2 to the power m plus 1 plus 2 to the power m being equals to 3 to the power n plus 2 minus 3 to the power n, where m and n are integers. Where m and n are integers, determine the value of m plus n. I think I've solved a similar question before. Let's go ahead and give it a try. Well, I want to get rid of this 2 to the power m plus 1. I know fully well that it is equals to 2 to the power m multiplied by 2 to the power 1. Because if we multiply in numbers of the same basis, we can add the exponents. So 2 to the power m plus 1 is just 2 to the power m multiplied by 2 to the power 1 plus 2 to the power m. Let me just try out the same idea on the right hand side. So I'm going to have 3 to the power n multiplied by 3 to the power 2 minus 3 to the power n. On the left hand side, I'm going to take 2 to the power m as a common factor. I'm going to have 2 to the power 1 plus 1 being equals to, I'm taking 3 to the power n as a common factor on the right hand side. So 3 to the power n, and then I'm going to be left with 3 to the power 2 minus 1. 3 to the power 2 is 9 minus 1 is 8, right? But we can write 8 as 2 to the power 3. So let's run with that idea. We're going to have 2 to the power m multiplied by 2 to the power 1, that's 2, plus 1 is 3. So we have 2 to the power m multiplied by 3, being equals to 3 to the power n multiplied by 8, which is just 2 to the power 3. Let's not forget that we have 1 here. If m is equals to 3 and n is equals to 1, the left hand side and the right hand side are going to be equals to each other. So we can say that m is equals to 3 and n is equals to 1. When this is the case, the left hand side is indeed equals to the right hand side. I think they're supposed to be equals to 24 or something. So what will be m plus 1 when m is equals to 3 and n is equals to 1? That is 3 plus 1, which is just equals to 4. Let's see if we can write down the general term of this series. So we have 3 plus 6 plus 12, our geometric series. The general term of a geometric series, it is given by Tn is equals to ar to the power n minus 1. A is the first term. The first term in our case is 3. R is T2 divided by T1 or T3 divided by T2. We just divide the two terms that are next to each other. So here, if we divide T2 by T1, we're going to have 6 divided by 3, which is equals to 2. So we have A, we have R. Tn will be equals to A, which is 3, R, which is equals to 2 to the power n minus 1. So this is the general term of this series. Let's move to 3.1.2. So in 3.1.2, we're supposed to calculate the value of k such that this sum is equals to 98,301. Okay, let's go ahead and find the terms of our series. So the first term, T1, will be equals to 3 divided by 2, 2 to the power p. P is starting at 1, right? So when P is equals to 1, we're going to have 2 divided by 2, so T1 is equals to 3. And then T2, we're going to have 3 divided by 2, and then 2 to the power 2. 2 to the power 2 is 4, so we're going to have 4 multiplied by 3, which is 12. 12 divided by 2 is 6, so that is T2. And then T3 is equals to 3 divided by 2, 2 to the power 3. 2 to the power 3 is 8. So we have 8 multiplied by 3, 8, 16, 24. So we have 24 divided by 2, which is equals to 12. So it seems like we just have 3 plus 6 plus 9. We're supposed to find the value of K, for which this sum is equals to 98,301. How can we possibly do that? We have a formula for the sum of a geometric series, while a finite and an infinite. In our case, we're going to have the sum being equals to a multiplied by r to the power n minus 1 divided by r minus 1. You cannot use sum to infinity is equals to a divided by 1 minus r in this case, because r is not between minus 1 and 1. Okay, so what is the value of n for which we're going to have a sum of 98,301? Let's find out. A is the first term, which is 3. R is the common ratio, which is 2. So 2 to the power n minus 1, everything divided by r minus 1. So that is 2 minus 1, which is just 1. Okay, so we're going to have 2 to the power n minus 1 being equals to 98,301 divided by 3. Okay, let me put that in my calculator real quick. I'm getting 2 to the power n minus 1 being equals to 32,767. If I take minus 1 to the right hand side, I'm going to get 2 to the power n being equals to 32,768. I don't know whether I can write this number with a base of 2 or not, but it is just going to waste my time trying to figure that out. I'm just going to go ahead and take log on both sides. If I do that, I'm going to get n log of 2 being equals to log of 32,768. So I can just divide both sides by log of 2, right? So 32,768, everything divided by log of 2. So let me go ahead and put that in my calculator and see what I have. So 32,768 divided by log of 2. So n is equals to 15. The value of k is supposed to be equals to 15, such that we have a sum of 98,301. N is equals to k minus p plus 1. N is 15. K, p is 1 plus 1. So it's easy to see that 15 is equals to k. Right, so that is 3.1.2. Let's go ahead and do the last question, 3.2. So in 3.2, let's hear the stories. A geometric sequence and an arithmetic sequence have the same first term. Okay, so let's have arithmetic and have geometric. Okay, they have the same first term. So we have a and a. T1 is equals to a. This a is the same, right? And then the common ratio of the geometric series is 1 divided by 3. So common ratio r is equals to 1 divided by 3. And then the difference on the arithmetic is equals to 3. And then the stories carry on. The sum of 22 terms of the arithmetic sequence is 734, more than the sum to infinity of the geometric sequence. Okay, let's make sense of that mathematically. The sum of the 22 terms of an arithmetic sequence is 734, more than the sum to infinity of the geometric. So, okay, S22 should be equals to S infinity plus 734. That is how I'm interpreting the question. Okay, but what is sum on an arithmetic series or sequence, whatsoever we're dealing with here? We have n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. And then the sum to infinity is a divided by 1 minus r plus 734. Okay, let's go ahead and substitute. N is equals to 22. So we're going to have 22 divided by 2 multiplied by 2a. So we have 2a is a. That's what we're interested in actually. And then plus n minus 1. So 22 minus 1 multiplied by d, which is 3. Okay. This is equals to a divided by 1 minus 1 divided by 3 plus 734. Okay, we have to solve this now. So we're going to have 11 multiplied by 2a. Then 22 minus 1 is 21. So we're going to have 21 multiplied by 3. Is that 63? Okay, so we have plus 63 minus... Okay, no, that's it. 21 multiplied by 3. 2a plus 63. This is equals to a divided by, what is 1 minus 1 divided by 3? That is 2 divided by 3. Okay, so if we say 1 divided by 2 divided by 3, we're going to get, instead of writing a there, let's instead write 3 divided by 2a plus 734. Okay, let's multiply out on the left hand side. We're going to get 22a plus 63 multiplied by 11. That is 693, being equals to 3 divided by 2a plus 734. Let's take the a's to the left hand side and the constants to the right hand side. Okay, the a's to the left. So we have 22a minus 3 divided by 2a being equals to 734 minus 693. So what is 22 minus 3 divided by 2? We have 41 divided by 2a being equals to 734 minus 693, which is 41. Okay, so a is equals to, I have 41 divided by 41 divided by 2. A is equals to 2. Did you get the same answer? Just let me know in the comments. Write down the equation of the asymptote of f, that is 4.1. We have f of x being equals to 2 to the power x minus 4. We're looking for the asymptote of this function. Let me show you something. In order for f of x to be equals to minus 4, we would need 2 to the power of x to be equals to 0. And that is actually impossible. We get very close to 0, but we never touch 0. So that tells us that our asymptote is that y is equals to minus 4, because our graph cannot touch y is equals to minus 4, because 2 to the power x will never be equals to 0. We just get close to 0, but we never actually get there. 4.2. That is where the idea of a limit actually comes in. Anyway, stories. Let's determine the coordinates of B. We are told that A and... What's happening? We're told that A and B are y and x intercepts respectively. So A is the y-intercept, so x equals to 0, and we have some y. And B is the x-intercept, and y is equals to 0. F of x is equals to 2 to the power x minus 4. If we substitute the coordinates of B, x and 0, in attempt to find x, we're going to have 0 being equals to 2 to the power of x minus 4. If we take minus 4 to the left hand side, we're going to have 2 to the power x being equals to 4. But we can write 4 as 2 to the power of 2. It is easy to see that x is equals to 2. So the coordinates of b, we have 2 and 0. Let's go ahead and do 4.3. In 4.3, we're supposed to determine the equation of k, a straight line passing through a and b in the form k of x is equals to. Well, if it is a straight line, then this is mx plus c. We need the gradient. After finding the gradient, we can substitute b or a to find c. How can we find the gradient? We need 2 points. Well, for b, we know that we have 2 and 0. If we can find the coordinates of a, we're going to be able to determine the gradient of k of x. So the coordinates of a, we have x is equals to 0 and it's a unknown y value. If we substitute that into f of x is equals to 2 to the power x minus 4. We're going to get y being equals to 2 to the power 0 minus 4. Any number to the power 0 is 1, so we have 1 minus 4, which is minus 3. So the coordinates of a, we have 0 and minus 3. If we go ahead and find the gradient, we'll get y2 minus y1 divided by x2 minus x1. We have b and a. If we take a as our second point, we're going to have minus 3 minus 0. The y value of a minus the y value of b divided by 0 minus 2. So this is just equals to 3 divided by 2. So that is the gradient of k of x. We can say that k of x is equals to 3 divided by 2x plus c. Let's substitute either a or b to find the value of c. If we substitute b, b is 2 and 0. We're going to have 0 being equals to 3 divided by 2 multiplied by 2 plus c. 2 and 2 cancels out. We have 2 being equals to 3 plus c. It is obvious c is equals to minus 3. So we can conclude and say that k of x is equals to 3 divided by 2x minus 3. Is this equation true? Is it correct? Let's find out. Let's substitute the x value of a. If we substitute 0, we're going to get 3 divided by 2 multiplied by 0 minus 3. So this is just equals to minus 3. Well, it seems like it works out. Let's go ahead and do 4.4. So in 4.4, we want to calculate the vertical distance between k and f at x is equals to 1. The vertical distance between k and f. Right, we are looking for the distance, not the displacement. Okay, so if we're looking for the displacement, it would matter whether we're seeing f of x minus k of x, but if it is the distance, it doesn't matter. Even if we get a negative value, we would just quote it as a positive value because distance is not a vector, but it is a scalar. Anyway, let's get on. But if you connect a and b, you should be able to see that k of x is above f of x between a and b. And that is where x is equals to 1 lies. X is equals to 1 is between a and b. So the distance will be equals to k of x minus f of x. Well, k of 1 minus f of 1, because that's the point we're interested in. So k of x, we're going to have 3 divided by 2. We are interested at x is equals to 1 minus 3 minus f of x, 2 to the power 1 minus 4. So 3 divided by 2 multiplied by 1, that is 3 divided by 2, which is 1.5. So we have 1.5 minus 3. That should be minus 1.5. So we have minus 1.5. Minus 2 to the power 1. 2 to the power 1 is 2. 2 minus 4, it is minus 2. So we have minus 1.5 plus 2, which will be plus 0.5 units. So that is the distance between k of x and f of x. Let's move to 5.5. In 5.5, not 5.5, but 4.5. We're supposed to write down the equation of g if it is given that g of x is equals to f of x plus 4. So g of x will be equals to, what is f of x? This is 2 to the power x minus 4 plus 4. Minus 4 plus 4, so g of x is just equals to 2 to the power x. Right, and 4.6, let's write down the domain of g inverse. So the range of g of x is equals to the domain of g of x. So what is the range of g of x if g of x is equals to 2 to the power x? Well, the range y is an element of 0 to infinity. It cannot touch 0, but it cannot touch infinity also. We know that for sure. So this is the range of g of x. So the domain of g inverse x will be an element of 0 to infinity. That's how it works. That's all we have to do. And 4.7, we actually need to find the equation of g inverse. G of x is equals to 2 to the power x. To find the inverse, you swap x and y and make y the subject of the formula. In this case, we're going to have x being equals to 2 to the power y. If we want to bring y down, we have to take a log on both sides. If we do that, we're going to have y a log of 2. That is a log law. You are allowed to do that. What you want to do at this point is to divide both sides by log of 2. We're going to have y being equals to log of x divided by log of 2. What is log of x divided by log of 2? That is log of x base 2. If you get 18 out of 18 in this question, then your math is really good. Let me show you why I say that. So we have the graphs of f and g that are drawn below. A point of intersection of f and g is B, the turning point of f. The graph f has x-intercepts minus 3 and x is equals to 5 and the y-intercept at C. The first question, 5.1, let's write down the coordinates of the turning point of f. Well, we are told that f of x is equals to minus 1 divided by 2 multiplied by x minus 1 squared plus 8. When your equation is written in this format, 1 will be the x value of your turning point and 8 will be the y value of your turning point. So the coordinates of B, the turning point of f, is x is equals to 1 and y is equals to 8. That's pretty much basic. It's not a difficult question whatsoever. Let's go ahead and do 5.2. In 5.2, we're looking for the x coordinate, for the coordinates of C, not the x coordinate. C is the y-intercept of f. So y-intercept, I know x is equals to 0. If I go ahead and substitute x is equals to 0 into f of x, I'm going to have minus 1 divided by 2 multiplied by 0 minus 1 squared plus 8. Let's take a look at this. 0 minus 1, that is minus 1. You square that, you get 1. So we have minus 1 divided by 2 plus 8, which will be 7.5. 7.5, I think we can write it as 13 divided by 2 instead. So the coordinates of C, we have an x value of 0 and a y value of 13 divided by 2. 13 divided by 2 is 6.5 and not 7.5. So we're supposed to have 15 divided by 2 instead. Let's go ahead and do 5.3. Calculate the value of D. D is a variable on g of x. Well, we know that g of x is equals to D divided by x. We are told that g of x and f of x, they touch at B. So B is a point on G of X. But lucky for us, we've already determined the coordinates of B. The X value is 1 and the Y value is 8. If we substitute that into G of X, of which we can do with no issues whatsoever because B lies on G of X and F of X, we're going to have 8 in place of the Y value being equals to D divided by X, which is 1. It should be easy to see now that D is equals to 8. So basically, G of X is equals to 8 divided by X. That is 5.3. Seems like all is going well. 5.1, 5.2, 5.3. Let's see what happens in 5.4. In 5.4, we're looking for the range of G. G of X is equals to 8 divided by X. Well, if X is positive, we're going to have all positive Y values, obviously, except from 0 and infinity. In order for G of X to be equals to 0, we need X to be equals to 0. And we cannot divide by 0. So basically, G of X cannot touch 0. So we know that 0 to infinity is part of our solution. And then let's look at when X is negative. When X is negative, we run from minus infinity to 0. We cannot touch 0 even. The range of G of X is just minus infinity to 0 and 0 to plus infinity. So that is the range of G of X. It's not really hard to see. The only thing you need to realize is that G of X cannot be equals to 0. So basically, you can say that Y is an element of real numbers, but Y is not equal to 0. 5.5, we're looking for the values of X for which F of X multiplied by G of X is less or equals to 0. Right, F of X is our parabola and G of X is 8 divided by X. So let's talk about this 8 divided by X first. When X is positive, 8 divided by X is positive. When X is negative, 8 divided by X is negative. That is very important to point out. I'm going to show you why. But we know fully well that in our solution, we cannot include X equals to 0. Whatever interval we can have, it must not include X is equals to 0 because G of X is not defined at that point. We need to be aware of that. Well, let's go to our graph. Let me show you something. Okay, so between minus 3 and 5, F of X is positive. Between minus 3 and 5. And then minus 3, minus 4, minus 5 going to minus infinity, F of X is negative. And then from positive 5, positive 6 going on and on, F of X is negative. That is important to point out. Okay, let's look at minus 3 to minus infinity and see what is happening. So from minus 3 to minus infinity, both F of X and G of X are negative. As you can clearly see here, both G of X and F of X will be negative. If we multiply two negative numbers, then our answer is going to be greater than 0. So minus 3 to minus infinity is not our solution because F of X multiplied by G of X will be greater than 0. Let's look at minus 3 to X is equals to 0. From minus 3 to X is equals to 0, F of X is positive and G of X is negative. So minus 3 to positive 0 is part of our solution. We can include minus 3 because both F of X and G of X are defined, but we exclude 0 because G of X is not defined at 0. So that is part of our solution. Now let's look at 0 and 5. Between 0 and 5, F of X is positive, as you can clearly see, but G of X is also positive. So that cannot be part of our solution. If we multiply those two functions between 0 and 5, our answer is going to be greater than 0, and that's not what we're interested in. Let's look at x is equals to 5 to positive infinity. X is equals to 5 to positive infinity. F of x is going to be negative, and g of x is going to be positive. Negative multiplied by positive, that is negative, and it will satisfy our inequality. So what are we saying? We're saying that we are also interested in the part where x is between 5 and infinity, but including 5. We can include 5 because both f of x and g of x are defined. So yes, this is our solution for 5.5. Between minus 3 and 0, f of x multiplied by g of x will be less or equals to 0. Same is true between 5 and infinity. That is our answer to 5.5. Let's go ahead and do 5.6. 5.6 and 5.7, that's where things start getting a bit interesting, but there ain't nothing to it but to do it. Let's take a look. Calculate the values of k such that h of x is equals to minus 2x plus k will not intersect the graph of g. Right, we have h of x being equals to minus 2x plus k, and g of x being equals to 8 divided by x. So we're looking for the values of k for which h of x will not be equals to g of x. Well, let's say you've never seen a problem like this before. What are you most likely to do? You're most likely to start by saying h of x is equals to g of x. If we were to substitute here, we will get minus 2x plus k being equals to 8 divided by x. Obviously, this x is a disturbance, so let's multiply out by x. If we do that, we get minus 2x squared plus xk being equals to 8. X and x will cancel out, right? Writing this in standard format, we're going to have 2x squared minus xk minus 8 being equals to 0. I think most people will probably get to this point, but now you're stuck. You don't know how to carry on anymore. Well, as you can see, this is a quadratic equation. We're looking for values of k for which the two graphs won't touch. So basically, what you have to do, you have to find the discriminant of this quadratic equation. Let me show you how. The discriminant is equals to b squared minus 4ac. You know that your quadratic equation is not going to have solutions if the discriminant is less than 0. There's no square root of a negative number. So if the discriminant is less than 0, then your quadratic equation is not going to have any solution. So we are interested in the values of k for which this quadratic equation is not going to have any real solutions. And in doing that, we have essentially solved our problem. We have the values of k for which the two functions h of x and g of x will not intersect. Right, that is a lot to digest, so maybe you need to rewind a bit and listen to it again. But anyway, stories. The discriminant is equals to b squared minus 4ac. We're interested in the case where b squared minus 4ac will be less than 0. Well, in our case, b is minus k, right? The coefficient of x. So we have minus k squared minus 4ac. C is A, not C. A is 2 and C is minus 8, less than 0. So minus k squared, that will be k squared. There's a mistake I'm making, I'm only realizing it now. This is supposed to be plus 8 and not minus 8. When I take 8 to the left hand side, it is going to be minus 8. And then when I multiply out by minus 1, then it will be plus 8. So this is actually plus 8 and not minus 8. Right, so we're going to have k squared minus 64 being less than 0. If we take 64 to the other side, we're going to have k squared being less than 64. Let's go ahead and find our CV critical values. So k squared is equals to 64, k is equals to 8, or k is equals to minus 8. The solution to this inequality, we have k being between minus 8 and positive 8. It has to be greater than minus 8 but less than positive 8. So these are the values of k for which h of x will not intersect g. 5.6. Let's do the last one. Let's do 5.7. So in 5.7, h is a tangent to g at r, a point on a point in the first quadrant. Calculate t such that y is equals to f of x plus t intersect g at r. So we are interested at f of x plus t is equals to g of x. We want to find the value of t for which f of x plus t is equals to g of x. How can we possibly do that? Let's look at the information we have. We are told that h is a tangent to g at r. H of x is equals to minus 2x plus k. This is the gradient of h of x. So basically, we have the gradient of h of x at r, right? It is equals to minus 2 because h of x is the tangent to g at r. So what are we saying? We're saying that if you derivate g of x and equate to minus 2, you can find the x value at r, the point we're interested in. Let me show you how. So we want to derivate g of x. Let's start by saying g of x. So g of x is equals to 8 divided by x. But this is the same as saying 8 multiplied by x to the minus 1, right? So if we go ahead and derivate this using the power rule, we're going to get minus 8 multiplied by x to the minus 2. But we know the gradient at r. The gradient at r is minus 2. So now we're interested in finding the x value at r. So we're going to say minus 8. We can take x to the minus 2 back to the denominator, which will be x to the power 2. If we cross multiply here, we get 2x squared is equals to 8. We divided both sides by minus 1 at the same time. Right. So 2x squared is equals to 8. Dividing both sides by 2, x squared is equals to 4. X is equals to 2. So the x value at r is 2. But we can take that a step forward. We can also find the y value at r because we have the equation g of x. So the y value at r, we're going to have 8 divided by x, which happens to be 2. So that is 4. The coordinates of r, we have 2 and 4. We are almost done. That is what you actually have to figure out. As soon as you figure that out, then it becomes extremely simple. Right, let me show you why I'm saying that. We have y being equals to f of x plus t. But y at r is 4. So we're going to have 4 being equals to f of x. X is 2. So that will be minus 1 divided by 2, x minus 1. So that is 2 minus 1 squared plus 8 plus t. So 4 is going to be equals to 2 minus 1 squared, that is 1. So we just have minus 1 divided by 2 plus 8 plus t. So 4 is equals to, what is minus 1 divided by 2 plus 8? That is 7.5, which is just 15 divided by 2. So we have 15 divided by 2 plus t. T should be equals to 4 minus 15 divided by 2, which is just equals to minus 7 divided by 2. Determine f prime of x from first principles. If 7.1 f of x is equals to minus 4x squared. From the power rule, we know fully well that f prime of x should be equals to minus 8x using the power rule. But we're supposed to use first principles. So we're going to have f of x being equals to the limit as h tends to 0 of f of x plus h minus f of x, everything divided by h. So let's go ahead and determine f of x plus h separately. If we do that, we're going to have f of x plus h being equals to minus 4. In place of x, we are substituting x plus h. So we're going to have x plus h squared. This will be equals to minus 4 multiplied by x squared plus 2xh plus h squared. This is just equals to minus 4x squared minus 8xh minus 4h squared. Right, so that is f of x plus h. If we include also minus f of x, we can say that f of x plus h minus f of x is equals to minus 4x squared minus 8xh minus 4h squared minus f of x, which is minus 4x squared. So as you can see, minus 4x squared minus 4x squared, that is 0. So f of x plus h minus f of x is just equals to minus 8xh minus 4h squared. If we substitute it back into our equation, we're going to have f prime of x being equals to the limit as h tends to 0 of minus 8xh minus 4h squared, everything divided by h. If we take h as a common factor on the denominator, on the numerator I meant, we're going to have h multiplied by minus 8x minus 4h, everything divided by h. If h and h cancels out and we let h turn into 0, we're going to have minus 8x minus 0 basically. So f prime of x is just equals to minus 8x, which is the same solution we get to using the power rule. So yeah, we are convinced that 7.1 we have it correct, all the 5 marks. Let's move to 7.2.1. 7.2.1, we're supposed to determine f prime of x if f of x is equals to 2x to the 3 minus 3x. Out of 2 marks, we're just going to use the power rule. The power rule states that if we have some g of x, which is equals to ax to the b, then g prime of x will just be equals to b multiplied by ax to the b minus 1. If we go ahead and apply this same idea on f of x, we're going to have 3 multiplied by 2 to the power multiplied by x to the power 3 minus 1 minus 1 multiplied by 3 x to the power 1 minus 1. So f prime of x will be equals to 3 multiplied by 2, that is 6. So we have 6x squared minus 1 multiplied by 3, that is 3. X to the power 1 minus 1 is x to the power 0. Any number to the power 0 is 1. So our answer here is 6x squared minus 3. Let's see, does it make sense? 6x squared minus... Yeah, I think it checks out. So that is 7.2.1. Let's take a look at 7.2.2. Well, a question like 7.2.2, 7.2.1, and 7.1, you know they're going to be there in your final exam. The variables, the numbers are going to change, but the technique is the same. Well, let's look at 7.2.2. So we have dx and 7 multiplied by the square root of x squared. We have that 3 up there plus 2x to the minus 5. Right, so let's just rewrite this nicely in the following way. We're going to have 7x to the power 2 divided by 3. Yes, we can bring this 3 right here. We are allowed to do that. Plus 2x to the minus 5. Seems like everything is in standard form now. We can go ahead and derivate. So we're going to have 2 divided by 3 multiplied by 7 x to the power 2 divided by 3 minus 1 plus minus 5 multiplied by 2 x to the minus 5 minus 1. So what is 2 divided by 3 multiplied by 7? That is 14 divided by 3 x to the power 2 divided by 3 minus 1. That is minus 1 divided by 3. And then minus 5 multiplied by 2 minus 10 x to the minus 6. Well, let me check if I'm not making any mistake. 2 minus 5 minus 10 x to the minus 6. So this is correct. Let's check this one. Okay, 7x to the 2 divided by 3. This is fine. And then I multiply 7 by 2 divided by 3. I think all is well. I think all is well. We can move ahead and do 7.3. You can let me know if all is not well in the comments. So 7.3 is very similar to 2.2.3, where we're supposed to find the values of n for which a quadratic pattern is increasing. So here we're supposed to find the values of x for which the tangent to minus 2x to the 3 plus x will have a positive gradient. Right, so f of x is equals to minus 2x to the 3 plus 8x. The equation of the tangent is given by f prime of x will be equals to. So we're just derivating using the power rule. We're going to have minus 6x squared plus 8. So we're looking for values of x for which minus 6x squared plus 8 is greater than 0, right? Because that's where the gradient will be positive. This equation is the equation of the gradient of f of x. Right, so let's go ahead and solve that. We're going to have minus 6x squared being greater than minus 8. We're taking plus 8 to the right-hand side. We're going to divide both sides by negative 1. If we divide by negative 1, the sign of the inequality changes, right? So we're going to have 6x squared being less than 8. Dividing both sides by 6, we're going to get x squared being less than 4 divided by 3. We can go ahead and find our critical values. We're going to have x being equals to the square root of 4 divided by 3 plus, or x being equals to minus the square root of 4 divided by 3. But if you go ahead and evaluate, x is between minus the square root of 4 divided by 3 and plus the square root of 4 divided by 3. If you substitute any value between minus the square root of 4 divided by 3 and plus the square root of 4 divided by 3, indeed the gradient is going to be positive. So this is the answer to 7.3. When x is between these two values, the gradient is positive, which makes sense because our the function of the gradient of f of x is going to look something like this. For only a few values of x will this function be greater than 0. Determine the coordinates of the turning points of f. Okay, so we have f of x, which is equals to minus x to the power 3 plus 6x squared minus 9x plus 4. In order to find the coordinates of the turning points, we need to derivate and equate to 0. That is because the gradient at the turning point is equals to 0. So if we derivate f of x and equate to 0, then we're going to find the x values at the turning points, substitute them into f of x, and find the corresponding y value. So let's go ahead and do that. F prime of x will be equals to, so we just simply apply in the power rule here. We're going to get minus 3x squared plus 12x minus 9. Right, and then minus 3x squared plus 12x minus 9 is equals to 0. So if we divide throughout by -1, we're going to have 3x squared minus 12x plus 9 being equals to 0. Let's go ahead and factorize this. On the first bracket, we're going to have 3x. On the second bracket, we're going to have x. We want minus 12x as the middle term and minus 9 as the constant. The way of doing that is if we have 3x minus 9 and x minus 1 being equals to 0. Here we're going to have x is equals to 3, and on the other side we're going to have x is equals to 1. Obviously 3x minus 9 is equals to 0, 3x is equals to 9. We divide both sides by 3, x is equals to 3. So these are the x value of the turning points. But we are looking for the coordinates, so we need to substitute these x values into f of x. So we're going to have f of 3 being equals to minus 3 to the power 3 plus 6 multiplied by 3 squared minus 9 multiplied by 3 plus 4. This is equals to 4. And then on the other hand, f of 1 will be equals to minus 1 to the power 3 plus 6 multiplied by 1 squared minus 9 multiplied by 1 plus 4. This is equals to 0. So the turning points, we have 3 and 4, 0 and, not 0 and 1, but 1 and 0. So these two are our turning points. Right, let's go ahead and do 8.2. In 8.2, we're supposed to draw the graph of f and clearly label all the intercepts with the axes and any turning points. So turning points, we have our turning points, so that is covered. Let's now look at the intercept. Do we have the x-intercept? Yes, we do. This turning point also serves as an x-intercept because y is equals to 0. So the x-intercept, we have that covered. Okay, let's go ahead and look at the y-intercept. Do we have the y-intercept? We don't, but we can go ahead and find it. The y-intercept, so f of 0, we know that y-intercept x is equals to 0. We're going to have minus 0 to the power 3 plus 6 multiplied by 0 squared minus 9 multiplied by 0 plus 4. So f of 0 is just equals to 4. So yes, we have the turning points and we have all the intercepts. We can go ahead and sketch our cubic function. Let's go ahead and do that. So let me just put my axis here and see what I can do. My y-axis and my x-axis. Okay, I have 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. And then going up, we have 1, 2, 3, 4. Going down, minus 1, minus 2, minus 3, minus 4. Right, let's go ahead and plot our coordinates. Okay, let's take a look at the turning points. We have 3 and 4, 1 and 0. So when x is equals to 3, y is equals to 4. We have a turning point right there. And then when x is equals to 1, y is equals to 0. We have a turning point right here. Okay, the x-intercept, let's take a look at the x-intercept right here when y is equals to 0, x is equals to 1. So that turning point is also serving as an x-intercept. Okay, and then the y-intercept when x is 0, y is 4. So we have a y-intercept. Okay, there's something I'm forgetting. There's another intercept here at x is equals to 4. Let me show you how that is coming about. F of x is also equals to, look at this equation here that they have factorized for us. X minus 1 squared multiplied by minus x plus 4. So obviously we have minus x plus 4 being equals to 0. So x is equals to 4. This is the other x-intercept that we have. Okay, let's carry on and do the equation that follows. We are done sketching that graph. 8.3. Use the graph to determine the values of k, for which minus x to the power 3 plus 6x squared minus 9x plus 4 is equals to k. We'll have 3 real and unequal roots. A very basic question. So we have f of x is equals to k. So f of x minus k is equals to 0. So we want to shift f of x such that we're going to have 3 real and unequal roots. Right now, by the roots we mean the x-intercepts, by the way. Right now we have 2 unequal roots. X is equals to 1 and x is equals to 4. Let me show you something. If we shift f of x downwards, then we're going to have 3 real and unequal roots. But then if you keep shifting it downwards, then we're going to have a problem. You can see that at this point we have 2 unequal and real roots. So we need to shift our function downwards. We need to shift our graph downwards. But then we need the value of k to be between 0 and 4. If k exceeds 4, 4 is the local maximum. If k exceeds 4, then we will no longer have 3 unequal and real roots. And if k is less than 0, then we are actually shifting our graph upwards. Our condition is not going to be satisfied. So we need k to be between 0 and 4. Let's move to 8.4. So in 8.4, the line g of x is equals to ax plus b is the tangent to f at the point of inflection of f. Determine the equation of g. So point of inflection. We can easily find the x value at the point of inflection. So let's do that first. So f of x is equals to minus x to the 3 plus 6x squared minus 9x plus 4. If we derivate this, f prime of x is equals to minus 3x squared plus 12x minus 9. So if you want to find the x value at the point of inflection, you have to derivate again and equate it to 0. If we do that, we're going to have f prime of x being equals to the second derivative, minus 6x plus 12. We need to equate this to 0. So we're going to have minus 6x plus 12 being equals to 0. Minus 6x is equals to minus 12. X is equals to 2. This is the x value at the point of inflection. We can substitute this x value into f of x and find the corresponding y value at the point of inflection. If we do that, we're going to have f of 2 being equals to 2 minus 1 squared multiplied by minus 2 plus 4. This is equals to, so we have 1 squared multiplied by 2, so we have 2. This is the point of inflection. The x value is 2 and the y value is 2. But this very x value, we can substitute it into f prime of x to find the gradient at that point. Because if we have the gradient at that point and g of x is the tangent at that point, then we're going to have the gradient of the tangent. Okay, so f prime of 2 will be equals to, what do we have? Minus 3, 2 squared plus 12 multiplied by 2 minus 9. This is equals to 3. So g of x is equals to 3x plus b. We have the gradient at our point of inflection. In order to find b, we need to substitute our point of inflection of coordinates 2 and 2. If we do that, we're going to have 2 being equals to 3 multiplied by 2 plus b. b will be equals to 2 minus 6, which is equals to minus 4. So g of x will be equals to 3x minus 4. This is the equation of g of x. The last question, 8.5, is quite easy to compute. We're looking for the value of theta, the acute angle formed between G and the x-axis in the first quadrant. The angle between G of x and the x-axis is the angle of inclination. And we know fully well that if we say tan of theta is equals to the gradient, it shouldn't be hard to find theta. So theta will be equals to tan inverse of 3. If you put that in your calculator, 71.57 degrees. Question 9 is usually difficult, but I think this one was bearable. Let's take a look at it. The diagram below represents a printed poster. A rectangle ABCD is the part on which the text is printed. The shaded area ABCD is 432 centimeters squared, and AD is equals to x centimeters. So we have AD being equals to x centimeters. Let's carry on. ABCD is 4 centimeters from the left and right edges of the page, and 3 centimeters from the top and bottom of the page. All right, and the first question, 9.1, we're supposed to show that the total area of the page is given by A is equals to 3,456 divided by x plus 6x plus 480. Let's go ahead and make sense of that. We have a rectangle, so the area of a rectangle is the length multiplied by the breadth. So let's go ahead and see if we can have the length and the breadth in terms of x and multiply in order to find the total area. Well, we know that AD is x centimeters. So from A to D, we have x centimeters. From D to the edge, we have 4 centimeters. And then from A to the edge, we have 4 centimeters. It means that from this edge to this edge, let's call that our length. Our length is equals to 4 plus x plus 4, right? So the length will be 8 plus x. We have 4 from here to here, and then from here to here we have x, and then from here to here we have 4. So that length is just 4 plus x plus 4, which is 8 plus x. That is the length. Let's go ahead and take a look at the breadth. Let me just erase this first and see what we have. From here to here we have 3 centimeters, obviously, and then from here to here we have 3 centimeters. We just need the length from this point up to here. How can we do that? We have the area of the shaded area. It is said to be 432 centimeters. So we have 432. The formula for that area would be AD multiplied by DC. This is equals to 432. But we know that AD is x. So we have DC being equals to 432 divided by x, basically. That is why we are given the area of ABCD. Right. So here we have 432 divided by x. So the length of the poster is 432 divided by x plus 3 plus 3. These 3 right here from D to the poster, and these 3 from C to the poster, plus 432 divided by x, which is the length of DC. So the breadth will be equals to 432x plus 6. This is the length and this is the breadth. So we can say that the area of our poster in terms of x will be equals to the length, which is 8 plus x multiplied by the breadth, which is 432 divided by x plus 6. So we just have to multiply these two brackets. 8 multiplied by 432 is 3,456, divided by x. And then 8 multiplied by 6. What is 8 multiplied by 6? That is 48. So we have plus 48. Now we multiply x by 432. We're going to get 432x. There's this x on the denominator, so they will cancel out. Plus 6x. This will be equals to 3,456 divided by x plus 48. 48 plus 432, that is 480. So we're going to have 6x plus 480. This is exactly what we are required to show. Let's go ahead and move to 9.2. In 9.2, we're supposed to determine the value of x for which the total area will be a minimum. You know fully well, this is almost always the case. We're going to derivate the equation in 9.1 and equate to 0. Let's do that first, and we're going to talk about why we're doing that. So a of x is equals to 3,456 divided by x plus 6x plus 480. But we can rewrite this, right? A of x will be equals to 3,456 x to the minus 1. That is the same as divided by x plus 6x plus 480. Let's go ahead and derivate this using the power rule. We're going to have a prime of x being equals to minus 3,456 multiplied by x to the minus 2 plus 6. Let's now equate to 0. 3,000 minus 3,456 x to the minus 2 plus 6 is equals to 0. X to the minus 2 is problematic, so let's write it as minus 3,456 divided by x squared plus 6x being equals to 0. We can multiply both sides by x squared. If we do that, we're going to get 6x squared minus 3,456 being equals to 0. So 6x squared is equals to 3,456. So x squared will be equals to 3,456 divided by 6. If we take square roots on both sides, we're going to have x being equals to 24 or x being equals to minus 24. So tell me, between x is equals to 24 and x is equals to minus 24, which one corresponds to the maximum and which one corresponds to the minimum? Let me know in the comment section. We have events A and B that are independent. The probability of A is equals to 1 divided by 3, and the probability of B is equals to 3 divided by 4. The first question, 10.1.1, we're looking for the probability of A and B. The probability of A and B will be equals to the probability of A multiplied by the probability of B. A and B are independent events. So we're going to have 1 divided by 3, the probability of A, multiplied by 3 divided by 4, the probability of B, being equals to 3 divided by 12, which is just 1 divided by 4. This is the probability of A and B, 10.1.1. Let's take a look at 10.1.2. There's a bit of swag here in 10.1.2. The question is saying, what is the probability of at least one event occurring, at least one event taking place? That is just a fancy way of saying what is the probability of A or B, right? So the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B, right? 10.1.1 was just setting us up to answer 10.1.2. So the probability of A or B will be equals to the probability of A, which is 1 divided by 3, plus the probability of B, which is 3 divided by 4 minus the probability of A and B, which is 1 divided by 4. This is equals to 5 divided by 6. 10.1.2. Let's move ahead and do 10.2. Quite an interesting one, but I feel like we have solved this problem before in some of the videos we have done previously. Let's take a look at it. The probability that it will snow on the mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius is 72%. We're going to make sense of that. No need to worry. Let's just read through our statement and see what information we have. If it does not snow on the mountains, the probability that the minimum temperature will drop below 0 degrees Celsius is 35%. Right, and then the first question, 10.2.1, represent the given information on a tree diagram. Clearly indicate the probabilities associated with each branch. 10.2.1 is probably setting us up to do 10.2.2. But let's just go ahead and solve this problem. We have 10.2.1. We're supposed to represent this in a tree diagram. Well, let's start. So it's either it is going to snow or it is not going to snow. So snow and not snow. One of those two has to happen. It's either it is snowing or it is not. It cannot be in between or both at the same time. So what is the probability that it will snow? Is 5%, right? We are given that. So we have 5 divided by 100. That is the probability that it will snow. If the probability that it will snow is 5 divided by 100, the probability that it will not snow is 95 divided by 100. I hope that makes sense. And then let's carry on. If it snows, then the temperature can be less than 0, but it is also possible that it can snow and the temperature be greater than 0. So what is the probability that when it snows, the temperature is less than 0? Let's go ahead and find out. You can see clearly here that if it snows, then the probability is 72% that the temperature is going to be less than 0. So we have 72 divided by 100. Okay, and then if the probability that it will snow and the temperature being less than 0 is 72%, then the probability that it snows and the temperature be greater than 0 will be 100 minus 72, which is 28. So we have 28 divided by 100 being the probability that it will snow and the temperature will be greater than 0. Right, let's move on to not snow and figure out what we have here. So t less than 0, t greater than 0. Okay, so if it does not snow, what is the probability that the temperature will go below 0 degrees Celsius? It is given to us as 35%. So if it does not snow, there's a probability that the temperature will be less than 0, which is 35 divided by 100. Obviously, for t greater than 0, we're going to have 65. Yes, 65 plus 35, 100. So we have 65 divided by 100 being the probability that it will not snow and the temperature will be greater than 0, which makes sense. Right, so this is the information we have represented on a tree diagram. 10.2.1. How many marks? 3 marks. Yeah, it's a lot of work. I don't know why it's 3 marks, but anyway, stories. Let's carry on and do 10.2.2. So in 10.2, calculate the probability that the temperature in central South Africa will not drop below 0 degrees Celsius in June 2024. We have to use our tree diagram. We want the probability that it will not drop below 0. Okay, let's go ahead. We can see clearly that here it is not dropping below 0 because the temperature is greater than 0. And even here, it's not dropping below 0 because the temperature is greater than 0. So we have to add those two probabilities. How do we do that? Okay, let me show you. So first of all, if it snows, the probability that the temperature will be greater than 0 is 28 divided by 100. And if it does not snow, the probability that the temperature is greater than 0 is 65 divided by 100. That is what we have to figure out. In order to find the probability of the temperature being greater than 0 when it has snowed, we have to multiply the probability of snow and the corresponding probability of the temperature being greater than 0. So we have 5 divided by 100 multiplied by 28 divided by 100. When we go up the branches, we multiply, and when we go down, we add. This is equals to 7 divided by 500. On the other hand, we're going to have 95 divided by 100 multiplied by 65 divided by 100, which is equals to 247 divided by 400. Makes sense, right? If it does not snow, the temperature will probably be greater than 0. All these probabilities make sense. So the answer, we're supposed to add these two. We're going to have 7 divided by 500 plus 247 divided by 400. This is equals to 0.6315. That is the probability that the temperature will not drop below 0 degrees Celsius in June 2024. Right. Let's move ahead and do 10.3. Quite an interesting question. I did spend a lot of time on this question, trying to see if I'm missing something. But anyway, we have 10 learners that randomly sit in a line, one behind the other. So in how many different ways can 10 learners stand in the line? Oh, they stand, they don't sit on a line. If we have 10 learners and they're sitting randomly, then we have 10 factorial ways of which they can sit. Right, that is quite an easy one. 1 mark in the bag, 10.3.2. Calculate the probability that there will be 5 learners between the 2 youngest learners in the line. That is where things start to get interesting. Okay, let's go ahead and have our, I don't want to say our seats, but yeah, let's go ahead and have 10 spaces. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've always used this method, and I'm always going to use it. Okay, so we want to find the probability that 5 learners will sit in between the 2 youngest learners. So let's say, for instance, we have y1 being the first youngest learner, and then in between we have 1, 2, 3, 4, 5. The 5 learners that are supposed to be between the 2 youngest. And then after that, we have y2, right? The second youngest learner. And after that, we're going to have 6, 7, 8, right? So in total, we have 10 learners. So let's go ahead and make sense of this. The probability is going to be equals to some number divided by the sample space, which is 10 factorial. So let's go ahead and figure that out. So we can have y1 first or y2 first. So there's 2 factorial ways in which y1 and y2 can arrange themselves between themselves. Okay, so this is 2 factorial. It's either y1 starts or y2 starts. So there's 2 factorial ways of doing that. Multiplied by, now let's take a look at the 5 learners in between y1 and y2. Well, they can arrange themselves in 5 factorial ways, right? Okay, so now that we have taken care of y1 and y2 and the 5 learners in between, we need these 7 learners to move as a unit because they need to be in between those 2 youngest learners. So if they're moving as a unit, then we have 1, 2, 3, 4. ways we can play around with the 7 learners and the 3 that are notched in between. So that is another 4 factorial ways we can arrange the 3 learners that are left out with the 7 learners, the 2 that sandwich the 5 in between them. So the probability is just 2 factorial. So we have 2 factorial. Let me just put that in my calculator. Multiply by 5 factorial, multiply by 4 factorial, divided by 10 factorial. This is equals to 1 divided by 630. Yes. Let me know in the comments if there is something I'm missing.
X squared minus 2x minus 24 is equals to 0. So what you want to do here is to ask yourself, which 2 numbers do I multiply and get minus 24, but then when I add, I get minus 2. We are essentially factorizing, right? You will realize that those 2 numbers is minus 6 and plus 4. So as a consequence, we're going to have x minus 6 multiplied by x plus 4 is equals to 0, right? So x minus 6 is equals to 0, or x plus 4 is equals to 0. So x can be equals to 6, or x can be equals to minus 4. Again, just to recap, which 2 numbers do I multiply and get minus 24, and then when I add them, I get minus 2, right? It's minus 6 and plus 4. And then let's do 1.1.2. So 1.1.2 is saying that let's solve for x if 2x squared minus 3x minus 3 is equals to 0. And then in the bracket, they tell us that we must round off to 2 decimal places, right? As soon as we see that, we know fully well that we're going to use the quadratic formula. That is, x is equals to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a, right? And then from our equation here, we know fully well that the coefficient of x squared is a, right? The coefficient of x is b, and this term here is going to be our c, right? So if we substitute that in our equation, we should get x is equals to minus, we're saying that b is minus 3, right? So minus 3 plus or minus b squared. So we have minus 3 squared minus 4ac. A is 2 and c is minus 3, right? And then we divide everything by 2 multiplied by 2. So x is going to be equals to minus multiplied by minus 3. That will just give us 3, right? And then plus or minus the square root of 33, right? If you put that in your calculator, and then everything divided by 4. So now it's easy to see that x will be equals to 3 plus the square root of 33 divided by 4, or our x can be equals to 3 minus square root of 33 divided by 4. So here x is going to be equals to 2.19 if we round off to 2 decimal places, or x is going to be equals to minus 0.69, and that's how we essentially solve that problem. Now let's do 1.1.3. So for 1.1.3, we have x squared plus 5x being less or equals to minus 4. As soon as we have something like this, right, we're going to jump straight to the critical values. So we're looking for the critical values, right? So we're gonna have x squared plus 5x being equals to minus 4. So this will be x squared plus 5x, and then minus 4. If we take it to the other side, we should have plus 4 being equals to 0, right? So now we can factorize this. Which 2 numbers do we multiply and we get 4, but then when we add them we get plus 5. That's easy. 1 and 4, right? So we're gonna have x plus 1, right, multiplied by x plus 4 being equals to 0. Obviously, when you get at this step, you can actually multiply out the bracket and see if you get what you started with. So if we go ahead and solve this, x will be equals to minus 1, or x is gonna be equals to minus 4. So this is where it gets interesting, right? The way I solve this problem, I introduce 2 possible solutions, right? So we can only have 2 possible solutions from this problem. It's either our answer is between the 2 numbers or outside the 2 numbers. What am I talking about here? It's either x is equals to 4 or between minus 4 and minus 1, or it can also be equals to minus 1, right? And then this is our first possible solution. Our other possible solution is that our answer is outside that range, right? So what am I saying? We're saying that x is less or equals to minus 4, and x is greater or equals to minus 1. We only have these 2 possible solutions, the first one and the second one. So now let's check which solution is true, right? So here on the first solution, we say that x can be between minus 4 and minus 1, right? So let's take a number between minus 4 and minus 1 and substitute it in our equation. If that number satisfies our equation, then the first option is true and the second is not. We know that we have x squared plus 5x being less or equals to minus 4. So let's take minus 2, right? Since minus 2 is between minus 4 and minus 1. So if we take minus 2, we're going to get minus 2 squared plus 5 multiplied by minus 2 being less or equals to minus 4. So minus 2 squared, that will be 4, right? So we have 4, and then 5 multiplied by minus 2, that will be minus 10. So we have minus 10 being less or equals to minus 4. So we're getting minus 6 being less or equals to minus 4. And you can see that this is true, right? Minus 6 is less than minus 4. So our first option is true. So this answer here cannot be correct, because when you take a number in this interval that we're proposing, it satisfies our equation. 1.1.4. So for 1.1.4, we have the square root of x plus 28 being equals to 2 minus x, right? So let's, square both sides here and see what happens. So we have the left hand side squared and then the right hand side squared. The left hand side, that will just be x plus 28, and the right hand side, so we have 2 minus x squared, right? So you say 2 multiplied by 2, that is 4, and then 2 multiplied by minus x, that is minus 2x, multiplied by 2, that will be minus 4x, and then minus x multiplied by minus x, that will be plus x squared, right? So let's take x and 28 to the right hand side, right? So we have 0 being equals to, so 4 minus 28, that will be minus 24, and then minus 4x minus x, that will be minus 5x, and then plus x squared, right? So now we factorizing that. Again, our key equation, which 2 numbers do we multiply, and we get minus 24, but when we add, we get minus 5. That should be minus 8 and positive 3, right? So 0 should be equals to x minus 8 multiplied by x plus 3. So now it's easy to see that x is equals to 8 or x is equals to minus 3. But then one between these 2 answers is not necessarily true, because we squared here and introduced solutions that might not be necessarily true. So it's up to us now to check which answer is that. So we're going to substitute 8 and we're going to substitute minus 3 in the equation and see what happens, right? So let me just substitute 8 real quick. So if I substitute 8 real quick on the left hand side, I get 6. And then let me check what happens on the right hand side. on the right hand side, I'm getting minus 6. Clearly, 8 doesn't satisfy our original equation. So we have to show here by saying that x is not equals to 8. Let's see if we can solve for x and y simultaneously. If 2y is equals to 3 plus x, right? And 2xy is equals to x squared plus 4y squared. So what are we saying? We're saying that 2y is equals to 3 plus x, right? We're not going to do anything new. We're going to do what we always do. We're going to take one variable and make it the subject of the formula. You should be able to see here that if we make y the subject of the formula, then we're going to have to divide both sides by 2, which will make our equations more complicated because we're going to have fractions, right? But then if instead we make x the subject of the formula, then we want to have a fraction, and that will be easier to deal with. If I want to make x the subject of the formula, I'm going to get 2y minus 3 is equals to x, right? Now x is the subject of the formula, and I can call this equation 1, right? Now let's look at the other equation. The other equation, we have 2xy plus 7 being equals to x squared plus 4y squared, right? And then we can call this equation 2. So what we want to do at this step, we want to substitute equation 1 into equation 2, right? We want to substitute equation 1 into equation 2. So how do we do that? Everywhere where there is x in equation 2, right? Everywhere where there is x in equation 2, we're going to put 2y minus 3. So if we do that, we're gonna get 2, let's say 2y, and then in place of x, we're gonna have 2y minus 3, right? Plus 7 being equals to x squared. In place of x, we have 2y minus 3, and then squared plus 4y squared, right? So now you should be able to see that in this equation that we have here, the only variable we have is y. So it should be easy to find y. And then when you have y, we're gonna then substitute those answers into equation 1 in order to find x, right? We're solving simultaneously. So we have 2y multiplied by 2y, which will be 4y squared, right? And then we have 2y multiplied by minus 3, which will be minus 6y, and then plus 7, all being equals to, so we have 2y minus 3 squared, right? So we say that 2y multiplied by 2y, that will be 4y squared, right? That will be 4y squared. And then 2y multiplied by minus 3 multiplied by 2, so that will be minus 12y. So we have minus 12y, and then minus 3 multiplied by minus 3, that is just plus 9, right? And then plus 4y squared. So on the left hand side, we have 4y squared minus 6y plus 7 being equals to. On the right hand side, you should be able to see here that we have 4y squared, and then here we have plus 4y squared. So that should give us 8y squared, and then minus 12y plus 9, right? Now we can take everything on the right hand side to the left hand side, right? If we do that, we're gonna have 4y squared minus 8y squared, which will give us minus 4y squared. And then we have minus 6y plus 12y, right? When you take it to the other side, we shall change the sign, and that should give us plus 6y, and then plus 7 minus 9, that should be minus 2, all being equals to 0. So if we divide everything by minus 1 here, we shall get 4y squared minus 6y plus 2 being equals to 0, right? So now what we have to do is to factorize that. If we factorize that, we should get 4y on this bracket, and then on the other bracket we have y. On the first bracket, we're going to have minus 2, and then on the second bracket, we're going to have minus 1 being equals to 0. When it comes to factorizing these kind of equations, you might have to use trial and error a couple of times, right? Alternatively, you can just use the quadratic formula instead of factorizing. But then anyway, stories. If we go ahead and solve this, we're going to get 4y is equals to 2, or y is equals to 1. So y here should be equals to 2 divided by 4, which is just 1 divided by 2, right? And then on the other side, we already have y is equals to 1. So it's either y is equals to 1 or y is equals to a half, right? Now we need our corresponding x values. What is the value of x if y is a half? We have to go back to our equation 1, right? Our equation 1, we said that 2y minus 3 should be equals to x. So if y is a half, then we're going to have 2 multiplied by a half minus 3 being equals to x. So 2 multiplied by half, that is 1 minus 3 being equals to x. So minus 2 is equals to x. But that's if y is a half. But what if y is 1? Then we're going to have 2y minus 3 being equals to x. And then 2 multiplied by 1 minus 3 is equals to x. And then minus 1 is equals to x, right? So we have x being either equals to minus 2 or x being equals to minus 1. And that's essentially how we solve that problem. And now the more interesting one is actually 1.3. Let's solve 1.3 and see what happens. So 1.3 is saying that the roots of an equation x is equals to minus n plus or minus the square root of n squared minus 4mp divided by 2m, where m, n, and p are positive real numbers. The numbers m, n, and p in that order form a geometric sequence. Prove that x is a non-real number. X is a non-real number. I want you to realize that this minus n here doesn't have any effect on whether x is a real number or not, right? And then this 2m here also doesn't have any effect on whether x is a real number or not, right? What is actually controlling that is this here, which is inside the square root, right? Because if that is negative, then x is a non-real number, right? Because we cannot take the square root of a negative number, right? So if that is negative, then x is a non-real number. So this question is saying that let's prove that x is a non-real number. So we're essentially proving that n squared minus 4mp is less than 0. But how are we going to do that? We're going to do that by using the information given here. The numbers m, n, and p in that order form a geometric sequence. So let me show you what I'm talking about. We're saying that we need n squared minus 4mp to be less than 0, right? That's what we are required to prove. But we know that m, n, p, they form a geometric sequence, right? So we can see that this is the first term, this is the second term, and then this is the third term. So if this is indeed a geometric sequence, then r, the common ratio, should be equals to t3 divided by t2, or even t2 divided by t1, right? So what is t3? T3 is p. So we have p divided by t2, which is n, being equals to t2, which is n again, divided by t1, which is m, right? So if we cross multiply here, it should be easy to see that mp is equals to n squared. mp is equals to n squared, right? Let's go back to our equation now. We have x being equals to minus n plus or minus n squared minus 4mp divided by 2m, right? So now that we know that mp is equals to n squared, instead of mp here, let's put n squared. So x will be equals to minus n plus or minus the square root of n squared minus 4n squared divided by 2m. Issues are arising. You can see here that for n squared minus 4n squared, we're going to get minus 3n squared. So we're going to have the square root of a negative number, which we know that we're not allowed to have. As a consequence, x will be a non-real number because of that, right? Just to cement the idea, x will be equals to minus n plus or minus, we're saying that n squared minus 4n squared, that will be minus 3n squared divided by 2m. Clearly, x can never be a real number because we take in a square root of a negative number. So we have a geometric series x plus 90 plus 81 and some numbers therefore. And then 2.1 says determine the value of x. For a geometric series, we know that we have a common ratio. The common ratio is given by Tn divided by Tn minus 1. So if we have T3, Tn minus 1 is T2. And then if we have T2, Tn minus 1 is T1. So this is the idea we're going to use to determine the value of x. So what is T3? T3 is 81 and T2 is 90. We're saying that T2 is 90 and then T1 is x. So from here, we can then solve for x, so to say. So we're going to have 81 multiplied by x is equals to 90 multiplied by 90. At this step, I don't want to put this 90 multiplied by 90 in the calculator. I'm avoiding anything that can make me make a mistake. So the only time I'll put something in a calculator, it's when I have to, or I'm at the end and I have to determine my answer. So if I carry on from this, I will get x equals to 90 multiplied by 90 divided by 81. And then at this step, that's where I can put it in the calculator. And then if you put this in the calculator, you're going to get 100. So that's the value of x. The value of x for this question is 100. And then let's move ahead. 2.2 says, show that the sum of the first n terms in the sequence is Sn equals to 1000 multiplied by 1 minus 0.9 to the power n. So what's the formula for the sum of n terms in a geometric series? The formula is given as the sum of the n terms is equals to a multiplied by 1 minus r to the n divided by 1 minus r. A is the first term, as you should know by now, and then r is our common ratio, and then n is the number of terms of which you're interested in. So we're going to have Sn equals to a is 100, right? Because 100 is our first term, which was x before we determined it. And then 1, that is 1. And then to find r, we divide Tn by Tn minus 1. So if we take Tn as 90, then we're going to divide it by the term before it, which is 100, and then everything to the power n. And then we divide this by 1 minus 90 divided by 100, right? Then this will be equals to 100 multiplied by 1 minus 90 divided by 100, that is 0.9 to the power n, everything divided by 1 divided by 10. Because if you subtract 90 divided by 100 in 1, you're left with 1 divided by 10. So from here, we're going to say, we know that if we have a multiplied by b, everything divided by c, this is the same as a divided by c, everything multiplied by b. So if we apply that idea here, we're gonna get 100 divided by 1 divided by 10 multiplied by 1 minus 0.9 to the power n. And then 100 divided by 1 divided by 10, that will give you 1000 multiplied by 1 minus 0.9 to the power n, which is what our question asks us to show. And then 2.3 goes on to say that calculate the sum to infinity. After I calculated Sn, I know that the sum to infinity is going to be 1000. Why am I saying that? I'm saying that because I know that the sum to infinity is just a divided by 1 minus r. And then that's how we got 1000. We got it from a divided by 1 minus r. But then let's go ahead and show that. We know that the sum of infinity, like we're saying, is a divided by 1 minus r. What is a? A is 100. And then 1. And then r is 0.9. If you put that in the calculator, you get 1000. Here we have a quadratic number pattern, the first term being minus 145, the second term being minus 122, and the third term being minus 101. And then the first question says, write down the value of T4, the fourth term, the term coming after minus 101. So the thing we can do, we can find the first difference first, and then we find the second difference, and then we just add on to find the fourth term. So if we subtract minus 145 from minus 122, we get 23. And then if we find the difference between minus 101 and minus 121, we get 21. If we find the difference between 21 and 23, we get minus 2. So this is the information we have. And now from this, we know how we can move forward. So we add minus 2 to 21, we get 19. And then we add 19 to minus 101, we get minus 82. So our fourth term in this quadratic pattern is minus 82. So 3.2 goes on to say, show that the general term of this number pattern is given as Tn equals to minus n squared plus 26n minus 170. So the general formula for the general term of a number pattern is given as Tn equals to an squared plus bn plus c. So what this question is basically asking us to do is to determine a, b, and c. So to determine a, we have a formula that says 2a is equals to the second common difference, which is minus 2, right? So from here, we can get a equals to minus 1. And then for b, we have a formula that says 3a plus b equals to the first term of the first difference, which is 23. So we know that a is minus 1, so we're going to have 3 multiplied by minus 1 plus b equals to 23. If you take minus 3 to the right hand side, you get b equals to 26. And then for c, we have a plus b plus c, which is always equals to the first term. In this instance, is equals to minus 145, right? A, we said is minus 1, b, we said is 26, so we're just solving for c. So we're going to have c equals to minus 145 plus 1 minus 26, which is going to give us minus 170. So we have proved that Tn is equals to minus 2n plus 26n minus 170. And then we can move to the third question. The third question says, between which two terms of the quadratic number pattern will there be a difference of minus 121? Let me show you something. Here the difference is 23, right? Between this term and this term. So the first term of the sequence being made by the first differences is between the second and the first term of the quadratic. Then the second term is between the third and the second. And then the third is between the fourth and the third. So T50 of the sequence being made by the first difference will be the term between T51 and T50. So what this question is asking us to do is to find which position minus 121 is located in the sequence being made by the first difference.
So the first difference, we say that is 23, the second difference is 21, and then the third difference is 19. So now we have a sequence being made by the first differences. We can then use it to find where minus 121 is located. So we're gonna have Tn equals to a plus n minus 1 multiplied by d, because this is an arithmetic pattern, right? We have a common difference. So Tn is minus 121. A is the first term, which is 23, plus n minus 1 multiplied by d. What is d? We know that d is minus 2, right? So we're going to have minus 121, which is equals to 23 minus 2n plus 2. So minus 2n equals to minus 121 minus 23 minus 2. And then n is equals to minus 121 minus 23 minus 2 divided by 2n. If I put that in my calculator, I'm gonna get 73. So minus 121 is T73, right? So that means it's between the 73rd term and the 74th term on our quadratic sequence. It's a bit tricky, so maybe take the video back and watch it again. And then 3.4 says, what value must be added to each term in the number pattern so that the value of the maximum term in the new pattern will be 1? What's the maximum term? So you can see that our general formula is Tn equals to an squared plus bn plus c. This is parabolic, so to say. So the maximum term, n at the maximum term, will be given by minus b divided by 2a, just as we have in a parabola. So what is minus b? Minus b is minus 26, 2 multiplied by a, which is minus 1. So this is going to give us T13, right? But what is the value of T13? We need to know the value of T13 so that we know what we need to add to it so that we can get 1, because we want the maximum term to have a value of 1. So T13 equals to minus n squared plus 26n minus 170. So we're going to have minus into 30 squared plus 26 multiplied by 13 minus 170. Let me put that in my calculator real quick. I'm getting minus 1. So which number do we have to add to minus 1 to get 1? This is clear to see that the number we need to add is 2. So if we add 2 to each term, then the value of the maximum term in the new sequence will be 1. And then the first question says, write down the equations of the asymptotes of f. What comes to your mind when you hear the word asymptote? What should come to your mind is undefined. An asymptote is that point which the graph never reaches, no matter what. So always, when you're given a hyperbola, let's say you're given a hyperbola g of x and it's in the form a divided by b plus x plus c, and the question says find the asymptote. You focus on this part, on the denominator, right? And then you equate it to 0. B plus x equals to 0, and then you solve for x. This is because if you take any number k, right, and you divide by 0, you get undefined. So the graph will never reach that point no matter what. So for me to practice what I preach, let me do the same for our f of x, right? On the denominator we have x minus 3
which we're going to equate to 0, like I said, and then that will mean that x equals to 3. If you take this 3 right here and you substitute it in f of x, you are gonna get undefined, right? So the x coordinate of the asymptote is x equals to 3. But then the question says write down the equations. We have x, now we're looking for y. Like I said, if you substitute f 3 into f of x, you're gonna get undefined, right? So you won't get the corresponding y value. So what you can do is substitute a number that is very close to 3, x, our x coordinate for the asymptote. So what you can do is substitute 2.99999, or you can substitute 3.01111. If you do that, you're gonna realize that you will get a number that is approximately 2, and that will be the y coordinate of the asymptote. Using our example of a general formula of a hyperbola g of x, the x coordinate of the asymptote will always be equals to minus b, right? B being, this value that we have here, and then the y coordinate of the hyperbola will always be equals to c. So in this instance, y is equals to 2, right? And that's how you can sort of determine an asymptote. Let's move ahead. 5.2, it says write down the domain of the graph. The domain is every value of x where the graph is where the equation is defined, right? So because the function is defined everywhere except at the asymptote, right? So we have already established that x cannot be 3 for our f of x, right? So the domain of f of x will there be x can be an element of any real number, but just not 3. That's all we need. If you plug in any number into f of x, you're gonna get a corresponding y except at 3. So x is an element of a real number except at x equals to 3. Or if you don't want to write it like that, you can say x is either greater than 3 or x is less than 3. Yeah, then that's also true. Let's move ahead. We have 5.3. It says determine the coordinates of the x-intercept of f. What comes to your mind when you hear the word x-intercept? When I hear the word intercept, x-intercept, I think y equals to 0, because an intercept is where the graph cuts on the x, and when it cuts on the x-axis, y is supposed to be 0. So we're just going to take our function and let y be 0 so that we can find the intercept. So for f of x, we're going to have 0 minus 1 divided by x minus 3 plus 2. We subtract 2 from both sides, we get minus 2 equals to minus 1 divided by x minus 3. If we cross multiply that, we get minus 2x plus 6 equals to 1. Take 6 to the other side, minus 2x equals to, this is minus 1. You take 6 and then it becomes minus 6. This will be minus 7, and then x equals to 7 divided by 2. That's the x-intercept, and then the point is the x value is 7 divided by 2, and then the y is 0, right? Because at the x-intercept, y is equal to 0. That's what we assumed when we were calculating x. The next question, y-intercept, we let x be equal to 0, and then we solve for y. for this equation, we're gonna have y equals to minus 1 divided by x. No, we're letting x be equal to 0, so this will be 0 minus 3 plus 2. This will give us 1 divided by 3, this negative and this negative, and then we have plus 2. And then here, the way I do it, I give 2 a denominator of 3 so that I can just add the numerators, right? So this will be 1 divided by 3 plus 6 divided by 3. This is equals to 2. And then I'll just have 1 plus 7 on the numerator. You take a common denominator, then this will be 7. Oh, this is 6, I'm sorry. This will be 7 divided by 3. So that's the value of y for the y-intercept. Then the point will there be for 0, and then y is 7 divided by 3. Let's move ahead. 5.4. Last but not least, draw the graph of f. Clearly show all the asymptotes, intercepts, and intercept with the x's. So asymptotes and intercepts. Yeah, I'm just writing that down so that I don't forget. Let me increase this space, and then okay, yeah, there we go. We have our y-axis there, and then we have our x-axis there, and then yeah, obviously it's still running, it doesn't end there. Asymptotes. Okay, let's go up and look for our asymptotes. The y asymptote is 2, and the x asymptote is 3. So here the x asymptote is 3, the y asymptote is 2, right? So if you're dealing with a hyperbola, you will then sort of have a new set of x's, right? That's the asymptote there running, and then this is the asymptote there running. At this point, you should know that when you are given a hyperbola, it's either you will have a graph here and another one here, or you will have one here and another one here. But then what determines that? I determine it using the equation, right, for the function. So let me write that down and take you through it. So the equation is f of x equals to minus 1 divided by x minus 3 plus 2. Look at the x. We have this 3 here, right? So here we have 4, we have 5 going forward. So what we can do is just ignore the 2 because it's a constant, and the minus 3 on the denominator, right? So let's just put minus 1 divided by x, right? If you keep on increasing x here, so x is going up, right? This value becomes smaller and smaller, right? But then because we have a negative here, it's becoming smaller from the negative side, so it's sort of increasing in a way, right? So y will go up when x goes up, and then that will mean that when x goes down, y goes down. In the first quadrant here, when x increases, y will go down for a hyperbola, right? On the second, x is increasing, we're not interested on that, and then on the third is doing the same. But then on the fourth, that's where when x increases, y also increases. So the first swing will be this side. Supposed to cut here on the x-axis, and then it will be like that, and then another wing will be on the second quadrant, or made by the asymptotes, right? And then another thing is supposed to indicate is the intercepts. For y, it's it's 7 divided by 3, so I'm assuming 7 divided by 3 is somewhere here, and then for x it's 7 divided by 2, so 7 divided by 2, I'm assuming it's somewhere here. So we have indicated the asymptotes, we've indicated the the intercepts, and yeah, that's it for this question. If you like the video, give it a thumbs up. If you didn't, leave a comment. Let me know what you didn't like. The graph of f of x is equals to log x base 4, and then there we have it drawn below. It has some point b of coordinates. Let me write that down. Coordinate k and 2, right? K being the x and 2 being the y. The first question says determine the value of k. K is the x coordinate of b. So because we have the function given to us, we're going to substitute 2 in place of y, and we substitute k in place of x, right? So our function is given by y equals to log base 4, and then we have our x over there. So in place of y, we're going to put 2 because that's the y coordinate of b, right? And then in place of x, we're going to put k because that's the x coordinate of b. So now the only variable we have is k, which is what we are solving for. So this is going to give us 4 to the power of 2 equals to k. If you don't know how this comes about, it's a log rule, which says that if you have some log b base a, then which is equals to some number n, then this is the same as a to the power n equals to b. Is what we did here on this equation we have here to determine k. So 4 to the 2 is 16, right? So in this instance, k is equals to 16. We just use this log rule that we have here. So every time the base of the log can carry the number on the other side, and it will be equal to this number here. In this instance is k. Let's move ahead. 6.2, it says determine the values for which f of x is greater or equals to -1 and is equals to or less than 2, right? So what is f of x? F of x is log base 4x, right? And it's saying we're supposed to find the x values for which this is greater or equals to -1, right? And then the other one is when it's less or equals to 2. But let's just start with this. So basically we have this, and the question is just asking us to solve for x. If we do that, sticking to the log rule, we have this 4 is gonna carry the -1, right? And then this will all be greater or equals to x. 4 to the -1, that is just 1 over 4, right? So x is supposed to be less or equals to 1 divided by 4. And then the other scenario we have is when this function log base 4x is less or equals to 2. We're just going to do the same thing. The 4 is going to carry the 2, and then this will be less or equals to x, right? 4 to the 2 is 16. We're going to have x greater than or equals to 1 divided by 4, and then less or equals to 16. So those are the values of x for which f of x is less or equals to 2 and is greater or equals to -1. The third question 6.3, it says write down the equation of the inverse of f in the form y equals to. So when you have a log function like this that we have y equals to log of x base 4, right? And then the equation says find the inverse. What you're supposed to do is you're supposed to swap x and y and then solve for y. If we do that on this question, we're going to get x in place of y, and then this is equals to log base of 4y. Yeah, now we have swapped the two and we solve for y. We have done this. Now if you remember the log laws, what's going to happen is that this 4 is going to carry the x, and then this will be equals to y. Now we have solved for y. So this is the inverse of our f of x. 6.4, last but not least, it says for which values of x will x multiplied by the inverse of f be less than 0. So let's go ahead and do that. Yeah, it might look scary, but it's really not. You just have to stick to the basics. So we have x being multiplied by 4 to the power x, because 4 to the power x is the inverse of f. And then we say for which values of x is this less than 0. This can never be less than 0, right? This part here, 4 to the power x, can never be less than 0. So the question is really on this part here, this x that's multiplying. This x which is multiplying is less than 0 for every value which is less than 0, right? So we're gonna be multiplying a positive number by some negative number in order to get a number that is less than 0. So for which value of x, for every value of x that is less than 0, this whole expression will be less than 0, right? So the answer is basically just x less than 0, and then that's it for this question.
Most people don't know this, but we actually have an equation for the turning point of a quadratic function and the range, and I'm going to use those exact formulas to answer this question. Let's look at 7.1. The question is saying let's write down the coordinates of b and d. B and d are the x-intercepts of our function. We are given the function f of x being equals to x plus 4 multiplied by x minus 6. Obviously, if we solve for x here, we're going to get x is equals to minus 4 or x is equals to 6. It will be easy to see that between minus 4 and 6, the x coordinate of b is minus 4 and the y coordinate is 0 because it is the x-intercept. And then this is the coordinates of b. The coordinates of d, we have 6 and 0. And just like that, we've answered 7.1. Let's look at 7.2. Calculate the coordinates of c. C is the turning point of f of x. We are given that f of x is equals to x plus 4 multiplied by x minus 6. Let's go ahead and multiply out. If we do that, we're going to get x squared minus 6x plus 4x minus 24. So we're going to have x squared minus 2x minus 24. If we want to find the x value of c, we say minus b divided by 2a, where b is the coefficient of x. It happens to be minus 2 divided by 2a. A is the coefficient of x squared, which is 1. So 2 divided by 2, that is 1. Now we come to the y value of C. This is what I was referring to. We actually have a formula for that. We can substitute back into our equation, but we don't really have to do that. The formula, it is C minus B squared divided by 4A. So what is the value of C? The constant. That is minus 24. So we're going to have minus 24 minus B squared. B is minus 2. We square that and we divide by 4A. A is 1. So we're going to have minus 24 minus what is minus 2 squared. That is just 4. You divide that by 4, we just get minus 1. So minus 24 minus 1, that is minus 25. So the coordinates of C, we have 1 as the x value and minus 25 as the y value. Let's go ahead and do 7.3. 7.3, we're looking for the range of f. F is concave up. If f is concave up, then the range will be given by y is greater or equals to y at the turning point. But we know that y at the turning point is minus 25. So y is greater or equals to minus 25. Just like that, we've answered 7.3. 7.4. Let's look at what the question is saying. Given that theta is equals to 14.04 and the tangent to f at t is perpendicular to AE, 7.4.1, let's calculate the gradient of AE. If we're given the angle, then it will be very easy to compute. We know that tan of theta is equals to the gradient of that line. It happens to be AE in our case. So we're going to have tan of 14.04 being equals to the gradient of AE. If you put that in your calculator, you're going to get 1 divided by 4 being equals to the gradient of AE. Let's look at the equation that follows, 7.4.2. Let's calculate the coordinates of T. We are told that T lies on a tangent that is perpendicular to AE. So we can find the gradient at T with ease. Because if the tangent is perpendicular to AE, then the gradient of the tangent multiplied by the gradient of AE will give us minus 1. So the gradient of the tangent multiplied by AE, that is 1 divided by 4, is equals to minus 1. So the gradient of the tangent will be minus 1 divided by 1 divided by 4. If you solve that, you should get minus 4 as the gradient of our tangent. The tangent touches f of x at t. So we can derivate f of x and find f of prime x. And then that is how we're going to get to the x value of t. So if we do that, f of x at this point, we know it is equals to x squared minus 2x minus 24. If we derivate this, we're going to get f prime of x being equals to 2x minus 2. And that's it. We know that the gradient at that point is minus 4. So we can say that 2x minus 2 is equals to minus 4. What are we trying to do here? We're trying to find the value of x for which the gradient is minus 4. And we know that the gradient is minus 4 at t. That's why we are doing this. So we're going to have 2x being equals to minus 2 plus 2. That will be minus 2. So x is equals to minus 1. Now we can substitute this value into f of x. So f of minus 1 will be equals to minus 1 squared minus 2 multiplied by minus 1 minus 24. This will be 1 plus 2 minus 24. So we have minus 21. The coordinates of t, the x value is minus 1 and the y value is minus 21. The last question, 7.5. A straight line G parallel to AE cuts F at K and R. Calculate the x coordinate of R. Right, so what we are going to do here, we're going to find the equation of g. We are going to find g of x, and then after finding g of x, we can equate g of x and f of x, and then we're going to find the x coordinates of which they touch, which happens to be k and r. So our first step, let's find the equation of g of x. So we're given the gradient of g of x, so to say it is said to be parallel to AE. The gradient of AE is 1 divided by 4, so the gradient of g of x should be 1 divided by 4. Now we just need to find c, but we're given k, a coordinate on g, so c should be quite easy to find. If we substitute k, we're gonna get minus 9 being equals to 1 divided by 4 multiplied by minus 3 plus c. So minus 9 plus 1 divided by 4 multiplied by 3 is equals to c. So c is equals to minus 33 divided by 4. So g of x is equals to 1 divided by 4x minus 33 divided by 4. We need to equate this to f of x. We're going to be able to find the two x values for which f of x and g of x touches. That is how we're going to get the x coordinate of r. So let's go ahead and say that g of x is equals to f of x. So g of x is a half x minus 33 divided by 4. And then f of x, on the other hand, we have x squared minus 2x minus 24. So if we rearrange this, we're going to get x squared minus 2x minus 1 divided by 4x, and then minus 24 plus 33 divided by 4 being equals to 0. It will be wise for us to multiply out by 4 because we have 1 divided by 4 and 33 divided by 4. If we multiply it by 4, everything sits down. So let's go ahead and do that. We're going to have 4x squared minus 8x minus x, and then 24 multiplied by 4. So that is 24, 48, 96 plus 33 being equals to 0. So if we solve that, we're going to get 4x squared minus 9x minus 63 being equals to 0. So now it is just a matter of factorizing. You can use the quadratic formula because of this coefficient of 4. It becomes really hard to factorize using your mind without the aid of a calculator. So if we factorize anyway, we shall get 4x minus 21 multiplied by x plus 3 being equals to 0. So x is equals to 21 divided by 4, or x is equals to minus 3. We know that x is equals to minus 3 is the x value of k. That just tells us that x is equals to 21 divided by 4 is the x value of r.
So 9.1 says determine f prime x from first principles if it is given that f of x is equals to 2x squared minus 3x. What you can do when you have a question like this, you can do it using the power rule first, right? So if I do that, I get f prime x is equals to 4x minus 3. So in a way, when you use the first principles, you already know what the answer is supposed to be. So let's go ahead and do that. We're gonna have f prime x is equals to the limit as h tending to 0 of f x plus h minus f of x divided by h, which is equals to the limit as h tending to 0. So f of x plus h, everywhere where there is x, we're going to put x plus h, right? So we're going to have 2, and then in place of x we put x plus h squared, right? Minus 3, in place of x we put x plus h, and then we can close that bracket, and then we subtract f of x, right? F of x, that's 2x squared minus 3x, and then we can divide everything by h. So we have the limit as h tending to 0. So now we're supposed to square x plus h, right? So we're gonna have 2 multiplied by x multiplied by x is x squared, x multiplied by h, that's xh multiplied by 2 is plus 2xh, and then h multiplied by h, that is just h squared, minus 3x minus 3h, and then we subtract f of x from everything. So we're gonna have 2x squared minus 3x, and then we divide everything by h, right? So it goes to the limit as h tending to 0. So now we have we multiply in this expression here by 2, right? So we're gonna have 2x squared plus 4xh plus 2h squared minus 3x minus 3h, and then let's multiply out this bracket here by minus, right? So we're gonna have minus 2x squared plus 3x divided by h. At this step, every term that doesn't have an h is supposed to fall apart. So if after this step you still have a term that has x and then it doesn't disappear, then you have done something wrong. So this 2x squared is going to be neutralized by this 2x squared, and then minus 3x, we're going to add 3x, and then it's going to be gone. And then now we're just left with terms that have h. So we're going to have the limit as h tending to 0 of 4xh plus 2h squared minus 3h divided by h. Now we can take h as a common factor. We're going to have the limit as h tending to 0, h 4x plus 2h minus 3 divided by h. H and h, they cancel out. Now we have the limit as h tending to 0 of 4x plus 2h minus 3. H is tending to 0, so we're just going to have 4x minus 3, which is the same as when we use the power rule. So what we have done here is correct. So let's move ahead. 9.2.1 says determine dy dx if y equals to 4x to the 5 minus 6x to the 4 plus 3x. This is quite an easy one because we're just going to use the power rule. So what does the power rule say? The power rule says that if we have x, okay, if g of x equals to let's say k x to the power of n, then the derivative of g of x is equals to n multiplied by k multiplied by x to the power n minus 1, right? So now dy dx is gonna be 5 multiplied by 4 multiplied by x to the power 5 minus 1, and then minus 4 multiplied by 6 multiplied by x to the power 4 minus 1 plus 3 plus 1 multiplied by 3 multiplied by x to the power 1 minus 1. So this is going to give us 5 multiplied by 4 is 20 multiplied by x, so that is 20x to the power 4. 4 multiplied by 6, that is 4, that is 6, 12, 24, so that is minus 24x to the power 3. 3 multiplied by 1, that's 3, and then any number to the power 0 is 1, so this is just gonna be plus 3. So it's easy as that. We have solved our problem. Now let's move to 9.2.2. We have the derivative of dx of minus 3 there, and then okay, let me just copy that down real quick. Divided by 3x to the power 2. So there we have that expression there, right? So there's a square there, 1 divided by 3x is being squared. So that's something to note. We're gonna take care of that. So okay, we're gonna take out that cube root there. So we're gonna have minus x to the power 1 divided by 3 divided by 2, and then plus 1 squared divided by 3x squared, right? 3x squared is gonna be 9x squared. So there isn't much left to do here on this term. We're just gonna derive it, but then this term we still have to write it in the standard format so that we can use the power rule, right? So we have minus 1 over 2 multiplied by x to the power 1 over 3 plus. Now the x is on the denominator, right? If we put it on the numerator, then the exponent changes sign, right? So now we're gonna have 1 divided by 9. Instead of x at the denominator is coming to the numerator, so we're gonna have x to the power minus 2, right, instead of 2. So if you derive this, we're gonna have 1 over 3 multiplied by minus 1 over 2 x to the power 1 divided by 3 minus 1 plus minus 2 multiplied by 1 divided by 9 x to the power minus 2 minus 1. This is equals to 1 by multiplied by 1 by minus 1, that's just minus 1. 3 multiplied by 2, that is just 6x, and then 1 over 3 minus 1, that's minus 2 over 3. So we're gonna have minus 2 over 3, and then we have minus 2 divided by 9 x to the power minus 3, right? Yeah, now we have derivated our equation, but then we cannot leave it with negative exponents because that's not how we found it. Now we have to take it back, and doing that we had minus 1 divided by 6 multiplied by x. It had a negative sign, now the sign becomes positive, right? 2 divided by 3 minus 2 divided by 9x, instead of minus 3, now it's just 3, right? And then this is our d of x.
For which values of k will this equation have one negative and two distinct positive rows? This is one of those questions that people usually run away from, but we're about to do it in a couple of minutes. Let's look at 10.1. show that A is equals to minus 1 and B is equals to 6. Let's look at the information we have. We are given the equation for the graph h of x. It is said that h of x is equals to ax to the 3 plus bx squared. What information do we have? We are given 2 points, one at the origin. Our second point is another turning point at x is equals to 4. We have 2 variables, a and b. Generally, we would need 2 equations. Let's substitute b and see where we end up. If we do that, the value of h of x will be 32 and the value of x will be 4. So 4 to the power 3 plus b 4 to the power 2. We're gonna have 32 being equals to 64a plus 16b. Let's make b the subject of the formula since it has the smallest coefficient. If we do that, we're gonna have 32 minus 64a being equals to 16b. We can divide both sides by 16. If we do that, we're gonna get 2 minus 4a being equals to b. We can say that this is our equation 1. Which other information do we have? We can still exploit this very point. It is at the turning point, so we can find the derivative of h of x and still substitute the same coordinate. We say that h of x is equals to ax to the power 3 plus bx to the power 2. If we derivate this, we're gonna get h prime of x being equals to 3ax squared plus 2bx. At the turning point, the gradient is 0. So we can substitute b all over again. But then this time, we're gonna get 0 being equals to 3a x is 4 squared plus 2b multiplied by 4. So we're gonna get 0 being equals to 4 squared, that is 16, 16, 32, 48. So we have 48a plus 8b. So 0 is equals to 48a plus 8. In place of b, let's put equation 1. So if we do that, we're gonna have 2 minus 4a. 0 being equals to 48a plus 16 minus 32a. Minus 16 will be equals to, what is 48 minus 32? That is 16a. If we divide both sides by 16, we're gonna get a is equals to minus 1. If a is equals to minus 1 and b is equals to 2 minus 4a, then b should be equals to 2 minus 4 multiplied by minus 1. b is equals to 6. And this is what we are required to show. Let's look at the following equation, 10.2. We're supposed to calculate the coordinates of a. A is one of the x-intercept of our graph h of x. So x-intercept will let y be equals to 0. If we do that in this situation, we're going to have 0 being equals to ax to the 3. But we know that a is minus 1. So we're going to have minus x to the power 3 plus bx squared. b is 6. So we're going to have 6x squared. If we divide both sides by minus 1, we're going to get x to the power 3 minus 6x squared being equals to 0. We can take x squared as a common factor. We're going to have x squared multiplied by x minus 6 being equals to 0. So x is equals to 0 or x is equals to 6. We know that x is equals to 0 is at the origin. So x is equals to 6 should be the x coordinate of a. So a is the x-intercept. So we know that the value of y is 0. So we're going to have the coordinates of a being 6 and 0. 0 is coming from the fact that it is an x-intercept. It is not this value here. No. That's not how it works. Let's move ahead and look at 10.3. So the question here says that 10.3.1, let's write down the values of x for which h is increasing. We need the values of x for which h is increasing. H is increasing when the slope is positive. From 0, that's our turning point, up to x is equals to 4. Another turning point. So it is increasing in between 0 and 4. At 0 and at 4, it is stationary. It is neither increasing or decreasing. So we can say that when x is between 0 and 4, our condition is satisfied. Let's move to the following question. 10.3.2. The values of x for which our function is concave down. So let me show you something. This is concave down, and right here we have concave up. So we need the value of x where the concavity changes. Somewhere here in the middle, the concavity is going to change. So how can we possibly find that value? You can say that x is equals to x of turning point 1 plus x of turning point 2 divided by 2. If you do this, you're going to be able to get the value of x for which the concavity changes. Another way of doing it, you can find the second derivative of your function and equate to 0. So we're going to have x being equals to the turning point here is 0. So we're going to have 0 plus the turning point here is at x is equals to 4. Everything divided by 2. So 4 divided by 2, that is 2. So when x is greater than 2, we can see clearly that our function is concave down. It is ultimately going down. It starts going up, but ultimately it is going down. 10.4. For which values of k will that equation have one negative and two distinct positive rows? I want you to realize something. This right here is just h of x minus 1. This is just h of x minus 1. So what does x minus 1 do to a function? It shifts it 1 unit to the right. If it was x plus 1, it would shift it 1 unit to the left. So let's just go ahead and shift this function 1 unit to the right first, and then we're going to look at everything else after. So if we shift it 1 unit to the right, then it should look something like this. If it is shifted 1 unit to the right, the positions of our intercepts changes. Let's look at what the question is actually asking us to do. We're supposed to look for the value of k that will lead to 1 negative and 2 distinct positive rows. So what does k do? K shifts your graph either upwards or downwards. If it is plus k, then you're shifting it k units up, and then if it is minus k, you're shifting it k units downwards. Let's go to a graph and make sense of the situation. So we need 2 distinct positive rows. How many rows do we have now? We have 1, 2, which are all positive. But then that doesn't satisfy our conditions. We need 2 positive and 1 negative. We're going to achieve that by shifting our graph. We need to shift our graph such that this y-intercept is now below the x-axis. If the y-intercept is below the x-axis, then our graph will have 1 negative root and 2 positive roots. So we need to find the value of that y-intercept. We have some f of x, which is equals to minus x minus 1 to the 3 plus 6x minus 1. In order for us to find the y-intercept, we need to let x be equals to 0. So let's see what we're going to get when we do that. If you put that in your calculator, you should get 7. So that tells us that we need to move this graph at least 7 units downwards. Let's say we move it to this point. If we move it to this point, you can see clearly that we're going to have 1 negative root and 2 positive roots. But then if we move it to this point, then we only have 1 root. So we need to move it at least 7 units downwards, but not greater than 32 units. Because if we move it more than 32 units, then we end up with 1 negative root. So it needs to be somewhere here. Then our conditions will be satisfied. So what are we saying? We're saying that we need k to be between 7 and 32. If you take a look at 1.1.1, the equation is already factorized. We just need to equate to 0. So we're going to have 3x minus 6 being equals to 0, or x plus 2 being equals to 0. We're going to have 3x is equals to 6. We divide both sides by 3. We get x is equals to 2. And if x plus 2 is equals to 0, then x needs to be equals to minus 2. So these are our two answers. X is equals to 2 or x is equals to minus 2. When the equation is already factorized, you don't multiply out like I see some people do. Right. 1.1.2. We're supposed to solve for 2x squared minus 6x plus 1 correct to 2 decimal places. That just tells us that we need to use the quadratic formula. We're going to have x being equals to minus b plus or minus the square root of b squared minus 4ac. Everything divided by 2a. This is the value of a. Minus 6 is b and 1 is c. If we substitute, we're going to have x being equals to minus multiplied by minus 6 plus or minus the square root of b squared. B is minus 6, so we're going to have minus 6 squared minus 4 multiplied by a, which is 2, multiplied by c, which is 1. Everything divided by 2a. So the value of a is 2. So we just have something like that. X will be equals to 2.82, or x will be equals to 0.18. These are the values of x correct to 2 decimal places. Quite an easy one. We just substituting in the quadratic formula. Let's take a look at 1.1.3. So in 1.1.3, we have x squared minus 90 being greater than x. Let's take x to the left hand side. We're going to have x squared minus x minus 90 being greater than 0. At this point, what you want to do is to find your critical values. How do we do that? We let x squared minus x minus 90 be equals to 0. Now we just need to factorize this. In factorizing this, we are looking for two numbers that when we multiply, we get minus 90, and when we add, we get minus 1. That is plus 9 and minus 10 being equals to 0. So x is equals to minus 9 or x is equals to 10. These are our two critical values. There's one thing we need to figure out. Our critical values is minus 9 and 10. We need to see if our answer lies between minus 9 and 10 or outside of that range. So let's go ahead and find out. What we can do, we can substitute 0 because it is a number between minus 9 and 10. If x squared minus 10 is greater than x is satisfied when we substitute 0. That means that all our answers lie between minus 9 and 10. But then if our equation is not satisfied, then it will tell us that our answer does not lie between minus 9 and 10. We need x to be less than 9 and x to be greater than 10. So let's go ahead and find out. X squared minus 90 being greater than x. Let's substitute 0. So we have 0 squared minus 90 being greater than 0. Minus 90 is greater than 0. Well, we can clearly see that this is not the case. Minus 90 is not greater than 0. So our answer does not lie between minus 9 and 10. Our inequality is not going to be satisfied. We're going to get an answer that is mathematically wrong, which will tell us that our answer does not lie between minus 9 and 10, but it actually lies outside. So what can we say? We can say that x is less than minus 9 or x is greater than 10. That is our final answer. 1.1.3. Let's take a look at 1.1.4, an interesting question. So we have x minus 7 square root of x being equals to minus 12. Well, I have square root of x, so I want to square both sides. But then if I have this x and I'm squaring both sides, it gets complicated. So let me take minus 7x to the right hand side and take minus 12 to the left hand side. I'm going to have x plus 12 being equals to 7 square root of x. Now I can go ahead and square on both sides. If I do that, x plus 12 squared, x multiplied by x, that is x squared, x multiplied by 12, that is 12, x multiplied by 2, that is 24x, plus 144 being equals to 49x. So now we need to take 49x to the left hand side. We're going to have x squared 24 minus 49, that will be minus 25x, plus 144 being equals to 0. So now we just need to factorize this. We're asking ourselves the same question again. Which two numbers do we multiply and get 144? But when we add them, we get minus 25. That is minus 16 and minus 9. So we're going to have x minus 16, x minus 9 being equals to 0. So x is equals to 16 or x is equals to 9. Usually when you square both sides, one of your answers is not correct and you need to find that answer and cancel it out. But in our case, all our answers hold. But just be careful. Next time, when you're solving a problem and you end up squaring both sides and get rid of a square root, one of your answers may not be correct and you need to figure out which one is that one. Right, 1.2. Let's solve for x and y simultaneously. We have 2x minus y being equals to 2. I'm going to make y subject to the formula because it is less complicated. If I make x, I'm going to have to divide both sides by 2, which I don't want to do. So I'm going to have minus y being equals to 2 minus 2x. Divide both sides by minus 1. Y is equals to 2x minus 2. Well, I can call this equation 1, but I don't even have to do that. I can just solve it without calling anything equation 1. And then now we have x multiplied by y being equals to 4. In place of y, I can just substitute equation 1. So I'm going to have x multiplied by 2x minus 2 being equals to 4. X multiplied by 2x, that is 2x squared, and then minus 2x being equals to 4. Let's take 4 to the left hand side. We're going to have 2x squared minus 2x minus 4 being equals to 0. If we divide every term by 2, this is just x squared minus x minus 2 being equals to 0. Let's go ahead and factorize this. Two numbers that when we multiply, we get minus 2, and when we add, we get minus 1. So that is minus 2 and plus 1. X is equals to 2 or x is equals to minus 1. If x is equals to 2, what is the value of y? Let's find out. When x is equals to 2, y will be equals to 2. I'm substituting into this equation. Right. Y will be equals to 2 multiplied by 2 minus 2. Y will be equals to 2. Or y will be equals to 2 multiplied by minus 1 minus 2. So y will be equals to minus 4. 1.3. Let's take a look at 1.3. So in 1.3, we're supposed to show that 2 multiplied by 5 to the n minus 5 to the n plus 1 plus 5 to the n plus 2. It's even for all positive integer values of n. All right, let's see how we can possibly show that. What I'm realizing here is that we have 5 to the n on this first term, we have 5 to the n on the second term, and we have 5 to the n on the last term. It seems like it would be a good idea to take 5 to the power n as a common factor. Let's go ahead and see how that will look like. This will be equals to 2 multiplied by 5 to the n minus 5 to the n plus 1. 5 to the n plus 1 is just 5 to the n multiplied by 5 to the 1. Because if you multiply these two numbers, you add the exponents and you get 5 to the n plus 1. Let's do the same for the last term. This will be 5 to the n multiplied by 5 to the power 2. Right, so now we can take a common factor of 5 to the power n. As you can clearly see that we have 5 to the power n as a common factor. Right, if I take 5 to the power n on the first term, I'm going to be left with 2. On the second term, I'm left with minus 5. And then on the third term, I'm left with plus 5 to the power 2. So 5 to the power n multiplied by, so 5 to the power 2, that's 25. And then we have 2 minus 5 minus 3 plus 25. That is 22. So we have 5 to the power n, 22. 22 is an even number. And if we multiply it by any integer, the answer is going to be even. So that's why we say that this expression will always be even for all positive integer values of n. Right, that is 1.3. Let's do 1.4. The last question. Determine the values of x and y if 3 to the power y plus 1 divided by 32 is equals to the square root of 96 to the power x. Right, so we have 3 to the power y plus 1 and we have 32. Can we write 32 with the base of 3? Because usually in a case like this, we're trying to give all the numbers the same base. Well, we can't, but we can write it with a base of 2. So let's go ahead and try that and see what we're going to have. We will have 3 to the power y plus 1 divided by 2 to the power of 5 being equals to square root of 96x. Can we write 96 with a base of 3 or with a base of 2? Well, we can do that at the same time. Why do I say so? We're going to have the square root of, if you want to write 96 using prime numbers, you have 2 to the power 5 multiplied by 3 to the power 1, everything to the power of x. Yes, 2 to the power 5 multiplied by 3 to the power 1 is equals to 96. Let's get rid of the square root on the right hand side. We're going to have 3 to the y plus 1 divided by 2 to the power of 5. We don't have to necessarily square both sides. We can just say that 2 to the power 5 multiplied by 3 to the power 1 to the power x divided by 2. And just like that, we have gotten rid of the square root. So 3 to the power y plus 1 divided by 2 to the power 5 will be equals to 2 to the power 5x divided by 2 multiplied by 3 to the power x divided by 2. This is the same as 3 to the power y plus 1 multiplied by 2 to the power minus 5. We're taking it from the denominator to the numerator, so it must have a minus sign on the exponent. This will be equals to 2 to the power 5x divided by 2 multiplied by 3 to the power x divided by 2. We can equate minus 5 and 5x divided by 2 and y plus 1 with x divided by 2. So if we say minus 5 is equals to 5x divided by 2 and we cross multiply, we're going to get 5x being equals to minus 10. So x is equals to minus 2. Now we have the value of x, so let's go ahead and find the value of y. Y plus 1 is equals to x divided by 2. But we know fully well that x is equals to minus 2. So we're going to have minus 2 divided by 2 minus 1. So minus 2 divided by 2 minus 1 minus 1 minus 1 minus 2. So y is equals to minus 2. The first term of a geometric series is 14 and the sixth term is 448. The first question, 2.1.1, we're supposed to calculate the value of the constant ratio r. So let's go ahead and dissect our information. The first term, t1, is equals to 14, which is just a. So a is equals to 14. On the other hand, t6 is equals to 448. T6 is AR to the power 5. This is equals to 448. But we have the value of A. A is 14. So we have 14 multiplied by R to the power 5 being equals to 448. Now we need to divide both sides by 14. If we do that, we're going to get R to the power 5 being equals to 32. So R to the power 5 is equals to 2 to the power 5. It should be easy to see now that R is equals to 2. This is our common ratio of our geometric series. Let's go ahead and do 2.1.2. Determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Right, so we have a sum Sn which is equals to 114,674,000. We have a common ratio which is equals to 2. Our first term is equals to 14. And we can find the number of terms that will give us a sum of 114,674. So if we just go ahead and find the number of terms required to give us a sum of 114,674 and subtract 6 from that number of terms, we're going to have the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain that sum. Let me show you what I'm talking about. We're going to have Sn being equals to A multiplied by R to the power n minus 1 divided by R minus 1. The sum is 114,674. A is equals to 14, R is equals to 2, n is what we're interested in, minus 1 divided by 2 minus 1. If we cross multiply, this is 2 minus 1, right, which is just 1. We're going to have 114,674 being equals to 14 multiplied by 2 to the power n minus 1. So we are dividing both sides by 14. If we do that, we're going to have 8,191 being equals to 2 to the power n minus 1. If we take minus 1 to the left hand side, we're going to have 2 to the power n being equals to 8,192. So we can take log on both sides. We're going to have n log of 2 being equals to log of 8,192. So n is equals to the log of 8,192 divided by log of 2. Right. If you put that in your calculator, you're going to get 13. In order to get a sum of 114,674, we need 13 terms. So how many consecutive terms must be added to the first 6 terms? That is 13 minus 6, which is equals to 7. So to the first 6 terms, we need to add 7 more terms in order to get a sum of 114,664. Let's move to the following question, 2.1.3. If the first term of another series, so we have A being equals to 448, and the sixth term, so we have AR to the power 5 being equals to 14. Calculate the sum to infinity of the new series. So we have A. Another point of information we need is R. If we substitute A into this equation, we're gonna have 448 r to the power 5 being equals to 14. So r to the power 5 is equals to 14 divided by 448. So we can just take everything to the power 1 divided by 5. So 5 and 5 cancels out. We have r being equals to 1 divided by 2. So there we go. We have our common ratio. It is 1 divided by 2. So the sum to infinity will be equals to a divided by 1 minus r. A is 448 and then r is 1 divided by 2. This is equals to 896. And there we go. We have our sum to infinity. 2.2, let's take a look at 2.2 and see what is happening there. So in 2.2, we're given some sigma notation and the sum, right? We're supposed to determine the value of k. Let's make sense of k. K plus 1 is the number of terms we have in our series. Meaning that if we can find the number of terms we have in our series, then k will just be the number of terms minus 1. Okay, so let's go ahead and find the terms of our series. T1 will be equals to, so we substitute in p into this equation. T1 will be equals to 1 divided by 3. P is starting from 0 plus 1 divided by 6. This is just 1 divided by 6, right? And then T2 on the other end, 1 divided by 3 multiplied by 1 plus 1 divided by 6. This is 3 divided by 6. And then T3 will be equals to 1 divided by 3 multiplied by 2 plus 1 divided by 6. This is 5 divided by 6. T1, T2, T3. Let's see how our series looks like. So we have 1 divided by 6 plus 3 divided by 6 plus 5 divided by 6. Do we have a common ratio or do we have a common difference? We need to determine whether it is geometric or arithmetic. 5 divided by 6 minus 3 divided by 6 is 2 divided by 6. 3 divided by 6 minus 1 divided by 6 is 2 divided by 6. So we have a common difference. It means that it is arithmetic. The equation we can use to find the sum, we say that Sn is equals to n divided by 2 multiplied by 2a plus n minus 1 multiplied by the common difference. What is the sum? The sum is given by 21 divided by 6 being equals to n. N is what we're interested in. Multiplied by 2a. A is the first term, which is 1 divided by 6, plus n minus 1 multiplied by the difference, which is 2 divided by 6. So 21 divided by 6 is the same as 20 multiplied by 6. That is 120. You plus 1, so this is 121 divided by 6. Being equals to n divided by 2, and then 2 multiplied by 1 divided by 6 is 2 divided by 6, and then n multiplied by 2 divided by 6 is going to be 2n divided by 6, and then minus 2 divided by 6. As you can clearly see, 2 divided by 6 minus 2 divided by 6 will give us 0. So we just have 121 divided by 6 being equals to n divided by 2 multiplied by 2n divided by 6. So 121 divided by 6 will be equals to 2n squared divided by 12. This is the same as 121 divided by 6 being equals to n squared divided by 6. So we can drop the 6's and just equate the numerators. N squared is equals to 121. So n should be equals to plus 11 and not minus 11. We cannot have minus 11 number of terms. So we have 11 terms, which means that k will be equals to 10. We're given a quadratic number pattern Tn that is equals to n squared plus bn plus 9. And the first term of the first difference is 7. The first question, 3.1, show that b is equals to 4. Let's look at the information we have. We have the equation for the quadratic number pattern, but we have a variable b which we need to figure out. Another piece of information that we have is that the first term of the first difference is 7. It means that t2 minus t1 of the quadratic number pattern will be equals to 7. Let's go ahead and find t2 and t1. So in place of t2, we're just substituting 2 into tn, right? We're going to have 2 squared plus b multiplied by 2 plus 9 minus t1. So that is going to be 1 squared plus b multiplied by 1 plus 9 being equals to 7. So what is 2 squared? That is 4 plus 2b plus 9. And then 1 squared, we're going to get minus 1. B multiplied by 1, we're going to have minus b, and minus 9 being equals to 7. If we solve that, we're going to get 4 plus 9, 13, minus 1, 12, minus 9, 3. So we have 3. 2b minus b, that is 3 plus b, being equals to 7. If we take 3 to the right hand side, we're going to get b being equals to 7 minus 3, which is just equals to 4. And just like we are required to show, b is equals to 4. That is 3.1. 3.2, determine the value of the 60th term of this number pattern. So we're looking for T60. T60 will be equals to n squared plus 4n plus 9. Now we no longer have b because we have showed that it is indeed equals to 4. So T60 will be equals to 60 squared plus 4 multiplied by 60 plus 9. Now it's just a matter of putting that in your calculator. You shall get 3,849 as the value of the 60th term. That is 3.2. Let's take a look at 3.3. In 3.3, we're supposed to determine the general formula for the sequence of first differences of the quadratic number pattern. And we're supposed to write our answer in the form TP is equals to MP plus Q. Let me show you something. Let's say we have T1, T2, T3, and T4. And we find the differences of 2 consecutive terms, A, B, C. And then now we have our common difference, which is D and D. We're looking for the general term of this sequence, which is going to be linear with a common difference. In order to do that, we need to find T1, T2, T3, and T4, and then compute this and ultimately this. From that, we're going to be able to find the general term. So let's go ahead and find T1. T1 will be equals to 1 squared plus 4 multiplied by 1 plus 9. This is equals to 14. While T2, on the other hand, will be equals to 2 squared plus 4 multiplied by 2 plus 9. This is equals to 21. And then the T3 will be equals to 3 squared plus 4 multiplied by 3 plus 9, which is equals to 30. And lastly, T4, we're going to have T4 being equals to 4 squared plus 4 multiplied by 4 plus 9. So 16, 32, 41. So we have T4 being equals to 41. So we're going to have 14, 21, 30, and 41. So let's go ahead and find the differences of these terms. 21 minus 14, that is 7. We know that the first difference of the first two terms is 7. 30 minus 21, 9. And then 30 not 30 but 41 minus 30, that is 11. So we can see that 9 minus 7 will be 2, 11 minus 9 will be 2. So we're looking for the general term of this sequence with a common difference of 2. So we're going to have Tn being equals to A plus n minus 1 multiplied by d, because we have a common difference. This is an arithmetic sequence or pattern. Right, so Tn will be equals to A, the first term. The first term of the arithmetic pattern is 7. So we're going to have 7 plus n minus 1 multiplied by d. We know that d is equals to 2. So Tn will be equals to 7 plus 2n minus 2. So Tn is equals to 2n plus 5. We're supposed to call it Tp and not Tn. So let me just rectify that. Tp is equals to 2p plus 5. There we go. Let's go to 3.4. The last question. So in 3.4, which two consecutive terms in the quadratic number pattern have a first difference of 157? Which two terms in the quadratic number pattern has a first difference of 157? This is a very common question. Well, we have the formula for the first differences. So we can find the position of 157 in the pattern of the first differences. So Tp is equals to 2p plus 5. And in which position is 157 situated? 2p plus 5. Let's go ahead and find the value of p, the position of 157 in the general term of the first sequences. So 157 minus 5, that will be 152 being equals to 2p. So if we divide both sides by 2, we get p being equals to 76. Let me show you something. T1 of the first differences is between T2 and T1 of the quadratic. And then T3 is between T4 and T3. If 157 is in position 76, it would mean that it is between T77 and T76.
Sketch below is the graph h of x. So we have h of x being equals to 1 divided by x plus p plus q. The asymptotes of h intersected a coordinate 1, 2, right? That's where we have our coordinate sim, right? Let's just call it a sim. And then 4.1.1 says that let's write down the values of p and q. The values of p and q. So q is the horizontal asymptote, right? So q is equals to 2. We can see it here from our graph, right? That's from our general knowledge of a hyperbola. So q is equals to 2. That's what we know, right? And then now we're looking for p, right? So if you look at this equation of the hyperbola here, we have x plus p, right? So to find p, you say x plus p is equals to 0, right? So x is equals to minus p. But then from our graph, we have the value of x. X is 1, right? So now you can see that minus p is just equals to 1. So if you solve for p here, you're going to get p is equals to minus 1. So q is equals to 2 and p is equals to minus 1, right? Hence we have our asymptote at x is equals to 1, because if x is 1, then we have 1 divided by 0, which we're not supposed to have. Let's do 4.1.2. So 4.1.2 is saying that let's calculate the coordinates of the x-intercept of h. So as soon as I hear x-intercept, I'm letting y be equals to 0, right? So from h of x, I'm going to put 0, and then we have 1 divided by x minus 1 plus 2, right? So now if we take 2 to the other side, we're going to get minus 2 is equals to 1 divided by x minus 1. So minus 2x plus 2 is equals to 1. So minus 2x is going to be equals to 1 minus 2, that will be minus 1. So x is equals to 1 divided by 2. So our coordinate is 1 divided by 2 and 0. Let's do 4.1.3. 4.1.3 says that let's write down the x coordinate of the x-intercept of g. If g of x is equals to h and then x plus 3, right? So let's understand what g of x is doing to h of x. G of x is moving h of x 3 units to the left. If we have plus 3, we're moving 3 units to the left. If we have minus, we're moving 3 units to the right. It's counterintuitive, I know, but then it is what it is. So g of x, you just move h of x 3 units to the left, right? So if the x-intercept was at 1 divided by 2, now we have to move it 3 units to the left. How can we move it 3 units to the left? We're gonna say 1 divided by 2 minus 3, right? That's exactly what you're gonna say. And if we compute this, we're saying that x is equals to 1 divided by 2 minus 3, which will be equals to minus 2.5, right? So the new x coordinate of the x-intercept will be x is equals to minus 2.5 because we have moved h of x 3 units to the left. Now let's do 4.1.4. 4.1.4 says that the equation of an axis of symmetry of h is y is equals to x plus t. Determine the values of t. So we are given the slope, right? We just have to find t. So if you have an axis of symmetry, the point you substitute is this point here, where the axis of symmetry intersect. You substitute that point if you want, where the asymptotes intersect, I meant. That's the point you substitute if you want to find an equation of the axis of symmetry. So if we substitute that point, right, we're going to get 2 being equals to 1 plus t, so 2 for the y and 1 for x. Yeah, so we're gonna get 1 is equals to t. So the axis of symmetry is y is equals to x plus 1, and we just asked to find t, and then there we have t. So I think we're good to go. The last question, 4.1.5, says that let's determine the values of x for which minus 2 is less or equals to 1 divided by x minus 1. Let me show you something. If we take minus 2 to the right hand side, we're going to get 0 being less or equals to 1 divided by x minus 1 plus 2. And this is the equation we have in the graph, right? So what this question is asking us is to find the values of x for which the graph is at 0 or above, right? The values of x for which the graph is at 0 or above, right? So let's look for that. Let me just erase this so that we can have a bit of clarity. So let's go to our graph, right? We don't have to do this algebraically. Obviously you can, but then we don't have to if we have the graph already. So let's look at the graph. We can see here that for this part of the graph, this part here, the graph is greater than 0, right? So for all those values of x on that part, they satisfy what we're looking for. So we can say that when x is greater than 1, our equation is satisfied because h of x is clearly greater than 0, right? Now let's look at the other wing. We know that the x-intercept is here, right? And we've calculated it. That's when x is equals to 1 divided by 2, right? But if we go to the left, then our graph h of x is above 0, right? So on that side, we can say that when x is less or equals to a half, our equation is satisfied because h of x is either equals to right at x is equals to 1 divided by 2 or greater than when x is less than 1 divided by 2. Now I'm under the impression that if the sketches look complicated, then the questions are actually easy. And then if the sketch look kind of plain, and then the questions might be hard. So let's see what's happening in this question here, right? So for 4.2.1, the question is saying that let's write down the y coordinate of C, right? So clearly we have two graphs here, f of x, which is x squared minus 4x minus 5, right? Which is the quadratic function you see on the graph. And then we have an exponential function, g of x, right? Which is a multiplied by 2 to the x plus q. And then e and h are the x-intercept. We have e here, as you can see, and then we have h here being the x-intercept. So this line here is actually our x-axis, and this line here is our y-axis, right? And then c is the y-intercept of f. So we have c here being the y-intercept of f, and it lies on the asymptote of g. Okay, c is the y-intercept and it lies on the asymptote of g. The two graphs intersect at d, so they're intersecting here at d, the turning point of f. So the first question, the y coordinate of c. So c is the y-intercept of f, right? So if we're looking for the y-intercept, we always let x be equals to 0, right? So for that function f of x, if we do that, we're gonna get f of 0 being equals to 0 squared minus 4 multiplied by 0 minus 5, right? So it should be easy to see here that f of 0 is gonna be equals to minus 5, right? So the coordinate, the y coordinate of c is clearly minus 5, right? Because that's what we get when we let x be equals to 0. And then the next question, 4.2.2, let's determine the coordinates of d. D is the turning point of f of x, right? So we have f of x, let's not forget, being equals to x squared minus 4x minus 5, right? If we want to find the coordinates of the turning point, it's beneficial if we start with the x value of the turning point, right? Because we have a formula for that. We can say that x will be equals to minus b divided by 2a. So this will be equals to, so b is the coefficient of x, right? So that's supposed to be minus 4. And then a is the coefficient of x squared. So we're just going to have 1 there. So now we can see that x at the turning point should be equals to 2, right? Now that we have that 2 there, we're just going to substitute it in the equation f of x, right? F of 2 being equals to 2 squared minus 4 multiplied by 2 minus 5, right? So this will be equals to, so we have 4 minus 8 minus 5, and that should be equals to minus 9, right? So the coordinate of d, we have 2 for the x value and minus 9 for the y value, right? It's easy to see. Now let's do 4.2.3. So 4.2.3, we're looking for the values of a and q, right, from our graph g of x. So g of x is equals to a multiplied by 2 to the x plus q, right? Q is the asymptote of our graph, but we are told that the asymptote of g is at the y-intercept of f. So now we can easily say that q is equals to minus 5. So if q is equals to minus 5, then we have g of x being equals to a multiplied by 2 to the x minus 5, right? So now what we can do here, we can substitute the coordinate d so that we can find a, right? D has coordinates 2 and minus 9, because d lies on f of x and g of x, so we can substitute it in that equation. So if we substitute it, we shall get minus 9 is equals to a multiplied by 2 to the 2 minus 5, right? So minus 9 equals to 4a minus 5, right? So minus 4 is equals to 4a. So a is equals to minus 1, right? So we have determined the value of a, and we have determined the value of q, right? Let's do 4.2.4. So 4.2.4 is saying that let's write down the range of g, right? So we have g of x being equals to minus 2 to the x minus 5, and we're supposed to determine the range of the graph, right? We can just easily look at the sketch here, right? Because as you can see, the y values will never be greater than minus 5, right? They actually never touch there. The y value gets approximately approximately it gets infinitely closer to minus 5, but then it never really touches minus 5, right? But then going down, the y value goes to minus infinity, basically, right? So we're saying that the y value will always be less than minus 5, right? The y value is always going to be less than minus 5. So 4.2.5, determine the values of k for which the value of what? F of x minus k will always be positive, right? If we come to a graph f of x here, our turning point is here at d, where the y value is minus 9, right? So we know if we have f of x plus 3, then that moves the entire graph 3 units up, and then if we have f of x minus 3, then that moves the entire graph 3 units down, right? Then we have to shift it more than 9 units up, right? If we want our graph to always be positive, because if we shift it more than 9 units up, then it's going to be above the axis, so all the values will be positive, right? But here, the tricky thing is here, we have f of x minus k, right? So if k here is less than minus 9, then we will have shifted our graph enough units such that the entire function f of x is positive.
We have two functions, g of x and the g inverse. We're supposed to find the y coordinate of b, the y-intercept of g of x. We are given the equation g of x being equals to 2x plus 6. If you want to find the y-intercept, you let x be equals to 0. So we're going to have g of 0 being equals to 2 multiplied by 0 plus 6. So y is going to be equals to 6. 2 multiplied by 0 is just 0. So that is the y coordinate of b. 5.1. Let's take a look at 5.2. Determine g inverse in the form g inverse is equals to mx plus n. We know that g of x is equals to 2x plus 6. In order to find the inverse, we need to swap x and y and solve for y. So in place of y, we're going to put x, and in place of x, we're going to put y plus 6. So 2y is equals to x minus 6. We just need to divide both sides by 2. So we're going to get y being equals to 1 divided by 2x minus 3. This is the equation of g inverse. Now we can conclude and say that g inverse of x is equals to a half x minus 3. Let's move to 5.3. In 5.3, we're supposed to find the coordinates of a. Let's go ahead and take a look at a. A is where g of x and g inverse touch. So in order to find the coordinates of a, we have to equate the two equations. If we do that, we're going to have 2x plus 6 being equals to a half x minus 3. Let me take a half x to the left hand side. If I do that, I'm going to get 3 divided by 2x being equals to minus 9. I'm taking plus 6 to the left hand side. I'm going to get minus 3 minus 6, which is minus 9. Now what I have to do is to divide both sides by 3 divided by 2. If I do that, I get x is equals to minus 6. So that is the x value at a. Now I just have to substitute x is equals to 6 into g of x, or g inverse. If I substitute it into g of x, I'm going to get 2 multiplied by minus 6 plus 6. So 2 multiplied by minus 6, that is minus 12. Minus 12 plus 6 is minus 6. So the coordinates of a is minus 6 and minus 6. That is 5.3. Quite easy to compute. Let's take a look at 5.4. In 5.4, we're looking for the length of AB. We have the coordinates of A and we have the coordinates of B. So finding the length of AB should be pretty much straightforward. We're going to have AB being equals to, we're going to use the distance formula. That is x2 minus x1 squared plus y2 minus y1 squared. This will be equals to So the coordinates of B, we have 0 and 6. The coordinates of A, we have -6 and -6. If we take B as our second point, we're going to have 0 minus -6. So that is just 0 plus 6 squared plus y2. Y2, the y value of B is 6. So that will be 6 minus -6. So that is 6 plus 6 squared. So this will be 6 squared, 36, and then 12 squared, 144. 144 plus 36, 180. So AB is equals to square root of 180. Obviously, you can further simplify that and get 6 square root of 5. AB, let's do 5.5, the interesting question really. So in 5.5, we're supposed to calculate the area of triangle ABC. So let's just go ahead and highlight that triangle. There's quite a couple of ways we can use to find the area of triangle ABC. Let's just try this first. You can find the area of triangle DBC. Let me highlight it. We can find the area of this triangle. How can we possibly do that? We have the base DC and we have the height OB. We have the length of DC and we have the length of OB. And we can also find the area of triangle DAC, this area right here. We have the base DC again, but now we have this height of which we know the length, right? So we can go ahead and say that the area of triangle ABC is equals to the area of triangle BDC plus the area of triangle DCA. This is going to be equals to a half base. The base of triangle BCD is DC. What is the length of DC? The x-coordinate of C is 6 and the x-coordinate of D is -3. So from D to C is 9 units. So we're going to have that there. And then the height from O to B is 6 units. The y-coordinate of O is 0 and the y-coordinate of B is 6. So we're going to have 9 multiplied by 6 plus the area of triangle DCA. The base is DC. We know that DC is 9 units. And then now let's talk about this height. The y-coordinate A is -6 and the y-coordinate at the x-axis it is 0. So that distance should also be equals to 6. This is equals to 54 units squared. 12,000 was invested in a fund that paid interest at M% per annum, compounded quarterly. After 24 months, the value of the investment was 13,459. Determine the value of M. Let's go ahead and dissect the information we have. Our principal amount is 12,000 and our accumulated amount is 13,459. Our interest is what we're supposed to find, M%, which is just M divided by 100. It is compounded quarterly. Right, we know what to do with that information. After 24 months, the value of the investment was 13,459. So how many quarters do you have in 24 months? N is equals to 8. We're going to have the accumulated amount being equals to the principal amount multiplied by 1 plus I, everything to the power N. The accumulated amount is 13,459. The principal amount, 12,000 multiplied by 1 plus I, the interest, which is M divided by 100. Everything divided by 4. Why are we dividing by 4? Because it is compounded quarterly. Everything to the power 8. The most organic step is dividing both sides by 12,000. If we do that, we're going to have 1 plus M divided by 400, everything to the power 8, being equals to 13,459 divided by 12,000. M divided by 100 divided by 4 is the same as M divided by 400. So we can just write that instead. Now what we want to do is get rid of this 8. How do we do that? On the left hand side, we're going to have 1 plus M divided by 400, everything to the power 8, everything to the power 1 divided by 8. We want 8 and 8 to cancel out, but we have to do the same thing on the right hand side. On the right hand side, we're going to have 1.121 to the power 1 divided by 8. We're going to have 1 plus M divided by 400 being equals to 1.121, everything to the power 1 divided by 8. It's obvious what we need to do at this point. We need to take 1 to the right hand side and multiply both sides by 400. We're going to have M being equals to 1.121, everything to the power 1 divided by 8 minus 1 multiplied by 400. That's all we need to do to find the value of M, which is equals to 5.78%. Let's go ahead and do 6.2. In 6.2, on Jan 31st, somebody deposited 1,000 in an account that paid interest at 7.5% per annum compounded monthly. Right, we need to note that he continued depositing 1,000 on the last day of every month. He will make the last deposit on 31st December 2022. Will Tino have sufficient funds in the account on 1 Jan 2023 to buy a computer that costs 13,000? Justify your answer by means of an appropriate calculation. Let's make sense of our situation. So the first deposit is on the 31st of Jan, and the last deposit will be on the 31st of December. So that is 12 deposits, our value of N. So we have N being equals to 12. We have our monthly installments, or our monthly savings, being equals to 1,000. What is another piece of information we have? We have the interest, which is equals to 7.5% compounded monthly. How much money is he gonna have at the beginning of the following year? That's what we're trying to figure out. We're gonna have the future value. This is future value because we are saving money and making monthly contributions. It's gonna be equals to X multiplied by 1 plus I, everything to the power N minus 1, everything divided by I. Let's go ahead and substitute. The value of X, our monthly contributions, that is 1,000 multiplied by 1 plus the interest, which is 7.5%, divided by 12. We divided by 12 because it is compounded monthly. Everything to the power 12 minus 1 divided by the interest. The interest again, 7.5%. We're still dividing that by 12 because it is compounded monthly. If you put that in your calculator, you're going to get 12,421.22 rands, which is less than 13,000. We are not going to be able to purchase that computer that costs 13,000 because our future value is less than that. That is 6.2. Let's take a look at 6.3, 6.3.1. So Tower plans to buy a car that costs 250,000. He will pay a deposit of 15% and take out a loan for the balance. The interest on the loan is 13% per annum compounded monthly. 6.3.1. Let's calculate the value of the loan. So he wants to buy a car that costs 250,000. He will deposit 15% of that amount and finance the rest. So what is the value of the loan? The value of the loan is equals to 250,000 multiplied by 85%. The 15% is the deposit he is deciding to pay. So what is the amount of the loan? The amount of the loan will be equals to 212,500 rands, 6.3.2. The first payment will be made 6 months after the loan has been granted. The loan will be repaid over a period of 6 years after it has been granted. Calculate the monthly installment. We need to make note of something. He only starts repaying the loan 6 months after it has been granted. So during that 6 months, for the 5 months after the first month of taking the loan was accumulating interest. We are only considering the 5 months because the month you take the loan, it is not going to accumulate any interest. So we're going to have A being equals to P, 1 plus I, everything to the power N. So the new loan will be equals to the principal, which is 212,500 rands multiplied by 1 plus the interest, which is 13% compounded monthly. So that will be 13% divided by 12, everything to the power 5, like we are saying. If you put that in your calculator, you're going to get 224,262.53 cents as the balance 6 months after the loan has been granted. Let's go ahead and compute the next part of our problem. We know fully well that when we are repaying a loan, we use P is equals to X multiplied by 1 minus 1 plus the interest, everything to the power minus N, everything divided by I. This is the monthly installments we're looking for. And P is the loan amount or the value, which is 224,263 rands 53 cents. So we're going to have 263.53 being equals to X. Everything multiplied by 1 minus 1 plus the interest, 13%. We divide that by 12, everything to the power minus N. So let's make sense of that minus N. So he's repaying the loan in 6 years, right? Let's concentrate on the first year. There's something that is happening there on the first year. The other 5 years, we just have 5 multiplied by 12, which is equals to 60. But what about the first year? How many payments are we going to make in our first year? Let's say the loan is being granted in Jan. So in Jan, it's not going to pay Feb, March, April, May. But at the end of the 6th month, which is June, he's going to make the first payment. So he's going to make a payment in June, July, August, September, October, November, December, which is 7. So he's going to make 60 plus 7 payments, which is 67. So that is our value of N. We need to familiarize ourselves with those kind of situations. So we have minus 67. The value of N is not 66, but 67. And that is a very common mistake. We are dividing everything by the interest, which is 13% divided by 12. We want to find the value of X, which will divide both sides by this coefficient of X. So X will be equals to 224,263.53 divided by the coefficient of X. This will be equals to 4,724 rands 96 cents.
First principles. So it's the limit as h tends into 0 of f of x plus h minus f of x, everything divided by h. So this part here, f of x plus h, we just take in the function itself, right? F of x, and everywhere where there is x, we put x plus h, and then minus f of x, we just subtract f of x. There's nothing special we're doing. So f prime of x will be equals to the limit as h tends into 0 of our function is x squared plus x, right? So we're gonna have x plus h in place of x, right? And then here again we're gonna have x plus h, and then we subtract f of x, the function itself, right? So we say in minus x squared plus x, and then we can divide everything by h. So f prime of x will be equals to the limit as h tends into 0 of, so we have x plus h squared, so x multiplied by x, that is x squared, and then x multiplied by h, that is xh. You multiply that by 2, you get plus 2xh, and then h by h, that is just h squared, right? And then plus x plus h, and then minus x squared, and then minus x, and then everything being divided by h. It should be easy to see here now that x squared minus x squared, so that's gone, right? And then we have x, and then we minus x, so that also disappears. So now we have f prime of x being equals to the limit as h tends into 0 of 2xh plus h squared plus h divided by h. So right now we're gonna take h as a common factor on the numerator, right? So we're gonna have the limit as h tends into 0 being equals to h. We have 2x, and then plus h, and then plus 1 divided by h, right? We just took h as a common factor. It's easy to see now that h in the denominator will cancel out with h on the numerator. So now we just left with 2x plus 1, right? And that's exactly what we're expecting, because if you derivate x squared plus x using the power rule, you expect to get 2x plus 1. Now let's do 7.2. 7.2 is quite straightforward, right? It says that let's find f prime of x if f of x is equals to 2x to the power 5 minus 3x to the 4 plus 8x. We're using the power rule, right? We know fully well that the power rule is saying that the derivative of x to some power n should be equals to nx to the power n minus 1. So if we apply this here, we're gonna get f prime of x being equals to 2 multiplied by 5, and then x to the 5 minus 1 minus 3 multiplied by 4, and then x to the 4 minus 1, and then plus 8 multiplied by 1, and then multiplied by x to the 1 minus 1. That should be equals to, so we have 2 multiplied by 5, 2 multiplied by 5, that is 10, and then 5 minus 1, that is 4, so we have 10, x to the power 4, and then minus 3 by 4, that is 12, and then x to the 3, 8 by 1, that is 8, and then x to the power 0 is 1, right? And the number to the power 0 is 1. And just like that, we already have 8 marks. And now let's do 7.3. So 7.3 is saying here that the tangent to g of x, if our function g of x is equals to ax cubed plus 3x squared plus bx plus c, has a minimum gradient at the point minus 1 and minus 7, right? For which values of x will g be concave up? For which values of x will g be concave up? I think if there's one thing we can agree on here is that this question will be extremely easy if we knew the value of a and the value of b, and then maybe I forgot plus c here. So maybe, let's give it a try. Let's see if we can find ABC. If we find ABC, then we're just going to derivate twice, equate to 0, and then we're going to be able to find for which values of x will g be concave up. So let's, go ahead and look at our equation and see what we can do here. So we can see here that the tangent, right, to g of x. So the tangent to g of x, let's find the equation of that tangent. So we're saying that g prime of x, we're trying to find the tangent to that graph. That will be 3ax squared, we just applying the power rule, right, plus 6x plus b, right? So now we have this tangent, right? Let's go ahead and substitute that point, -1 and -7, and see what we can do here. So if we substitute -1 and -7, we're gonna get -7 being equals to 3, and then a, and then -1 squared plus 6 -1 plus b, right? So we have -7 being equals to -1 squared, that will just be 3a, and then minus 6 plus b, right? So we can go ahead here and make b the subject of the formula, right? So that we don't have to divide, because if you make a the subject of the formula, you're gonna have to divide both sides by 3, and we don't want to do that. So if we do that, we're gonna get -7 plus 6, that will be -1, and then we take 3a to the other side, we get -3a being equals to b, right? So this is our equation 1, because you can see now we have 2 variables. So we need to think of another way we can use to find another equation, and then it will be straightforward. We are going to use the fact that -1 and -7, we find the minimum gradient of this graph here. We find the minimum gradient of this graph. So we can derive that equation again and equate to 0. Let me show you what I'm talking about. So we can say that g prime of x basically is equals to so if we derive that, that will be 6ax plus 6 being equals to 0, right? That's where the minimum gradient is. Minimum gradient is equals to 0. So again, we know the x value of that point, it is -1, right? So we can substitute that -1 in our equation. If we substitute that -1 there, we're gonna get 6a -1 plus b is equals to plus 6, not b, plus 6 is equals to 0. So here you're gonna see that -6a is equals to -6, so a is equals to 1. Right? So now we have determined that a is equals to 1. Now let's go to equation 1, to this equation here, and substitute 1 so that we can find b. If we do that, we're gonna say -1 minus 3 multiplied by 1 is equals to b. -4 is equals to b, right? So now we have the value of a and we have the value of b. Let's substitute them in our graph g of x, right? Because like we have already agreed on, if we find a and b, it becomes extremely simple to find for which values of h will g be concave up. So now we're saying that g of x is equals to, in place of a, we put 1 and then x to the 3, right? And then plus 3x to the 2 plus bx. So we know that b is -4, so -4x plus c, right? So now we have g of x is equals to x cubed plus 3x squared minus 4x plus c, right? So now we have this equation here. The only unknown variable we have is c, but then c doesn't really matter, right? It won't affect us with much, because for us to find the x value at the point of inflection, we have to derive twice, and when we derive twice, c is gonna fall apart, right? Because for us to know for which values will g be concave up or down, we need the x value of the point of inflection, right? I can tell you already that that x value will be -1, because that's where the minimum gradient of the tangent is. But you don't have to believe me, let's just work it out. So if we derive this twice in attempt to find the point of inflection, we're going to say that g prime of x will be equals to 3x squared plus 6x minus 4, right? And then we derive it again, we get 6x plus 6, right? And then this is equals to 0. So it should be easy to see now that x will be equals to -1, right? So our point of inflection is -1. Now let's look at our graph g of x, right? The coefficient of x to the power 3 is positive. If the coefficient of x to the power 3 is positive, our graph should look like this. So this is how our graph will look like, right? And we're saying that our point of inflection is somewhere here at -1, right? We're looking for the values of x, of which our graph G is concave up, right? So this is concave up, right? Because our graph is ultimately going up. So when x is greater than -1, our graph is concave up. The graph of y is equals to f prime of x is equals to mx squared plus nx plus k is drawn below. The graph passes through points P, Q, and R clearly, as you can see on the sketch, right? And then the first question, 8.1, is saying let's determine the values of m, n, and k, right? So we're given here that y is equals to mx squared plus nx plus k, right? And we're given the function and 3 points. As you can see here, we have 3 variables, m, n, and k, right? And we have 3 points. So with 3 variables and 3 points, we can set up 3 equations to try and find the answer, right? But then the easy way you would do this equation is if you substitute point r first, right? Because r is a y-intercept. When you substitute r, you're gonna get the value of k, right? So if we go ahead and substitute r, we're gonna get 1 is equals to m multiplied by x squared, x is 0, right? And then n multiplied by x, x is 0 again, plus k, right? M will fall away because we multiplied by 0. The same is true with n. So now we're left with 1 is equals to k, right? So now we know the value of k. So our function will become y is equals to mx squared plus nx plus 1, right? Now we just left with m and n, and we have the 2 points, right? So with the 2 points, let's see how we can determine m and n. So let's substitute point q first of coordinates 1 and 0, right? If we substitute that point, we're gonna get 0 is equals to m multiplied by 1 squared plus n multiplied by 1 plus 1, right? So we have -1 minus m being equals to n, right? Here I just took 1 and m to the left hand side, and then we can call this equation 1, right? From here we can substitute our point p, which is -1 divided by 3 and 0 in our equation, right? If we do that, we're gonna get so the y value is 0, so we're gonna get 0 is equals to m multiplied by -1 divided by 3 squared plus n multiplied by -1 divided by 3 plus 1, right? So we're gonna get -1, I'm taking this one here to the left hand side, being equals to 1 divided by 9m minus 1 divided by 3n. So again, let's make n the subject to the formula and equate the two equations, right? We're gonna get -1 minus 1 divided by 9m being equals to -1 divided by 3n. So we're gonna divide everything by -1 divided by 3, right? So if we say -1 divided by -1 divided by 3, that should give you 3. And then if you say 1 divided by 9 divided by 1 divided by 3, right? The negatives will cancel out. You will get plus 1 divided by 3m is equals to n. So now what are we saying? We're saying that -1 minus m. So let's call this equation 2, right? So if we equate equation 1 and 2, we're gonna get -1 minus m is equals to 3 plus 1 divided by 3m. All these two equations are equals to n, so they should be equals to each other, right? So if we rearrange, we get -1 minus 3 is equals to 1 divided by 3m plus m, right? So -1 minus 3, that will be -4, and then 1 divided by 3m plus m will be 4 divided by 3
m, right? So if we divide both sides by 4 divided by 3, we're gonna get minus 3 is equals to m. So now we can substitute this value of m in either equation 1 or 2, right? Equation 1 is more easy to digest, so let's substitute it there, right? So equation 1 was saying that minus 1 minus m is equals to n, right? So this will be minus 1 minus 3 being equals to n. So it's just minus 1 plus 3 is equals to n. So 2 is equals to n. So our equation now is y is equals to minus 3x squared plus 2n plus 1, right? We have determined the value of k. We have determined the value of n and m. Let's move to the second question, 8.2. 8.2 saying that it is further given that f of x, right? F of x is equals to minus x cubed plus x squared plus x plus 2. 8.2.1 says let's determine the coordinates of the turning points of f, right? And then let's look at the marker location. The marker location is 3, right? So here, when we derivate this equation, right, we're going to get y. When we derivate f of x, we're going to get this equation y, right? And then we're gonna equate this equation to 0. When we equate this equation to 0 and we solve for x, we're going to get x is equals to minus 1 divided by 3 and x is equals to 1. We can just substitute these two values into f of x, right? So one turning point is going to be at f of minus 1 divided by 3. That is because if you want to find the x coordinates of the turning point, you derivate the equation once and you equate it to 0, right? Because the gradient there is equal to 0. So if we substitute that, we're going to get minus and then minus 1 divided by 3 to the 3 plus minus 1 divided by 3 squared plus minus 1 divided by 3 plus 2. I'm getting 49 divided by 27, right? Which I'm just going to round off to 2 decimal places and write it as 1.81, right? Now let's substitute the other point, which is 1. So we're going to have minus and then multiply by 1 to the 3 plus 1 to the 2 plus 1 plus 2, right? And that should be equals to 3. Now let's move forward and do 8.2.2. So the coordinates, let's just conclude there before we move on. So the coordinates there will be minus 1 divided by 3 and 1.81, right? And then the other coordinate is 1 and 3. Those are the coordinates of the turning point of f. Let's do 8.2.2. 8.2.2 is saying that let's draw the graph of f. Indicate on your graph the coordinates of the turning points and the intercepts with the axis. So we already have the turning points, right? The turning points figured out. Now we just need the intercept with the axis, right? So let's find the y-intercept, right? The y-intercept should be easy to see that if we say f of 0, all the x's are going to fall apart and we're just going to have f of 0 being equals to 2, right? So we have figured out the y-intercept. Now let's look for the x-intercept, right? So we have minus x to the 3 plus x squared plus x plus 2 being equals to 0, right? So what's happening here? We're supposed to solve for x, right? If you use trial and error here, you will find out that the only value of x that is real that will satisfy this equation is when x is equals to 2, right? So this is the x-intercept, we have the y-intercept, and we have the turning points. Now we can sketch our function, right? So let me just put our axis there and see what we can do. So there go our axis. Let's put the turning points first, right? So the turning points, we have minus 1 divided by 3 and 1.81, right? So let's put 1 here, let's put 2 here, let's put 3 here. So 1.81 should be somewhere here.
So we have a point there. Now let's look at the other turning point, 1 and 3, right? 1 for the x value and 3 for the y value. So we have another turning point there. Now let's look at our intercepts. The y-intercept is here at 2, and the x-intercept is also at 2, right? So we have another point here. So when we sketch our cubic function, it's going to look something of this manner. So there goes our cubic function. It must go through 2, and then it must turn here, right, at 3, and then we go down to 2 for the x-intercept, and there we go, right? It doesn't look so great, but yeah, you can see what's happening here. Now let's do 8.3. So 8.3 is saying that points E and W are two variable points on f prime of x, right? This function that we have here drawn for us, right? That function there. And then they lie on the same horizontal line, right? So let's just, put a horizontal line there so that we can better conceptualize what's going on. So let's say we have some horizontal line there. Let me just use a ruler because I do have one. Why should I make everything look so messy? So there goes our horizontal line, right? It's not exactly there, right? It might be below the axis, it might be above. I'm just, putting a horizontal line for the sake of clarity. Now, the question goes on to say that H is a tangent to F at E. So let's say maybe our coordinate E is somewhere here, right? It's somewhere here. And then our coordinate W is somewhere here. Then if H is a tangent at E, then H should touch E there, and then yeah, it can look like that, right? And then G is a tangent at W, so it can look like that, right? Then these two lines must go up until they touch somewhere up there, right? And then the first question, 8.3.1, is saying that let's write down the value of A. Let's write down the value of A. And then the question has 1 mark. Now I want you to realize something here, right? If indeed these two tangents lie on E and W, and E and W lie on the same horizontal line, then this point here should be at the X of the turning point. So if we want to find the value of A, we're going to say A is equals to minus B divided by 2A, right? Back to the basics, the X coordinate of the turning point. So we're going to have minus, we have the equation of that graph there, right? We just determined it above. So here it is here. So B is 2 and A is minus 3. So here we're going to have 2 and then divided by 2 multiplied by minus 3. So that will be 2 divided by 6, which is equals to 1 divided by 3. So the value of A is 1 divided by 3. Now let's do 8.3.2. 8.3 is saying that determine the values of B for which A and G will no longer be tangents, right? The value of B for which H and G will no longer be tangents to F. Now let's go to a sketch so that I can show you something, right? So let me just erase these tangents here, right? Let me just erase those tangents. So we can have tangents that look like this, right? And we won't have any problem, right? And we can have tangents that look like this, that go very up. We still won't have any problem, right? Let's assume that they are touching here, right? We won't have any problem. We can even have the tangents touching here on the y value of the turning point. But then if the two lines start touching at a value that is less than the y value of the turning point, then those two lines will no longer be tangents because they're going through the graph. They're no longer just touching it once. For instance, let's say we have something like this, then obviously these two lines won't be tangents anymore because they're going through the graph, they're not touching it once, right? So if those two lines touch at some point that is less than the y value of the turning point, then those two lines can no longer be a tangent. So basically we're just calculating the y value of the turning point, right? And then say that when b is less than the y value of the TP, then those two lines are no longer tangents. So let's go ahead and calculate the y value of the turning point. We know fully well that the x value is 1 divided by 3, right? So now if we want to find the y value, we're gonna get y is equals to minus 3 multiplied by 1 divided by 3 squared plus 2x, right? What is x? 1 divided by 3 and then plus 1, right? Don't forget the equation of y. And that should be equals to 4 divided by 3. So the value of b shouldn't be less than 4 divided by 3. If it is less than 4 divided by 3, then issues arise. F of x is equals to x squared. Determine the minimum distance between the point 10 and 2 and a point on F. It will be a really painful exercise if we calculated the distance between every point on F and this point that we given, right? Instead, let's do it for the function as a whole instead of doing point by point, because we'll never really reach to the end, right? So if we do it for the function itself, we can say that the distance is equals to, we know fully well, y2 minus y1 squared plus x2 minus x1 squared. Distance formula, right? Grade 10, nothing complicated. So now our distance will be equals to, so we have y2. Now this is where it gets complicated, right? What is y2 and which one is y1? Obviously we have our point here that is given to us, right? It's easy to see that we can make this 10 be x1 and let the 2 be y1. And then for x2 and y2, we're going to use the function itself, because for every point on the function f of x, right, we're going to have some coordinate x and the corresponding y value x squared, right? That is what this function is essentially doing, right? So if we substitute that in our function, so let's let this be x2 and let this be y2. So if we substitute this in our function, we're gonna get x squared minus y1, which is 2, and then we square everything, plus x2. x2 is x, and then minus x1, which is 10, and then we square everything, right? If you've been watching my videos, you know fully well that I don't like square roots, fractions, and all that, right? So I'm just going to square both sides so that I don't have to deal with the square root. If I do that, I'm gonna get the distance squared being equals to x squared minus 2 squared plus x minus 10 squared, right? So now you can see that it's much easier to digest, right? But then the brilliant thing about distance is that if the distance from A to B is greater than the distance from C to D, right? Even if you compare the squared distances, the distance between C and D will still be greater. So instead of using the distance, we can just use distance squared because it makes our life more simple, right? So let's just go ahead and use distance squared because we're all agreeing that it makes our life simple. If I go ahead and simplify this, I'm going to get d squared is equals to x squared by x squared. That will be x to the power 4, right? And then minus 2 multiplied by x squared, that will be minus 2x squared. You multiply that by 2, you get minus 4x to the 2, and then minus 2 multiplied by minus 2 plus 4, then x by x, that will be x squared, and then minus 10 by x minus 10, multiply that by 2, you get minus 20x, and then 10 by 10, that's 100, right? So now we have d squared being equals to x to the 4, x to the 4, x to the 4, minus 3x squared, and then minus 20x plus 104. So now we have our equation for distance squared, right? But then we don't want just the equation for distance squared. We want the minimum distance between a point on the function and our point 10 and 2, right? So the way we are going to do this, if we derive distance squared and equate to 0, then that value of x that we're going to determine is going to be the value of x on the point that gives us the minimum distance. And then after that, we're going to calculate the minimum distance. So let me go ahead and derive this. So if I derive this, so I'm saying the derivative of distance squared will be equals to x to the 4. We just apply the power rule, so that will be 4x to the 3 and then minus 6x minus 20. We're equating it to 0, right? We want the point that will give us the minimum distance. So now all we have to do is to solve this equation here, and we have the value of x of that point, and with the value of x of that point we can substitute it in our distance formula and consequently find the minimum distance between the point and a point on F, right? So when we solve something like this, we always going to have a bracket here that says x plus some number k, right, multiplied by a quadratic function being equals to 0, right? So the way you solve this, you start with this bracket here, right? You use trial and error and try a few values until you get 0, right? After you solve this bracket here, it becomes easy to find this other bracket. So let's go ahead and try a few values and see which value that when we substitute in this equation we're gonna get 0, right? Because if we substitute that value and we get 0, then we know that that value is a factor of this equation. So I'm gonna try 0, 1, 2 and minus 1 and minus 2, right? So let me try 0. So if I try 0 there, let me just substitute in real quick. If I try 0, I'm getting minus 20 if I try 0, right? Obviously, let me try 1 and see what I get. If I substitute 1 in that equation, I get minus 22. Let me try minus 1. If I try minus 1, I get minus 18. That's not what we want. Let me try minus 2. If I try minus 2, I'm getting minus 40. So let me just try 2. And then when I try 2, I get 0, right? So I know that when x is equals to true, this equation here, it holds, right? 4x to the 3 minus 6x minus 20 will be equals to 0 when x is equals to 2, right? So when x is equals to 2, that's exactly where we have our minimum, right? But the good part about all of this is that we can actually verify and see if we get our minimum when x is equals to 2, right? We can substitute x is equals to 2 on this distance formula here that we started with, right? And then we can substitute 2.1 and substitute 1.9, right? Because if we substitute a value that is slightly above 2 and a value that is slightly below 2, and all those two values give us a bigger distance than when we substitute 2, then 2 is the value we're looking for. So let's go ahead and substitute 2. So if we substitute 2 on the distance formula, we're gonna get d when we substitute 2, right? When x is equals to 2. When you substitute 2, we're gonna get d is equals to the square root of what? The square root of x squared minus 2 squared plus x minus 10 squared, right? So let me substitute 2 and see what I get. When I substitute 2, I'm getting a distance of 8.24 units, right? Now let me substitute 2.1. When I substitute 2.1, I'm getting 8.26 units, right? So you can see that when x is equals to 2.1, we're getting a higher value. And when I substitute x is equals to 1.9, I get a distance of 8.26 again. Now we can see that when x is equals to 2, our distance is 8.24 units, and that's the minimum distance between the point and the function. So what you can do if you want to verify this, you can take any other value of x, right, and then you substitute it in the equation for the distance and see if you get any number that is less than 8.25. We have events A, B, and C, and then we're given the probabilities and the combinations as a Venn diagram. And the first question, 10.1.1a, says that let's find y, the probability that none of the events will occur. The probability that none of the events will occur. So the probability that none of the events will occur is always equals to 1 minus the probability that at least one of the events occur. And then that is given to us on the question statement. It is said that the probability that at least one of the events will occur is 0.893. So the probability of y is just 1 minus 0.893, and that is 0.107. Now we can do B. B is saying that let's calculate the value of x, the probability that all the three events will occur. The probability that all the three events will occur. X is here. This is what we're looking for, the probability that all events will occur. We already know that the probability of at least one event occurring is 0.893. The probability that at least one event occurs is 0.893. So all these probabilities that we see here should be equals to 0.893, right? So if we do that, we're going to get 0.893 being equals to 0.05 plus 0.15 plus 0.05 plus again 0.1, 0.2, and 0.183 plus x, right? So now we're just solving for x, the probability that all three events occur. So 0.893 will be equals to, let me just add all these probabilities. I'm getting 0.733 plus x. So consequently, x should be equals to, so we're just saying 0.893 minus 0.733, which should be equals to 0.16. So now here at x, we know that we have 0.16, right? We have 0.16 at x. And then let's do 10.2. 10.1.2, I meant 10.1.2 is saying that let's determine the probability that at least two of the events will take place. The probability that at least two of the events will take place. So we need a formula for that. The probability that at least two events of A, B, and C occur. This will always be equals to the probability of A and B plus the probability of B and C plus the probability of C and A, right? Minus 2 the probability of A, B, C. Right, so we're gonna have the probability of A and B, so that will be 0.1 plus 0.16, right? So we have 0.1 plus 0.16 plus the probability of B and C. The probability of B and C will be 0.2 plus 0.16. So we have 0.2 plus 0.16 plus the probability of C and A, so that's 0.15 and 0.16, right? So we have 0.15 plus 0.16 and then minus 2 the probability of ABC, so that is minus 2 and then 0.16. You can see here that we counted 0.16 3 times and we're subtracting 0.1 twice, so that we end up counting it only once, right? So let me just put that in the calculator. and I'm getting 0.61. So the probability that at least 2 of these events will take place is 0.61. Let's do 10.1.3. So 10.1.3 is saying that are events B and C independent? Justify your answer. We have solved a very similar problem in the past, right? So what we have to do now, we have to stick to the definition. What does it mean when 2 events B and C are independent, right? By definition, 2 events B and C are independent if the probability of B and C is equals to the probability of B multiplied by the probability of C, right? So let's go ahead and look for the probability of B and C. So here on our Venn diagram, the probability of B and C is this 0.2 and X, which we know fully well that X is 0.16, right? So we have 0.16 plus 0.2. Being equals to, right? So we check in to see if they're equals to each other. So what is the probability of B? The probability of B is everything in the circle of B, right? Everything in here in the circle of B is the probability of B. So that will be 0.183 plus 0.1 plus 0.2 plus 0.16 multiplied by the probability of C. The probability of C will be 0.05. Everything in this circle here for C, right? Everything in this circle. 0.05 plus 0.15 plus 0.16 plus 0.2, right? So 0.16 plus 0.2, that will be 0.36, and it will be equals to that is 0.36008, and we can see that 0.36 is approximately 0.36008, right? So we can conclude and say that events B and C are independent of each other because they satisfy this definition here.
A 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 or 1. Digits may not be repeated. And then the first question, how many possible 4-digit combinations are there to open the lock? How many possible 4-digit combinations are there to open the lock? So let's look at the restrictions we have. We have digits from 2 to 9 because 0 and 1 cannot be used. So we have 2, 3, 4, 5, 6, 7, 8, 9. How many digits? This is 1, 2, 3, 4, 5, 6, 7, 8. The other condition that we have is that the code must be even numbered. What does that imply? If the last digit on the code is even, then the code itself is even numbered. So we need an even number to occupy the last spot. How many even numbers do we have? Well, 2 is even, 4 is even, 6 is even, and 8 is even. So we have 4 possible digits that can occupy the last spot. So we are choosing from 4. So out of the 8 digits that we have used 1 on the last spot. Now we are left with 7 and no further conditions. So we have 7 possible digits that can occupy the first spot. 6, 5. We have 840 possible 4-digit combinations. Let's look at 10.2.82. Calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is true. The code is greater than 5,000 and the third digit is true. Let's make sense of that. If the code is greater than 5,000, then on the first position, we need 5, 6, 7, 8, or 9. We need 1 between those 5 numbers. We say in only 5, 6, 7, 8, and 9 should occupy that first spot. Now let's look at the other condition that we have. We must have 2 on the third spot. So here we have only 1 digit that can occupy that spot. We have 2 there. And then on the last spot, for our combination to be even numbered, the last spot must be occupied by an even digit. We need 2 to be on the third spot, so we cannot include it anymore. So we are only left with 4, 6, 8. If you saw the last video I did on probability, you will realize that we have a conflict of interest now. 6 and 8 can occupy both the first and the last spot. So we need to make calculations for when 5, 7, and 9 occupies the first spot and when 6 and 8 occupy the first spot. So let's go ahead and do that. We only do that when we have a conflict of interest like we do right now. So let's have 1, 2, 3, 4. If 5, 7, and 9 occupy the first spot, then we are choosing one of the 3. And then on the last spot, we are still going to have 3 digits. On the third spot, we have 1 digit that can occupy there, which is 2. And then on the second spot, of the 8 digits, we have used 1, 2, 3. So we are left with 5. This is when 5, 7, and 9 can possibly occupy the first spot. Let's look at the case when 6 and 8 occupy the first spot. When 6 and 8 occupy the first spot, we have 2 possible digits that can occupy the first spot. On the second spot, we're going to have 5 digits after we have satisfied everything else. On the third spot, we need 2, so that is 1 digit. If 6 or 8 occupies the first spot, then on the last spot, we are only going to be left with 2 even digits. Let's say 6 occupied the first spot, then we are left with 4 and 8. If 8 occupies the first spot, we are left with 4 and 6. So we have 2 possible digits that can occupy that last spot. Now it is just a matter of putting that in your calculator and you should get 65. So the probability will be equals to 65 divided by the sample space, our total possible combinations, which is 840, which will give you 0.08. Let's take a look at 1.1.1. We have x multiplied by x minus 3 being equals to 0. We're solving for x. It's either x is equals to 0 or x minus 3 is equals to 0. One between the two, right? So x equals to 0 or x is equals to 3. That is the answer to 1.1.1. We are sticking to the basics, really. Nothing complicated. Right, let's take a look at 1.1.2. We have 2x squared plus 1 being equals to 4x, and we're supposed to solve for x correct to 2 decimal places. As soon as the question says correct to 2 decimal places, we are thinking that we might have to use the quadratic formula, the quadratic equation. So to write this in the standard format, we would have 2x squared minus 4x plus 1 being equals to 0. So this is A, this is B, and this is C. Right. So now we're going to say that x is equals to minus B. So minus B in this case is, well, 4. It's minus 4 is B in this case. And then plus or minus the square root of B squared. Right. So minus 4 squared minus 4AC. A is 2, C is 1. And then we divide everything by 2A, of which A is 2, right? So we have x being equals to. So without wasting time, let me just go ahead and substitute this in my calculator. So we're going to have plus 4 plus the square root of minus 4 squared minus 4AC. A is 2, C is 1, divided by 2A. Well, A is 2. So I'm getting x is equals to 1.71 or x is equals to, so let me change the positive to a minus. We have 0.29. 0.29. These are our two answers, 1.71 and 0.29. There's no other answer except from this. 1.70 something is wrong. 0.293, 0.2928. It is Completely wrong. The question says correct to 2 decimal places. There's no ambiguity when it comes to rounding off. So these are the only 2 possible options. Right, 1.1.2. Let's take a look at 1.1.3. So 1.1.3, x squared minus 2x minus 3 is greater than 0. So here we are solving for x. I'll go ahead and find my critical values, right? In saying that CV, right, I can then equate these to 0 and find those critical values of x and then worry about the answer after. So x squared minus 2x minus 3, we can easily factorize this, right? 2 factors of minus 3, when we add, we get minus 2, and when we multiply, we get minus 3. That is minus 3 and plus 1. This is equals to 0. Well, we can test this out. This is going to give us x squared minus 3x and then plus 2x minus 3. So x squared, actually, let me do that again. I know that this is how it looks like when it's factorized. So x and x will give us x squared, and then we have plus x, and then we have minus 3x, and then we have minus 3. So this is going to be x squared minus 2x minus 3. Okay, so I've done that in the correct way. So these are the critical values. X is equals to 3 or x is equals to minus 1. Like I've said on countless videos, there's 2 possible solutions when we get to this point. It's either x lies between the 2 critical values or it lies outside. Let me show you what I mean when I say that. If it lies between the 2 critical values, I'm saying that x is between minus 1 and 3. And when I say it lies outside, I'm saying that x is less than minus 1 or x is greater than 3. These are the possible solutions, A and B. These are our possible solutions. There's no other solution apart from these 2. So how do we therefore test which solution is correct? I'm glad you asked. Take a look at this. So we can substitute a number that exists in this solution, right? A number between minus 1 and 3 is 0. If we substitute that number in our equation and our condition, well, our inequality is satisfied, then A is our solution. But if that is not the case, then B becomes our solution automatically. So let me substitute 0. 0 squared minus 2 multiplied by 0 minus 3. So when you substitute 0, we get minus 3 is greater than 0. Is this true? We know it is not. So it means that this is not the solution. This is not the solution. We can get rid of this. This is not the solution. So the solution, x greater than 3 or x less than minus 1. This is the actual solution. We can obviously test that out. We can substitute 4, for instance. When you substitute 4, we get 4 squared and minus 2 multiplied by 4 minus 3. That is 5, and 5 is clearly greater than 0. So that is the solution, 1.1.3. 1.1.4, we have 2 to the power 2x minus 2 to the power x plus 2 minus 32 is equals to 0. So as soon as I see equations like this, I know that I'm going to let something be equals to k, right? I'm going to let something be equals to k. So let me show you how this plays out. So 2 to the power 2x, we can write it as, well, 2 to the power x, everything to the power 2, right? 2 just multiplies 2, just multiplies x, and we end up with 2 to the power 2x. And then here we can write minus 2 to the power x multiplied by 2 to the power 2, because when we multiply numbers with the same base, we add the exponents. So that is totally fine. And this we can leave as minus 32, and this is equals to 0. So we can let 2x be equals to k, right? In doing that, we will therefore have k squared minus 2 squared is 4, right? So we have minus 4k minus 32 being equals to 0. And then we can just go ahead and factorize this. So let me give that a try. We have k, and then 2 factors of minus 32, of which when we add, we get minus 4. I think minus 8, let's say minus 8 and plus 4 would work. Let's just give this a try and see. So this would give us k squared plus 4k minus 8k, 8, 16, 32, minus 32. So k squared minus 4k minus 32. So I'm quite convinced that what I've done is correct, right? That is how you can always check. You can just multiply out and see if you go back to the same thing. So k is equals to 8, or k is equals to minus 4. But we know that k is 2 to the power x. So 2 to the power x is equals to 8, or 2 to the power x is equals to minus 4. Obviously, we know that this is impossible. So we cross it out and we forget about it. Now let's focus on 2 to the power x being equals to 8, right? So 2 to the power x, we write 8 with a base of 2. So that is 2 to the power 2 is 4, so 3 is 8. So x is equals to 3. That is 1.1.4. Quite simple. It's not too bad. It's not too bad. This is easy, right? 5 easy marks. Right. And then 1.1.5, we have the square root of minus 2x plus 4 minus x being equals to 2. This is another basic one, right? We know exactly what we're going to do. We're going to isolate the square root here. We're going to be left with minus 2x plus 4 being equals to, well, let's just say x plus 2, because x is going to be positive when it goes to that side. And then we square both sides. Right? Sticking to the basics. When we do that, we get, let's say, minus 2x plus 4. I wanted to say 4 minus 2x, but it's fine. We can just leave it like that. And then x plus 2 squared, that is x squared plus 4x plus 4, right? Yes. Okay. I'm happy with that. So we're going to have x squared plus 4x plus 2x when we take it to the other side, right? So we get x squared plus 6x plus 6x, and then 4 minus 4, that gives us 0. So we have x squared plus 6x being equals to 0. So take x as a common factor, we get x plus 6. This is equals to 0. So x is equals to 0, or x is equals to minus 6. Right, most of the time when we square, we introduce solutions that are not necessarily true for the equation when it is not squared. Let me demonstrate what I'm talking about. So x is equals to 2. Well, what is x? X is 2. It's easy to see. We're saying that x is equals to 2. But take a look at this. If we square both sides, which is mathematically correct, we get x squared is equals to 4. But what are the solutions of x squared is equals to 4? X is equals to 2, or x is equals to minus 2. So when you square, you introduce things that might not be necessarily true for the original equation. So we need to test and see which one between these two it is not necessarily true. It is possible sometimes that they are both correct. Sometimes you can find a case like that, but let's test it out. Okay, so when I substitute 0, right, I'm substituting here, and after I substituted here, well, it's supposed to give me 2. So minus 2 multiplied by 0 plus 4 minus 0. This gives me 2. So x is equals to 0. It is working, right? Now let me substitute minus 6. So the square root of minus 2 multiplied by minus 6 plus 4 minus 6, right? Because that 6 is negative. And then here I get 10. 10 is equals to 2. Obviously 10 is not equals to 2. So x is equals to minus 6 is not necessarily true for the equation that we started with. That is 1.1.5. Let's take a look at 1.2. So here we have 2x plus y being equals to 3. Well, it's easy to see that our life will be easy if we make y the subject of the formula. If we do that, y is equals to 3 minus 2x. You can call this equation 1. You don't really have to do that, but yeah, you can do that. And then now we have x squared plus xy being equals to 2. This is our second equation. And then in place of y, we substitute 3 minus 2x. We square that. Plus x 3 minus 2x is equals to 2. So let's solve 3 minus 2x squared. So this will give us, 4x squared minus 2x multiplied by 3, that is minus 6x. We multiply that by 2, minus 12x plus 9 plus 3x minus 2x squared. And this is all equals to 2. So 4x squared minus 2x squared, that is 2x squared, minus 12x plus 3x, that is minus 9x. And then 9 minus 2, right? That is plus 7. So if you forget these two here and you equate to 0, then yeah, it's not going to work out. And then this is equals to 0. Obviously, it is very difficult to factorize when we have a coefficient of 2, when the coefficient of x squared is 2. But if you find your way and you factorize, you will get 2x minus 7. And then here you have x minus 1. But it's always safe to use the quadratic formula. And then x is equals to 7 over 2, or x is equals to 1. Right. So now we need to find the corresponding values of y. So when x is 7 over 2, what is the value of y? So 3 minus 2 multiplied by 7 over 2. I'm getting minus 4. So one possible value of y is minus 4. What about the case where x is equals to 1? So 3 minus 2 multiplied by 1, I think that just gives us 1. 3 minus 2 multiplied by 1, that gives us 1. So y is equals to 1. Okay, and then let's take a look at 1.3. I did post a video on a question like this not too long ago. So let's take a look. Determine all the values of n for which the product will be an integer value. Let's do that on a separate video. Here we go. So let me know in the comments which video you want me to do next. Right now I'm doing 1.3 and I'm going to upload it right now. But tell me, after 1.3, which question should we do next? 1.3 is a thing of beauty, and let me show you why that is the case. So consider the product 1 plus 1 over 2 multiplied by 1 plus 1 over 3, and lastly multiplied by 1 plus 1 over 4, so on and so on. Each factor in the product is of the form 1 plus 1 over n, for which n is greater or equals to 2, as we can clearly see from the first term that is the case. And then the question is saying, determine all the values of n for which the product will be an integer value. Determine all the values of n for which the product will be an integer value. So this product as it is very hard to digest, but we can change it a bit. Let me show you in what way we can change it. So let me just drag these down and show you a couple of things. I want to drag these down. There we go. So instead of having 1 plus 1 over 2, let's just put that in our calculator. I get 3 over 2. So here the first term that I have is 3 over 2, right? And then let's move to the second term. 1 plus 1 over 3, that is 4 over 3. And then the third term, 1 plus 1 over 4, that is 5 over 4, right? 5 over 4. Let me rewrite that. So these are the terms of the product, not the terms of the sequence. Let me put it here so that I can show you something. And then this pattern goes up until 1 plus 1 over n, right? Of which we do not know. So the last term here that we have is 1 plus 1 over n. But we can do the same thing for that term. Well, not the same thing, but we can also rewrite that term. Let me show you how. 1 plus 1 over n. 1 plus 1 over n is the same as n plus 1 over n. Because if we give both those two terms on the numerator, a denominator of n would end up with 1 plus 1 over n. So instead of writing 1 plus 1 over n, we can write n plus 1 everything over n. But it does not end there. It does not end there. There's another layer of complexity that I want to introduce here. So that is the last term, right, for some n terms, right? That is the last term. So that is the last term. But I want us to think about the term that comes before this one. I want us to think about the term that comes before that one. So the term that comes before this one is supposed to be, so this is the last term. So I want us to concentrate on the term that comes before that one. The term that comes before that one, it should have a numerator of n minus 1, right? Plus 1, because it is the term that comes before n. So it must be n minus 1. So on the denominator also, we are supposed to have n minus 1. We are replacing n with n minus 1. So let's put that term together with the other terms. So we are saying that the first term is 3 over 2. 3 over 2. It is followed by 4 over 3. And then after that we have 5 over 4. And then we have some terms. Before the last term, n minus 1 plus 1 is just n, right? So we have n divided by n minus 1. And then after n divided by n minus 1, we have n plus 1 divided by n. That's what we have. So let me erase this and show you what happens here. You can see for the first 3 terms that 3 and 3 will cancel out, right? After that, 4 and 4 cancels out. 4 and 4 cancels out. If you were to add the 4th term there, you would see that 5 and 5 would cancel out. So ultimately, we are left with 1 over 2, right? After 3 and 3 cancels out, we are left with 1 over 2 up until these last 2 terms. But with the last 2 terms, n and n cancels out. That's easy to see that n and n cancels out. So we have some 1 over n minus 1, and lastly, the last term that we have is n plus 1, right? So that's what we're going to have. So let's see how these 2 terms behave. 1 over 2 and n plus 1. Let's see how they behave. We want the product to be an integer, right? An integer is a number that is not a fraction. It's a whole number, right? So when can these be whole? When can we multiply these 2 things and have a whole number? It's when n plus 1 is even. Because take a look at this. If n plus 1 is odd, we're going to have 3 over 2. And that is not whole, right? If n is odd, we're going to have 5 over 2. And that is not whole. But if n plus 1 is actually even, then we can have 4 over 2, which is 2, right? We can have 6 over 2, which is 2. So how can we achieve that? If n is equals to 3, our condition is satisfied, right? Because we're going to have 4 divided by 2. If n is equals to 5, we're going to have 6 divided by 2. If n is equals to 7, we're going to have 8 divided by 2. So on and so on. So n can be 3, 5, 7, 9, up until infinity, right? Some infinity odd number so that our product can be an integer. So there we go. Okay, let's take a look at 2.1.1. Calculate the sum of the series. So what information do we have? The first term of an arithmetic series is 7. So we are given that a is equals to 7. The common difference of this series is 5. So the common difference is equals to 5. And the series contains 20 terms. So we know that n is equals to 20. What are we looking for? We are looking for the sum. So we know fully well that the sum of some n terms is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by the difference, right? So we're looking for the sum of the 20 terms. So S20 is equals to 20 over 2 multiplied by 2a. We know fully well that a is equals to 7 plus n minus 1. So 20 minus 1. The common difference is 5. So let me go ahead and put that in my calculator. So when I have 10 multiplied by 14 plus 19 multiplied by 5, this is equals to 1090. So the sum of the 20 terms is 1090. So this is 2.1.1. Let's take a look at 2.1.2. So 2.1.2, the original arithmetic series is extended to 75 terms. We now have 75 terms. Using sigma notation, write down an equation for the sum of the terms added to the original series. We need to be very perspicacious here. In 2.1.1, we determined that the sum of the first 20 terms is 1090, and then the sum of the 75 terms is 14,400. Let's pay attention to what we're looking for here so that we can make sure we don't miss anything. So listen to this. Use sigma notation and write down an equation for the sum of the terms added to the original series. The sum of the terms added to the original. So the sum added, we can find that by saying S75 minus S20, right? So 14,400, because you're looking for the sum of the terms that are added. Initially, we had 1090 as our sum, and after we add some terms, we have 14,400. So 14,400 minus 1090. This is equals to 13,310. This is the sum of the terms added, right? But we're not just looking for the sum of the terms added. We have to represent it using sigma notation. So from S20 to S75, we start with n being equals to 21, right? Up until n is equals to 75. So we know what number to start with at the bottom of our sigma and what number to put up there. And we actually know the sum, right? We know the sum of those terms that are added. Let's just call it SK. We know fully well that the sum is 13,310. So we have the number at the bottom, we have the number at the top, we have the sum itself, right? And then the equation Tn is equals to. So if we use the Tn for the original arithmetic sequence, A, we know fully well it is 7, right? And then plus, well, depending on what we're going to use, let's say K plus n minus 1. So let's say K minus 1 multiplied by the common difference, which is 5. So when we represent it, when we represent these as a sigma notation, we're going to have K is equals to 21, because that's where we're starting, right? And then we end up when K is equals to 75. And the formula that we have, let me use a bra there and not a cat. It's 7 plus K minus 1, everything multiplied by 5. And we know that this sum should be 13,310. There we go. That is only 2.1.2. Let's take a look at 2.2 and 2.2.1. The sequence of the first differences of a quadratic pattern is 1, 3, 5. That is the sequence of the first differences of a quadratic. So that is arithmetic, right? And then 2.1.1, if T99 of this quadratic pattern is, so we have T99. It's 9,632. This is T99, right? The question says calculate the value of T98. So we're looking for T98. So let me put it here and say that we are looking for the value here, of which it is T98. We are looking for T98. Okay, so the difference between T99 and T88, we should be able to find it using this arithmetic, right? Because we know that this arithmetic, we find it from finding the differences of the quadratic. So we can use that arithmetic to find the number which we need to subtract here in order to find T98. Because from T98 to T99, we add a number there from a number here, right? From the quadratic, from the arithmetic, so that we can get the following term of the quadratic. So we just need to identify that number. But how do we identify that number? Let me show you something. So we have something like this. So T1 of the arithmetic is between T1 and T2 of the quadratic, and the T3 is between and the T2 is between T3 and T2, and the T3 is between T4 and T3. So we are looking for T98. So T98 should be the 98th, the difference between T98 and T99 of the quadratic should be T98 of the arithmetic. It should be T98 of the arithmetic, right? So we need to find T98 of the arithmetic and subtract it from T99 in order for us to find T98 of the quadratic. So T1 is 3, so A is equals to 1. The difference 3 minus 1, it's easy to see that it is 2. So we have, well, T98 rather being equals to A1 plus n minus 1. So we're looking for the 98th term. So we have 98 minus 1 multiplied by the difference, which is 2. Okay, so let me just put that in my calculator. So 1 plus 98 minus 1, everything multiplied by 2. So this is 195. So the term here that we have is 195. This is 195. So T98 is going to be 9632 minus 195 minus 195. This is 9 minus 195. This is equals to 9437. So there we go. This is T98. This is T98. Okay, there's another way to find T98, right? But another way that you can use to find T98, it involves finding Tn, which is what we are supposed to do in the last question 2.2.2. So I don't know what is going to actually happen with that case, because in order for you to find T98, you can do that, but in doing that you can find Tn first. But 2.2.2 says find Tn. So what do you do in that case, because you've already found Tn in the question that came before? But anyway, stories, right? Let's do 2.2.2. We're supposed to find a Tn of the quadratic. We know fully well that Tn of the quadratic is an squared plus bn plus c. We need a, we need b, and we need c. How can we do that? So let's go back to our pattern, right, of the quadratic. We have T1, T2, T3, and T4. The difference between T2 and T1 is 1. The difference between T3 and T2 is 3. The difference between T4 and T3 is 5. We are getting that because we are given that quadratic, or that arithmetic pattern, right? And then the difference between 3 and 1 is 2. Obviously, the difference between 5 and 3 is 2. So already we can see that 2a is equal to the second common difference all the time, which is 2. So a is equal to 1 in this case. And then 3a plus b is equals to 1, right? So we have a, and then 3a plus b, so we have 3 plus b being equals to 1. So b is equals to minus 2. So we have b. So now we need to find c, right? We can say a plus b plus c is equals to T1. But the problem is that we don't have T1. But we have T99 because it is given to us. So we can say that T99 is equals to a is 1. And then n is 99. So 99 squared minus 2 because b is minus 2. And then n is 99, and then plus c. But we do have T99. T99 is 9,632. So let's replace that with 9,632. So c is equals to 9,300 or 9,600. 9,632 minus 99 squared plus 2 multiplied by 99. Okay, so let me put that in my calculator and find c. So 9632 minus 99 squared plus 2 multiplied by 99. This is 29. So c is equals to 29. So we have Tn being equals to n squared minus 2n plus 29. So this is Tn. Obviously, we can test and see if this is correct, right? We can substitute 98 and substitute 99 and see if we're gonna find. When we substitute 99, we shall find this term, and then when we substitute 98, we shall find the term that we found as an answer to the previous question. So let's substitute 99. So 99 squared minus 2 multiplied by 99 plus 27 gives us 9,630. Yeah, that is because I said 27 instead of 29. Yeah, so let me put 29 in my calculator. 9,632. So T9 is correct. I'm quite confident that Tn as a whole is also correct. There we go. Okay, we've done question 1, we've done question 2. Now I'm doing question 3. Tell me which question you want to see next. Do we just go to 4, 5, 6 up until 12, or shall we jump to one specific question that you had problems when you were doing today in the exam? Let me know in the comments. But nevertheless, let's take a look at 3.1. Write down the radius of the third circle. Let's take a look at the information that we have. A circle with radius 6 centimeter is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally as shown in the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Okay, so that is what we have. They form a geometric pattern. Back to our equation. What does it say? Write down the radius of the third circle, and that is for 2 marks. Okay, we can do it the easy way, conceptualizing. Let's go ahead and take a look at that. So we know fully well that the radius of the biggest circle is 6, right? So we have 6 there, and we have 6 right there. So that is also 6, okay? And then let's take a look at the second smaller circle. The second smaller circle should therefore have a radius of 3, right? We're going to have 3 here, and then we're going to have 3 there. And then now let's come to the smaller circle. So the smaller circle, it has a diameter of 3. So the radius, let me just put a dot here. Oh, that is too big. So maybe this is going to work. No, also too big. So the radius of the smallest circle, that is the center, right, should be 3 over 2. That side, right? At this side, we also have 3 over 2. So that is the radius of the smallest circle is 3 over 2. So the answer to 3.1, 3 over 2. This is the answer to 3.1. How are we getting to 3 over 2? The radius of the biggest circle is 6. The radius of the circle that follows is 3. And the radius of the third circle is 3 over 2. Right, we can clearly see that we have 6. And then here we're going to have 6 as the diameter and 3 as the radius. Here we're going to have 3 as the diameter and 3 over 2 as the radius. So there we go. And then 3.2, calculate the sum of the areas of the first 10 circles. And that is for 4 marks. Calculate the sum of the areas of the first 10 circles. Well, honestly speaking, I don't think this question should be for 4 marks, right? Because I think there's a lot of dots that we need to connect in order to answer this question. So calculate the sum of the areas of the first 10 circles. So let's think about this. The sum, let's say sum of A, right? The sum of the areas is going to be pi r squared, right, for the first circle, plus pi r squared for the second circle, plus pi r squared up until some last pi r squared, okay? Because we're looking for the sum of the areas of the first 10 circles. Okay, right. So this is what we have. Obviously, the radius, the first radius is going to be of the first circle, and then the second circle, and then the third circle. So how are we going to be able to do this? You calculate the areas of one circle at a time up until 10. That doesn't seem very efficient, right? Take a look at this. We can say that the sum of the areas of these circles is equals to, let's take pi as a common factor. Let's take pi as a common factor. So we're going to have r1 squared plus r2 squared up until the 10th circle. So we're going to have r10 squared. So what can we do? We can use a bit of math to find the sum here. We can use a bit of math to find the sum right there. But then you need to realize something, that r squared is not r, right? So we need to take this pattern that we are seeing from the radius of the circles and form r squared as a pattern. Okay, so when we looking at the sequence that is made up of the radius squared of the circles, the first radius should be 6 squared, right? And then the second radius should be 3 squared, and then the third therefore should be 3 over 2 squared, so on and so on, up until the last circle, R10. Okay, so this is the sequence, so to say, that is formed by the radiuses of these circles, right? The radiuses squared, because that's what we are now interested in as we attempt to find the areas of these circles. Okay, so 6 squared, obviously, that is 36, and then 3 squared, that is 9, but no need to worry about that. We just need to realize that A, the first radius, is 6 squared, right? The first radius squared. And then R, we need to distinguish this R. This R is not the radius, but rather the ratio, right? Because we know that we have Tn is equals to AR to the power n minus 1. This R is not the radius, it's the ratio. So don't confuse it with the two, with the radius. This is actually the ratio. So the ratio is equals to T2 divided by T1. So we're going to have 3 to the power 2, 6 over 2. So this is 9 over 36. So this is A, this is the radius, and then let's find the sum, right, of the first 10 terms of this sequence, of this series, because we are talking about the sum. So to find the sum, we have Sn being equals to, well, let me take my question paper and look at the formula, right? Don't want to make any mistakes here. So the sum of some n terms in our formula sheet is given as a r to the n minus 1, everything divided by r minus 1. That's what we're given. So the sum of the first 10 terms, we're going to have a being equals to 6 to the power 2. So we have 6 to the power 2. And then we have r being 9 over 36. And then this is to the power 10. We subtract 1 and we divide everything by r minus 1. So that is 10 minus 1. So I just need to put that in my calculator. So 6 squared multiplied by, well, 6 squared, that's 36, multiplied by 9 over 36, everything to the power 10, minus 1 divided by 10 minus 1. I'm getting, let me just verify that I'm doing the right thing. So the first term is 36, okay, and then that is followed by, okay, yeah, I have r minus 1. I substituted 10 there, which is wrong, right? It's not n minus 1, but r minus 1. I was getting a negative number, so I was getting surprised. So r is 9 over 36, and then we subtract 1, okay, and then the answer is 47. So S10 is 47.99995. Okay, and then let me open the instructions on the question paper and see if I can round off to 2 decimal places. Answer all the questions, number the questions correctly. If necessary, round off to 2 decimal places unless stated otherwise. Okay, so I can round off to 2 decimal places, right? So that is S10. That is this entire thing. That is this entire thing. So the sum of the areas is going to be equals to pi multiplied by 47.99995. So this is just 47.99995 pi, of which when you round off to 2 decimal places like we can, we get 48 pi. So the sum of the areas, some units squared. Yeah, are we given the units? No. Oh yes, we're given centimeters actually. So centimeter squared. So there we go. That is the sum of the areas. I know there's somebody who got 48 but forgot to include centimeter squared. Yeah, there has to be somebody who made that mistake. But anyway, sorry, that is 3.2. Let's take a look at 3.3. So 3.3, which circle has a diameter of 3 over 128? So this is the diameter, right? diameter is equals to 2r. We're interested in r. We've been talking about r here throughout. So let's go ahead and find r. So r is going to be 3 divided by 128, everything divided by 2. So 3 divided by 128, everything divided by 2. I'm getting 3 divided by 256. So which cycle has a radius of 3 divided by 256? We have to go back to this sequence that is made up of the radiuses, right? Because the first radius is 6 followed by 3 followed by 3 over 2, right? And we know fully well that Tn is equals to ARn minus 1. So Tn, we're looking for a radius which is 3 over 256. A is the first term, 6. R is 3 over 6, which is 1 over 2, right? Yeah. So we have 1 over 2 to the power n minus 1. So we're looking for minus 1 here. So from the get-go, we can just divide both sides by 6. So I'm getting 1 over 2 n minus 1 being equals to 1 over 512. Okay, so I can just introduce log on both sides here. I get n minus 1 log of a half being equals to log of 1 over 512. So obviously I'm gonna get n being equals to log of 512 with a base of a half when I divide by log on both sides, and plus 1 when I take 1 to the other side. So let me just substitute that in my calculator. Where is log here where I can write a base? It's running away from me, so let me just use log as it is. So I have a log of 1 divided by 512 divided by log of 1 over 2 plus 1, yes, and then I'm getting 10, n is equals to 10. So which cycle has a diameter of 3 over 128 centimeters? The 10th cycle, the 10th, yeah, something like that, but n is equals to 10. There we go. Question 3. Which question should I do next? Let me know in the comments. Calculate the value of a. It will not be paper 1 if there is no such equation. Calculating the value of a when we are given a function. So let's go ahead and take a look. F of x is equals to a to the power x minus 1. And we are given a point b which lies on the function f of x. We have 2 for the x value and minus 5 over 9 for the y. It's quite easy to see what we need to do. In place of x, we sub 2. In place of y, minus 5 over 9. So we're going to have minus 5 over 9 being equals to a to the power 2 minus 1. So a to the power 2 is equals to minus 5 over 9 plus 1, which is equals to 4 over 9. So should be easy to see here that a to the power, well, let's just say a to the power 2, everything to the power a half, and then 4 to the power 4 divided by 9, everything to the power a half. 2 and 2 cancels out. We have a being equals to 2 over 3, right? Because 4 to the power a half is 2, 9 to the power a half is 3. So a is equals to 2 over 3. So at this point, we know that f of x is equals to 2 over 3 to the power x minus 1. That is 4.1. Let's take a look at 4.2. So 4.2, we're supposed to write down the range of f. Well, f of x, again, it is equals to 2 over 3 to the power x minus 1. So let's talk about this. Let's talk about this right here. So the first thing that we need to realize is that this part can never be equals to 0. That part can never be equals to 0. if it cannot be equals to 0 and it cannot be negative also, it means that y will always be greater than minus 1. Because for y to be equals to minus 1, we need this part to be equals to 0. And we know that that cannot happen. And that part can also not be negative. So we know that we cannot have a value of y which is less than minus 1. So all values of y, we have y being greater than minus 1. So that is the range, right? And then 4.3, right, well, not right, but sketch the graph of f. Clearly show the intercepts with the axis and asymptotes, if any. So our first asymptote, y is equals to minus 1. We are not supposed to touch this line, because in order for us to touch that line, we would need 2 over 3 to the power x to be equals to 0. And we know that that cannot happen. So that is one asymptote. And then values of x, do you have a, because this is the horizontal asymptote, do we have a vertical asymptote? No, I don't think we have a vertical asymptote. It seems like f of x is defined for all values of x. And then the intercepts, well, let's let x be equals to 0 and see what the value of y is. So a to the power 0, well, we have the value of a, but it doesn't really matter. A to the power 0 minus 1, so we have 1 minus 1, which is 0, because any number to the power 0 is 1, except for 0, right? And we know that a is not 0, it's 2 over 3. So this is the intercept. We have 0 and 0. So serves as the x, serves as the y. So we are good to go here. Now we just need our axis. So our axis, this is, well, what am I doing? This is the y, and this is the x, right? And then our asymptote, our horizontal asymptote is at y is equals to minus 1. So this is our asymptote. We are not supposed to go beyond that line. We're not supposed to touch that line. We get very close to it, but we actually never touch it. So that is x, that is y. And then we have our intercept right here. So how is our graph going to look like? It's going to look like this. So if this is what you wrote in the exam, unfortunately, this is wrong. This is wrong. This cannot be. This cannot be. This is actually very wrong. You will see why it is wrong when you do 4.4, because initially I had drawn it like this, but then in doing 4.4 I realized that no, wait a minute, this is actually wrong. So our graph is actually supposed to face the other way, right? Supposed to be greater when x is negative rather than when it is positive. So this is what it actually needs to look like. You will see why that is the case when we do the second question. So let's just do that. Here we have x is equals to, well, y is equals to minus 1. So let's do 4.4 so that I can show you what I'm talking about. It is further given that C is a point on f at y is equals to 19 over 8, right? And then the question, determine the coordinates of C prime, the image of C when C is reflected above the line y is equals to x. So that reflection, if we have AB, right, and we reflect about the line y is equals to x, we have BA, right? They just sort of interchange. So this is the reflection that we need to talk about. But we are only given the value of y. So it is up to us to find the value of x. So f of x is equals to a is how much again? 2 over 3, 4, 9. Okay, 2 over 3. Right. So 2 over 3 to the power x minus 1. Right. We have the value of y, which is 19 over 8. And then we are looking for the value of x, 2 over 3 x minus 1. So let's take minus 1 to the other side. So 19 over 8 plus 1 is 27 over 8. So we have 2 over 3 to the power x being equals to 27 over 8. So x is equals to log of 27 over 8 with a base of 2 over 3. Right, so we introduce log on both sides, we drop the x, becomes a coefficient of log of 2 over 3, and we divide both sides by log of 2 over 3. We end up with that. So x is equals to, so let me go ahead and put that in my calculator. So yeah, yes, log. The base is 2 over 3 and the number is 27 over 8. So x is equals to minus 3. This is the point. Minus 3 is the value of x. 19 over 8 is the value of y. We're supposed to reflect this point about y is equals to x. So first of all, let me show you what I was talking about when I said that the way that you do 4.3, it has to look like this rather than looking like this. Yeah, it becomes apparent when we do 4.4, because this point x is minus 3, right? So x is minus 3 somewhere. What am I doing? X equals to 3 minus 3 is somewhere here, and then 19 over 8 is 2.37, so somewhere here, right? So that is the coordinate. This is the coordinate C. That is the coordinate C. But if your graph is somewhere here, then x minus 3 would be negative. And when x is equals to minus 3, y would be negative. And you can see that that is actually not supposed to be the case. So yeah, in doing 4.4, if you made a mistake in 4.3, you should be able to realize. So when we reflect this, so this is C. So C prime should be 19 over 8. And then y is minus 3. There we go. So let me know in the comments, which video should I do next? We've done 1, 2, 3, 4. If you have not watched those videos, please subscribe, go to the channel and find those videos. But let me know, which video should I do next? Which question? Here we go. You just have to forgive me for the way this question looks. I know it is a bit skewed and so on, but I'm trying to save time. I'm trying to do these questions as fast as I can, okay? But anyway, stories. Let's take a look at 5.1. Write down the value of p. So what are we dealing with here? We have f of x, which is equals to a divided by x plus p plus q, right? And then in order for us to find the, I have to think about this, to find the vertical asymptote, we have to say that x plus p is equals to 0. So x is equals to minus p. This is how we find the vertical asymptote. Okay, so let's take a look at our graph and see if we can determine our asymptotes. We can see the vertical asymptote here, that x is equals to 1. That is the vertical asymptote. So what does that tell us? This tells us that when x is equals to 1, we have the vertical asymptote. Okay, we're back in business. X is equals to 1. So it should be easy to see that p is equals to minus 1. But let's see if this brings us back to the vertical asymptote being equals to 1. So we would have x minus 1 being equals to 0, x is equals to 1. So it's easy to see that indeed the vertical asymptote is equals to indeed p is equals to minus 1. Okay, and then 5.2, determine the equation of the horizontal asymptote. Determine the equation of the horizontal asymptote. The horizontal asymptote, we are looking for the value of q. That is the horizontal asymptote. Q is right here. We are looking for q. That is the horizontal asymptote. So how are we going to do that? We don't have f of x, right? And then we don't have any number that is given close to the vertical asymptote, like we were given in the vertical, close to the horizontal asymptote, just as we were given on the vertical asymptote. So how are we going to do that? Well, we are going to use the equation of the line of symmetry, right? We know that g of x is equals to x minus 3. Okay, g of x is equals to x minus 3. And our asymptotes p and q. P and q, they meet at not p but minus p. Minus p and q. Minus p and q. We know fully well that they meet right here at that point. They meet on the line of symmetry. So we can actually substitute the value of p in order to find the value of q, because the value of p is going to be our x and the value of q is going to be y. So we have q being what we're interested in, and then in place of x we have 1, right, minus p, minus 3. So q is equals to minus 2, right? So we can conclude here and say that our horizontal asymptote, we have y being equals to minus 2. This is what you need. Y is equals to minus 2, not q is equals to minus 2. I've seen this get marked wrong, right? On the, I think it was the prelim in Gauteng. So, you know, you're not supposed to end with q is equals to minus 2. You're actually supposed to go further and say y is equals to minus 2. We are not looking for the value of q. We're looking for the equation of the horizontal asymptote. Y is equals to minus 2. So there we go. Right, very basic things, but with just a bit of a twist, really. Yeah, they're very basic, but there's a twist. So I would expect this question to throw some people off. But anyway, stories. Let's take a look at 5.3. So 5.3, we are looking for the value of a, right? We know that f of x is equals to a divided by x plus p plus q. We're looking for a. We have p and q, so let's just sub them in our equation. F of x is equals to a divided by x plus p, so x p is minus 1, so x minus 1, and then q is minus 2, and then minus 2, right? And then x minus 1 is equals to 0, x is equals to 1, so we have the asymptote there. Okay, I was just checking if I'm substituting them in the correct way. So this is f of x as we have it. We need to substitute a point into f of x so that we can find the value of a. That's what I'm thinking. There might be another approach, but that's what I'm thinking. So let's see if we have a point here. Do we have a point we can substitute into f of x? Let's take a look. There has to be something we can substitute here. The graph of f casts the x-axis, or not the x but the y-axis at 0 and 1. So okay, we know that this point lies on f of x, so we can substitute it. In place of y we have 1, right? And then in place, let me see, in place of a, that's what we're looking for. In place of x we have 0, right? I thought x is minus 1. Issues were gonna arise there. I was not quite happy with that. So a divided by 0 minus 1 minus 2, so we have 1 being equals to a minus 1 minus 2. We take minus 2 to the left hand side, we get 3 is equals to a divided by minus 1, a is equals to minus 3. I think we can just end it there. A is equals to minus 3. But let's just go ahead and see if it makes sense. A is minus 3, x minus 1 minus 2, I think. X minus 1 minus 2. So let's substitute 0 and see if we get 1. Yeah, when we substitute 0, we get 1. So I'm quite convinced that that is the correct value of a. And then 5.4, for which values of x is f of x greater or equals to 0. So let's take a look at this wing here. When we take a look at that wing, f of x greater or equals to 0. Well, it is less than there. It is less than. It is less than. Because that is below the x-axis, right? Because we have the x-axis right here. So that wing is below the x-axis. So it cannot be part of our solution because it is always negative up to infinity. Okay. And then let's look at this other wing. The other wing, well, when does it become positive? We need to find values for which it becomes positive. Is that easy to find? We just know here that we have 0 and 1. So it becomes positive somewhere here, right? That's where it becomes positive. But we don't have the x value at that point. So I think we I think that we need to actually find the value of x for which it becomes it starts becoming positive, right? So how are we gonna do that? Well, what is the value of x when y is equals to 0? Okay, so that's the question. Let's take a look. F of x, we need it to be equals to 0. So we have 0 being equals to minus 3 divided by x minus 1 minus 2. So 2 is equals to minus 3 divided by x minus 1. Okay, so 2x minus 2 is equals to minus 3. So 2x is equals to minus 1. So x is equals to minus 1 over 2. So the value of x here at this point where it starts becoming positive is minus 1 over 2. So from minus 1 over 2 up until x gets very close to positive 1, our condition is satisfied, right? Our graph is gonna be greater than 0. Is that what we're looking for? Yeah, we're looking for the values of x for which f of x is greater than 0. So we need x to be, it says greater or equals to, so we can include minus 1 over 2, but we cannot include 1 because it is not defined at 1, right? We just get very close to 1, but it is actually not defined. So why am I using a bra and not a cat? We're supposed to write this one. Okay, so there we go. That is 5.4. And then what about 5.5? What about 5.5? I'll let you guys talk about it in the comments. What about 5.5? What about 5.5? I want to hear what you guys think. But ultimately, describe a possible transformation that f could have undergone to result in h. What is the characteristic of h? The domain and range of h are the same as that of f. Okay, and then h prime of x, the derivative of h is negative on its domain. So what is the possible transformation? Let me know in the comments. But should I give the answer? Okay, I have the answer in front of me, but I feel like if I give the answer, then it is no longer fun. So I'll let you guys talk about it in the comments. And then, after a couple of comments, 20, 30 comments. Yeah, give me 30 comments. And then I will sort of give you the answer to 5.5. Yeah, there we go. Which question do we do next? We've done 1 to 6. Do we just do 7, 8, 9, 10, 11, 12? Let me know in the comments. Calculate the coordinates of B, the turning point of F. We're given that f of x is equals to minus x squared plus 4x plus 5. So we want the coordinates of B, the turning point. What do we know about the turning point? We know fully well that the gradient at the turning point is equals to 0. So we can find f prime of x, of which this is going to be equals to minus 2x plus 4. And then we equate these to 0, right? So should be easy to see that minus 2x is equals to minus 4, x is equals to 2. That is the x value of B. Now let's go ahead and find the y value of B. So we substitute 2 into f of x, not f prime of x, but actually f of x. So we're going to have minus 2 squared plus 4 multiplied by 2 plus 5. So let me just go ahead and put this in my calculator. Minus 2, and then we square that. The minus is on the outside. I didn't put it inside. Don't worry about that. Plus 5. And then I'm getting the y value to be equals to 9. So the coordinates of B, x is 2, y is 9. Okay, let's take a look at 6.2. So 6.2 show that the equation of the line through A and C is given by g of x is equals to 2x plus 2. Okay, let's take a look at this. G of x. So g of x is a straight line, right? And then the point C is a point of intersection of f and g, which is right here. So this point lies on g of x. Does A also lie on g of x? Let's just go through the entire question statement. So the question says show that the equation of the line through A and C. Okay, so the line passes through A and then it passes through C. In order for us to find the gradient, we have the coordinates of C, which happens to be 3 and 8. So in order for us to find the gradient, we need to somehow find the coordinates of A, right? Which we can just factorize f of x. We can just factorize f of x, and then in doing that, we will have what do we call this? We will have the values of a. Let's see if there's another way of doing it. Is there another way of doing it? I cannot see an immediate way of doing it, but if there is, we can also explore that way. But here I can see that if I let minus x squared plus 4x plus 5 to be close to 0, I can find the x value of a and the x value of d, and be able to substitute it into what do we call this, and substitute it into f of x. Okay, so let's go ahead and see. So here, if we divide both sides by -1, we get x squared minus 4x plus 5, no, minus 5 is equals to 0. So x factors of -5, when you add, we get -4 minus 5 plus 1. This is equals to 0. So x is equals to 5 or x is equals to -1. It should be easy to see that x is equals to -1 is the x value at a, right? So x is equals to -1 is our x value at a. Okay, so there we go. We have a has coordinates -1 and 0, and c has coordinates 3 and 8. So let's go ahead and find their gradient, y2 minus y1 divided by x2 minus x1. So if we take c as the second point, y2 is gonna be 8, right? And then y1 is 0, and then x2 is going to be 3, x1 is going to be -1. So 8 divided by 4, that is 2, right? So we know now that the g of x is equals to 2x plus some c. In order to find c, we can substitute either a or c, right? Let's substitute a. A has coordinates -1 and 0. So when x is equals to -1, y is 0. So 0 is equals to 2 minus 1 plus c. 2 is equals to c. G of x is equals to 2x plus c. Okay, let me just tell you what the problem I have with this question. We got g of x is equals to 2x plus 2, not c. 2x plus 2. And we are quite happy with that. We are convinced that what we have done is correct. But take a look at this. In the diagram below, the graphs of f of x and g of x, a straight line, are drawn. C is a point of intersection of f and g. E is drawn parallel to the x-axis, and E, a point on f, and H are on g. Right. E, a point on f, and H, oh, okay, a point on g. Okay, I see that. But take a look at A. We are now told that A is an x-intercept, and nothing is being said about D. I was supposed to just look at it and conclude ourselves that those are x-intercepts. I mean, nothing here in the equation says that they are x-intercepts. But in order to find the equation of g of x, we have to take A as the x-intercept. But it is not said. So do we just look at it and say, oh, well, it's close to the x-axis, so it's the x-intercept? Is that what we're supposed to do? Is that mathematical? No, it is not. More especially if we are always told that, I can see point 8 here on the question paper, diagrams are not necessarily drawn to scale. So why am I now supposed to conclude that A is an x-intercept when I'm not being told? Or when it is not shown in some way, hidden or clear? So, not a fan of 6.2. I don't think it's a good question. I'm criticizing the examiner here. But anyway, so this 6.2. Let's take a look at 6.3. Calculate the maximum length of EH for F is greater than G. A basic equation that we always see. So EH is going to be F of X as it is at the top minus G of X, which is below it, right? So in place of F of X, we have F of X. What else are we going to have? But anyway, minus X squared plus 4X plus 5. And then we subtract G of X, which is 2X plus 2, okay? And then this is going to give us EH is going to be equals to minus x squared, it does not have a like term, and then plus 4x minus 2x, that is plus 2x plus 5 minus 2, that is plus 3. So this is EH. We are looking for, what are we looking for? we're looking for the maximum length, right? So we can already see that EH is a parabola, which is said it looks like something like this. So essentially, we're just looking for the turning point there. So we can derivate and equate to 0, or we can say x is equals to minus b divided by 2a. We can also do this. It's gonna allow us to find the value of x at the turning point. So this is minus 2a is minus 1. So is x equals to 1? It seems like that is the case. And then now let's substitute this value of x into EH. So EH is equals to minus 1 squared plus 2 multiplied by 1 plus 3. So we have, we have minus 1 because the minus is on the outside. So minus 1 plus 2, that is 1 plus 3. And then we get 4. So there we go. It seems like EH is a maximum when it is equals to 4. That is the maximum value of EH. Okay, 6.3. Let's take a look at 6.4. So we need to, think just a bit. 5 marks. Let's see what is happening. Given that k of x is equals to f of x plus m, and it is ultimately equals to minus x squared minus 2mx minus m squared plus 4x plus 4m. That is a lot. Let me erase that and write it again so that it can fit in the screen, because it seems like there's a lot happening here. So k of x is equals to minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5. If I sound animated, I'm high on caffeine, so I'm all over the show now, starting to get tired, but let's keep going. Determine the value of m such that g is a tangent. Determine the value of m such that g is a tangent. So g of x is a tangent. G of x is equals to 2x plus 2. So the first thing that we're going to do here, we're going to say that k of x is equals to g of x. That is the first thing that we're gonna do. K of x is equals to g of x. Why are we equating these two? Because in order for g of x to be a tangent, you can agree with me that k of x and g of x need to touch, right? But the special condition is that they need to touch only once. So we are gonna address that. First of all, let's just address k of x being equals to g of x, because we know that needs to be true. So let's go and see what we end up with. So k of x is equals to g of x. What does that give us? Minus x squared. Well, let me just copy k of x already because I have it, because it's quite long. I don't want to rewrite it. So this is k of x, and I want to duplicate it and put it here, and then I equate to g of x, which is 2x plus 2. So 2x plus 2. Okay, so I'm going to take 2x to the left hand side, obviously. So I'm going to have minus x squared minus 2mx and then minus m squared plus 4x minus 2x, that will be plus 2x, and then plus 4m plus 5 minus 2 plus 3. This is equals to 0 when we take that to that side. Okay, so let's just rewrite this in a more acceptable form. Let me show you what I'm talking about when I say in a more acceptable form. So minus x squared. That is the only thing with x squared here, right? Okay, yeah, it seems. So let's find the things with a coefficient of x. Those are the two. So minus 2mx plus 2x. And let's find, and then here I'm just writing minus m squared plus 4m plus 3 being equals to 0. So this is the equation that we have. We can still, simplify that further. Let's do that. Minus x squared, and then minus, I want to take x as a common factor from these two terms. I want to take x as a common factor. So let me say plus x, and then I'm going to have minus 2m plus 2, right? And then this right here is just a constant, right? So we have minus plus, let's say plus, minus m squared plus 4m plus 3 being equals to 0. So this is A, this is B, this is C. All right, so we need to find the discriminant of that. We need to find that thing, that delta, which is equals to b squared minus 4ac. Why do we need this delta? Because when this delta is equals to 0, g of x and k of x only touch once. When that thing is equals to 0, they only touch once. That is very important to realize, that when that thing is equals to 0, they only touch once. Okay, so b squared, that is going to be minus 2m plus 2 squared. And then minus 4. A is minus 1. And C is minus m squared plus 4m plus 3. There we go. So minus 2m plus 2 squared, that is going to give us 4m squared minus 8m plus 4. Okay, so I've just solved what is inside the brackets there. Yeah, I'm underlining here so that I can not lose track. And then minus 4 plus multiplied by minus 1, that will be plus 4, right? And then what about these? Okay, that is just that. That is m squared, well, not m squared, but minus m squared. That is minus m squared plus 4m plus 3. Okay, and then this is equals to 0. So my 4m squared minus 8m plus 4 minus 4m squared plus 4 multiplied by plus 4m plus 8m plus 12 is equals to 0. So 4m squared minus 4m squared, that gives us 0. And then minus 8m plus 8m, that also gives us 0. And then 4 plus 12, that is 60. So we get 16 is equals to 0. Okay, I think the issue might lie here. Okay, because m cannot be 0. Well, it can't be 0 because the question just says determine the value of m. But let's re-evaluate these. Let's take a look at these once more. So, shouldn't have erased that. Let me just erase some of it and not all of it. So let me erase, and then yeah, this right here is this part. This right here is this part. So let me do this part, minus 4ac, right? So I have minus, let me erase this. No, I don't want to erase the entire thing. Let me show you what I want to do. So I want to drag these. And say minus 4ac. So I want to find the 4ac separately, right? So I have minus, and then I have my 4 right here, and then I want to solve that, which is inside the brackets there. So when I solve that, obviously I can start out by multiplying with 4, right? And then not 4 but minus 1. So I'll get 4, and then m squared plus, not plus, but minus 4m. Minus 4m plus 3, right? Plus 3 or minus 3. Minus 3 actually. Minus 3. Okay, so that is minus 3. And then this is equals to 0. So 4m squared, we will get, okay, I'm still solving what is inside the brackets there. So 4m squared minus 8m plus 4 minus what is inside the bracket. Inside the brackets, I have 4m squared plus, not plus, but minus 8. No, 4 multiplied by 4 is 16. So I think that is where the issue was arising. It is 16 minus 16m. Now I see where the problem was. Minus 12. Damn it. Almost lost it there. So 4m squared minus 4m squared, that is 0. And then minus 8m minus 16m. That is going to give us plus 8m. And then plus 4 minus 12. So 4 plus 12, that is 16. This is equals to 0, it seems. So 8m is equals to 16. So m is equals to minus 2. M is equals to minus 2. Okay, I see what the problem was. You know, sometimes you do the right thing, you just make one small algebra mistake and you're gone. But let's test and see if it is actually correct, because I'm going to have people in the comments saying, no, it is not correct, this is the correct way, blah, 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 I did this, I did that. Send us your solution. Don't just give us your opinion, send us your solution. Let's take a look at your work. Right, so k of x will now be equals to, because we are saying that m is minus 2, k of x is going to be equals to minus x squared, right? And then minus 2 minus 2, that is the value of m, x, right here it is, and then minus m squared, so that is minus 2 squared, plus 4x plus 4m, m is minus 2, plus 5. So k of x is equals to minus x squared plus 4x, and then this is going to give us 4, and then we're going to have minus 4 plus 4x minus 8 plus 5. Okay, so kx squared is minus x squared plus minus here plus 8x. So minus 4 minus 8 plus 5, that is minus 7. Minus x squared plus 8x minus 7. So this is k of x, and then g of x is equals to 2x plus 2. Okay, so these two things, they must touch once. So how can we prove that they actually touch once? Let's equate them and see if we get one solution. So minus x squared plus 8x minus 7 is equals to 2x plus 2. So minus x squared plus 6x minus 9 is equals to 0. I'm giving myself a very unnecessary headache. Okay, so okay, fine. So x squared minus 6x plus 9 is equals to 0. I just divided both sides by minus 1. So that is mathematically correct. So let's see if the discriminant here is going to have is going to be equals to 0. Okay, so that delta b squared minus 4ac. So b squared, that is minus 6 squared, minus 4, a is 1 and c is 9. So this is 36. And then 9, 18, 36. This is 36 also. So this gives us 0. So the discriminant is actually 0. So I'm quite convinced that we have finally done. We finally determined the correct value of m. Okay, so there we go. Which video do you want me to do next? Okay, let's take a look at 8.1.1. We have d over dx of 3x minus 5x squared. We can simply use the power rule here, right, to determine that, of which we're going to get 3 minus 10x. No complications there. We're just using the power rule. And then taking a look at 8.1.2, we're supposed to find g prime of x when g of x is equals to 2 over x squared minus 3, and then we have the square root of x to the 7. So a few issues might arise here. We are not able to use the power rule when our function looks like that. So what do? We just rewrite it. We don't have to really complicate things. What do I mean by that? Let me show you. So we're gonna have, for the first part, g of x is equals to 2 multiplied by x to the minus 2. When you bring x squared to the numerator, the power changes sign, right? And then we're gonna have minus x to the 7 over 3. So when we have written it like this, we can then derivate. And then we are able to see g prime of x. We cannot say g prime of x at this step. It would be wrong. We say it on the last step. So this will be equals to minus 4x minus 3, right? And then minus 7 over 3 x to the 7 over 3 minus 1. So 7 over 3 minus 1, 4 over 3. So 4 over 3. So g prime of x is minus 4 divided by x to the power 3 minus 7 over 3 x to the 4 over 3. So I think we can leave it like that. I don't think we can be required to further simplify it. I think that is perfectly fine. And then 8.2, determine the equation of the tangent to f of x at x is equals to 2. So f of x is equals to x to the power 3 minus 4x squared plus 2x plus 3. When we derivate this, right, we are going to have 3x squared minus 8x plus 2. And then we substitute 2. So f prime of 2 is equals to 3 multiplied by 2 squared minus 8 multiplied by 2 plus 2. And I think this is minus 2. So that is 8.2. And then 8.3.1, we're supposed to find f prime of x using first principles. If f of x is equals to minus 6x squared. So I'm not going to do this one just for the sake of time. But ultimately, the answer we should get, f prime of x is equals to minus 12x. Right. This will be f prime of x. But you're supposed to use the first principles. You can see the mark allocation is 5. Easy marks, really. Free marks. The mark allocation is 5. But you're supposed to use the power rule. You're not supposed to... you're supposed to use first principle, not the power rule. The power rule just helps you to see if you've done the correct thing. And then 8.3.2. Write down how you will restrict the domain of f such that f inverse... the inverse of f is a function. Okay, in order for me to explain this, I will also be answering 8.3.3 in the same way. Let me show you why. Okay, so y is equals to minus 6x squared, right? So the inverse is x is equals to minus 6y squared. So we end up with y squared being equals to x divided by minus 6. So y is equals to plus or minus x divided by minus 6. So you can see that we need values of x to be negative here. We need values of x to be negative because when values of x are negative, it ensures that the square root is defined. Because if x is positive, it's not going to be defined because we cannot take the square root of a negative number. So we need x to be positive here. We need x to be greater than 0. So this is the restriction we can impose. We need x to be greater than 0. Because when x is greater than 0, the square root is going to be defined. If it is 0, it is undefined. If it is negative, it is. And, well, we don't need it to be greater than 0. We need it to be less than 0. We need x to be less than 0. Because if x is positive, let's say 2, for instance, when I have 2 divided by minus 6, which is minus 1 over 3, and that is going to be undefined because it is under the square root. So we need x to be less than 0. For instance, minus 6. We're going to have minus 6 divided by minus 6, which is 1, and that is 5. So, okay, there we go. We need x to be less than 0, not greater than. Okay. 8.3.3, determine the equation of f inverse for which f inverse is less or equals to 0. Write your answer in the form y is equals to. So you can see we have a plus or minus. If we need it to be less than 0, this is the option that we need to take. F inverse of x is equals to minus the square root of x divided by minus 6. Here we go. For which values of x is f decreasing? For which values of x is f decreasing? So we look at our function from left to right, right? We're not from right to left. Let me show you what I'm emphasizing, that from here going there, x is not decreasing, right? Because we look at it from left to right, we actually have to go that way in order to see whether it is decreasing or increasing. So here x is, well, not x but f is increasing. It decreases until it reaches a, which is a stationary point, right? A and b are the turning points. It is neither increasing or decreasing at a and b. But let's look at what happens between a and b. Clearly you can see that it is decreasing here from a to b, and then when it reaches b, it turns, hence turning point, and it starts increasing once more. It has a positive gradient, and here between a and b, it has a negative gradient. So we say that it is decreasing there. So the answer to 9.1, for which values of x is f, decreasing. F is decreasing between 1 and 5/2, right? The x value of a and the x value of b. That's where it is decreasing. In between, at a, it is neither. It is stationary. At b, it is stationary. It is decreasing between a and b. So we're not supposed to include 1 and 5/2, which I think probably, most definitely, some people did include those 2 points. But if you think about it, we're not supposed to include them. The function is stationary at a and b. That's why the turning points are sometimes called the stationary points. Okay, so that is 9.1. What about 9.2? Write down the x-intercepts of f prime, the derivative of f. So the x-intercept, right, is at the turning point. The x-intercept is at the turning point. So when x is equals to 1, we have an x-intercept, and when x is equals to 5/2, we have an x-intercept. So the coordinates, right, of the x-intercept, we're going to have x is equals to 1, y is 0. X is equals to 5/2, and y is 0. Right, so that is how it works. The stationary points of the cubic function will give you the intercepts of the derivative, which is the quadratic function. So that is 9.2. And then 9.3, for which values of x is f concave up. So take a look at this. Take a look at this. From here, right, up until somewhere in between here, somewhere in between, it is concave down, as we can see, but the concavity changes, and then now it becomes concave up from this part up until infinity. So we need to find this point where the concavity changes. It is called the point of inflection. How can we find that point? We can say that x is equals to x of tp1 plus x of tp2, right, divided by 2. That's where we're going to find our point of inflection. So x is equals to 1 plus 5/2 divided by 2. What do? I put that in my calculator. So 1 plus 5/2, everything divided by 2. I'm getting 7/4. So x is equals to 7/4. So this point that we're interested in between a and b, it is 7/4. So we're looking for the values of x for which it is concave up. So from 7/4 up until infinity, it is concave up. So what are we saying? We're saying that x can run from 7/4 up until infinity, that is 9.3, right? And then it is concave down from 7/4 up until negative infinity. Okay, but at 7/4 it is neither concave up or concave down. It's confused. It does not know what it is. It cannot identify as one between the two. That is 9.3. And then 9.4, the question that we've done countless times. Maybe let me not say countless times, maybe 5, 6, 7 times, something like that. But then why am I bringing that up? Let me show you why I'm bringing that up. We are looking for the value of k for which y, okay, I'm not supposed to do that. Let me go down. For which y is equals to f of x plus k as 3 positive x-intercepts. We're looking for the values of k for which this thing will have 3 positive x-intercepts. So let's dissect that. Let's make sense of that and see what we need to do. So as you've seen on the previous video, when we are doing this equation, let me trace the function first so that I can demonstrate it to you with a bit of clarity. So you will see why I'm doing that. You will see why I'm doing that. So I want to show you something. Okay, so this is f of x, right? What does plus k do, right? Plus k, it moves the function up and down. If k is positive, it is pushing the function up. If k is negative, it is pushing the function down. That is what k does, right? So do we need the function to go up? No, we don't need the function to go up, because if it goes up and up and up, we are always going to have one negative x-intercept, and we are looking for 3 positive x-intercept. So how do we get to 3 positive x-intercepts? Take a look at this. Okay, we take this down. How many intercepts do you have? 1 negative. We take it down once more. 1 negative. We take it down. 1 negative. Again, 1 negative. But when we reach this point, right, when b touches the x, the x-axis there, we still don't have 3 positive. But take a look at this. What happens there? Now we have 3 positive, right? Let me show you why I'm saying we have 3 positive. We have this positive 1 here. We have another positive intercept here, and we have the third one there, right? So when k, which takes the function down. So if k, we have plus k here, so we need to be careful with how we write this. If k is greater than minus 8, our condition is satisfied. If k is greater than minus 8, our condition is satisfied. Because, for instance, if k is minus 8.5, then we achieve 3 positive intercept, right? But it does not end there. There's a limitation that I need to show you. So let's say we keep going down, and the x value at a touches the x-intercept, because we would have a here, right, and we would have b here. So you can see that when that, not the x value but the y value, when that y value at a touches the x-axis, we have a problem. We no longer have 3 positive. So we need k to be greater than minus 8, but we need k to be less than minus 9. If these two conditions are satisfied, then we're going to have 3 positive x-intercepts. That is question 9. There we go. Which question do you want me to do next? Question 10, 11, 12? Do we go to 7? Let me know in the comments. Hey, if you think about this, doesn't make any sense, right? Because minus 9 is less than minus 8. These are not positive numbers. So we're not supposed to write it in this way. We're not supposed to write it in this way. Rather, we're supposed to say that k should be less than minus 8, but it should be greater than minus 9. This is the correct way of writing it, because minus 8 is greater than minus 9, right? Not the other way around. I hope nobody made that mistake that I just did there. But anyway, stories. We're doing question 10. Let's go. So a cyclist rode from town P and stopped at town T, right? The speed in kilometers per hour at which the cyclist rode is represented by the equation s prime of t is equals to minus 3t squared plus 18t. And the first question, 10.1, calculate the maximum speed that the cyclist reached on this ride. And then we're supposed to note that speed is the rate of change in distance with respect to time. I would assume that that note is for people that are not doing physics, because if you're doing physics, there's no way you don't know that. But anyway, stories. We're not here to make fun of people that don't do physics, right? We accept them as they are. But let's take a look at the equation. We are looking for the maximum speed. This is the equation for the speed, and we can see clearly that this is a quadratic equation, right? Of which it is concave down. It should look something like this. So the maximum speed, we're essentially looking for the turning point, right? So what can we do? We can derivate and equate to 0, or we can just say minus b divided by 2a. I saw somebody say, no, we're not supposed to use minus b divided by 2a, we're supposed to derivate. I don't think it really matters. We can do whatever. We get to the same answer. But if we derivate, s prime of t will be equals to minus 6t plus 18. So at the turning point, the gradient is 0, right? So we know fully well that we're supposed to see minus 6t plus 18 is equals to 0. T is equals to, well, minus 6t is equals to minus 18. So t is equals to 3. So there we go. That is the value of t. But we're looking for the maximum speed, not the value of t for which we are going to have a maximum. So what are we going to do, therefore? Well, let's just prove that this t is indeed equals to 3, right? We can do that by saying t is equals to minus b divided by 2a, of which minus b, that is minus 18, divided by 2a, a is minus 3. So we have minus 18 divided by minus 6, which is 3, right? 6, 12, 18. So you can see we end up with the same thing. But we need to substitute this speed here, right? And see what, not the speed but the time, and see what speed we get. So 3, 1, 2 plus 18 t, that is 1. This is equals to, so let me just substitute that. Minus 3 multiplied by 1 squared plus 8 multiplied by 1. So this is equals to 15. Let me just verify. Plus 18. T is equals to 3. Why am I substituting 1? Why am I substituting 1? This is fatigue. That's what happens when you are extremely tired. So minus 3 multiplied by 3 squared plus 18 multiplied by 3. And this is equals to 27. So the maximum speed is 27. Let's take a look at 10.2. 10.2, calculate the distance between town P and town T. The distance between town P and town T. Okay, it's a bit complicated. How do we do that? We don't have, well, do we have the time it takes? Do we have the time it takes? Do we have the time it takes to go from P to T? Do we have that? We are not given the time it takes. Is there a way to find it? Is there a way to find the time taken? So we are going from P to T, right? I think we can actually find the time taken. I think we can. Okay. So at T, we stop at T, right? So we know fully well that the speed here at T is equals to 0 because we stop there at T. But what about P? We should be cycling from 0 at P, right? We should be cycling from 0 because you cannot start cycling at 10 kilometers per hour. You have to start cycling at 0. So the speed is also 0 there. So let's find the intercepts so that we can find the time, right? Because we clearly have a graph of which x is time and y is the speed. So we can find the time. So s prime of t is equals to minus 3t squared plus 18t. So let's find the intercepts so that we can find the time, right? Because where the intercepts, we are going to be able to find the distance between the intercepts, and that is going to give us the time. So minus 3t squared plus 18t is equals to 0. So if we take t as a common factor, minus 3t plus 18 is equals to 0. T is equals to 0, or t is equals to 18 divided by 6. That's 6. So, right, our time t is 6 hours. So this is our time t. We have the time t in 6 hours, and we have the equation of the speed, right? It is equals to minus 3t squared plus 18t. Okay, so I will now proceed and solve this question in two ways. One way of solving this question is to use what we call integral. We need to integrate, right? So when we integrate, essentially the idea is, you can see here that we have s prime of t, right? We have a derivative. So we are asking ourselves, what was the equation before we derivated? And what does that give us? Because this note that we're given, it says speed is the rate of change in distance with respect to time. So it means that before we got this equation, because we can see that it is a derivative, we had the distance with respect to time. And then when we derivate, we get speed, right? So we can ask ourselves, what was the equation that gives us distance before we derivated? That's what we mean by essentially finding the integral. So let me show you how that plays out. So s of t, right? Because now we are finding the integral. So before it was minus 3t squared. What was it? That's the question we're asking ourselves. Because before it was minus 3t squared, what was it? It's it's not too complicated, but that is the question we're asking ourselves. But after we do it in this way, I'm gonna also show you another approach that we can also take. So if we go ahead and use that approach, we're gonna have minus t to the power 3, right? Because if we derivate minus t to the power 3, we get minus 3t squared. Okay, so we can agree that this is before we derivate. Oh, this is what we have before we derivate and get minus 3t squared. And then what about plus 18t, right? Well, we need to have 9 here and then t squared, because if we derivate that, we get 18t. So this is the formula for the distance that we had before we derivated to find s of t, plus c. You might ask yourself, what is c? Well, c is a constant, because we know fully well that when we derivate, a constant falls off. T might be 0, right? Meaning that we had no constant. But we always include it to show that we are aware that we might have had a constant. But when we find in a definite integral, what do I mean by a definite integral? We have t going from 0 to t being equals to 6. Because we have this limit, this is a definite integral. So we're gonna evaluate this integral from t is equals to 0 to t is equals to 6 in the following way. So we're gonna say the distance is going to be equals to s at 6 minus s at 0. Okay, so let's evaluate this. S at 6, we're going to have minus, and then in place of let me use bra to show s of 6. So here we have s of 6, right? So it's going to be minus 6 to the power 3 plus 9 6 squared plus c, okay, and then minus s at 0. So we have minus 0 to the power 3 plus 9 multiplied by 0 squared plus c. Obviously, c and c will cancel out. That's what always happens when we have a definite integral. We don't even have to worry about the value of c, because they're going to cancel out. So this is equals to, so we can see that this will give us 0, right? So we can forget about that part and just focus on s of 6. S of 6, we're going to have minus, and then 6 to the power 3, okay, plus 9 multiplied by 6 squared. This is 108. So we have 108. So what does the equation say? Calculate the distance between P and T. So we're talking about kilometer per hour. So 108 kilometers. Can a person cycle 108 kilometers? But that's what we have. That is the distance when we use an integral. But integrating is not part of our curriculum. So which other possible option do we have? Let's evaluate that. So another possible option we have is to find the speed when t is equals to 0, t is equals to 1, 2, 3, 4, 5, 6. We can find the speeds when t is equals to these values. And after we do that, we can just find the average and multiply it by the time. So let's go ahead and do that. So minus 3 multiplied by 0 squared plus 18t. That will give us 0, right? And then when you substitute 1, minus 3 multiplied by 1 squared plus 18t. And this gives us 15. Let me substitute 2. When I substitute 2, I get 24. When I substitute 3, I get 27. What about when I substitute 4? When I substitute 4, I get 24. When I substitute 5, do I get 15? Seems like it. And when I substitute 5, I get, I substituted 15, not 5. When I substitute 5, I get 15. When I substitute 6, I think I should get 0. So let's see. I get 0. So yeah, this is the speed for each hour from t is equals to 0 up until t is equals to 6. So we can find the average speed here, right? So the average, I'm not supposed to do that. So the average speed, is going to be equals to 0 plus 15 plus 24 plus 27 plus 24 plus 15 plus 0, right? And we divide all of these by 6 because we are finding the average, right? We know what x bar is equals to. So 0 plus 15 plus 24 plus 27 plus 24 plus 15 plus 0 divided by 6. This is 17.5. So 17.5 kilometers per hour. This was the average speed. So now we can say that the distance is equals to the speed multiplied by the time. So the speed is 17.5. The time is 6 hours. So let me multiply that by 6. When I do that, I get surprisingly 105 kilometers. Oh yeah, I got 108. And then when I use the average, I get 105. They're very close to each other. So I'm quite happy with my solutions here. Tell me, what did you do for this question? Let me know in the comments. Here we go. Determine how many different codes can be formed if letters and digits may be repeated. What's our scenario? A company generates a 4-character code using the 26 letters of the alphabet and the 10 digits 0 to 10. And the code is in the form letter, digit, letter, digit. And then 12.1, we are supposed to find the total number, right? The question says determine how many different codes can be formed if letters and digits may be repeated. So we have letter, digit, letter, digit. So how many letters do we have? We have 26, right? And then how many digits do we have? We have 10. But repetition is allowed, right? How many different codes can be formed if letters and digits may be repeated? So when we fill the third spot with a letter, we still have 26 options. And when we fill the fourth spot with the digit, we still have 10 options. So the answer here, so that is 26 squared multiplied by 10 squared. 67,600. So there we go. That is the answer to 12.1. Let's take a look at 12.2. Looks like we have some conditions here. Determine how many different codes can be formed if the letters D, F, I, Q, U, and V may not be used. So of the 26 letters, how many are we subtracting? 1, 2, 3, 4, 5, 6. So we are subtracting 6 letters. And now we only have 20 letters, right? Okay. And then the code may not start with a W or Z. Is W or Z one of the letters that we eliminated? No. Okay. That is important to address. Letters or digits may not be repeated. Okay. And then the code ends with an odd digit. Okay, so those are our conditions. Let's go ahead and play around and see what we can come up with. Okay, so we have one. What am I doing? We have 1, 2, 3, 4 spots that we need to fill. So let's start with the spots that have conditions. The spot that have conditions is the first and the last, right? We have special conditions there. So the last spot, the code ends with an odd digit. So how many odd digits do we have? So the digits that we have is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So odd, that is even. Odd, 7 is odd, 9 is odd. So we have 1, 2, 3, 4, 5. We have a possible of 5 digits that can fill the last spot. We have only a possible of 5 digits that can fill the last spot. Okay, so we put 5 there because of that. And then let's come to the first spot, which we also have a condition. The code may not start with a W or a Z. So how many letters can possibly occupy the first spot? We have only 18 letters that can possibly occupy the first spot, because we have removed 6, right? Because we cannot use them anymore. But of those 20 that are remaining, we have 2 that are not supposed to occupy the first spot. So we have 18 there. And then the second spot, do we have any condition there? No, we just need a digit, right? But we have already exhausted 1 digit on the last spot. We have exhausted 1 odd digit. So of the 10, we are left with 9 here on the second spot. So there goes 9. And then on the third spot, we've already, of the 20 letters, right? We've already used 1 on the first spot. So we're actually left with 19 there on the third spot, where we need to assign a letter. So let me put this in my calculator. 18 multiplied by 9 multiplied by 19 multiplied by 5. This is equals to 15,390. So the W or Z, they should not occupy the first spot. Okay, so I'm quite happy with what we've done there. Okay, this is the answer to 12.2. Let's take a look at 12.3. 12.3 is just out of 2 marks. So I want you guys to let me know in the comments. How did you answer this question? Calculate the percentage increase in the number of different codes that can now be formed. Right. So how did you answer this question? What is your solution? Can you write it down in the comments? I'd like to see what your answer is. There we go.
X squared minus 7x plus 12 is equals to 0. Right. So we are supposed to solve for x, right? So if we try and factorize this, we're going to get x, and then on another bracket, we also have x being equals to 0. The right question to ask yourself at this point is, which 2 numbers do I multiply and get 12? And then when I add them, I get minus 7, right? That is minus 4 and minus 3. So we're going to get x minus 4, x minus 3 being equals to 0. So it is easy to see from this point that x is equals to 4 or x is equals to 3. And just like that, you have scored yourself 3 marks. And then the following question, 1.1.2, we have x multiplied by 3x plus 5 being equals to 1. We're supposed to solve for x correctly 2 decimal places. As soon as you see 2 decimal places, at this point you should know that you're supposed to use the quadratic formula, right? So let's go ahead and try writing this in standard format. So if we solve the left hand side, we're going to get 3x squared plus 5x is equals to 1. We take 1 to the other side to get 3x squared plus 5x minus 1 is equals to 0. Right? We know that we cannot factorize this. So let's just go ahead and paste the quadratic formula. X is equals to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Right? So if we go ahead and substitute, so this constant here, 3 is A, 5 is B, and minus 1 is C, right? So that we on the same page. And then if we substitute, we're going to get, in place of minus B, we have minus 5, and then plus or minus B squared. So we're going to have 5 squared minus 4AC. A is 3 and C is minus 1. Everything divided by 2A. A is 3, right? So we have X, and then X will be equals to, so one value you're going to get 0.18, and the other value you're going to get X being equals to minus 1.85. And just like that, we've solved for X using the quadratic formula. Let's see if we can do 1.13, right? It looks a bit more interesting. So for 1.13, we have X squared, which is less than minus 2x plus 15. Let's take minus 2x plus 15 to the left hand side and see what we get. We're going to have x squared plus 2x minus 15 being less than 0. What can we do now? Critical values. We need our critical values, right? So to find our critical values, we're going to say x squared plus 2x minus 15 is equals to 0. Again, we're going to open two brackets. We're going to open two brackets and ask ourselves that key equation again. Which two numbers do I multiply and get minus 15? But when I add them, I get plus 2. That is plus 5 and minus 3. So we're going to get x plus 5, x minus 3. So x is equals to minus 5, or x is equals to 3, right? So let me propose something to you. What if I say x is between minus 5 and 3? Is this the case? We cannot just conclude that that holds, right? We have to actually test it out and see if our inequality is going to be maintained. So a number between minus 5 and 3, let's go ahead and take 1, right? So let's not forget that we started with x squared being less than minus 2x plus 15. So if we take 1, we're going to get 1 squared on the left hand side, right? So that is 1, which is supposed to be less than minus 2 multiplied by 1 plus 15. So we have 1 being less than, so we have minus 2 plus 15, that should be 13, right? And then indeed 13 is greater than 1. So this is actually our answer. This is what we're looking for. But what were you gonna do if we took a number between minus 5 and 3 and then our inequality was not maintained? What were you gonna do next? What was gonna be our solution? You need to watch the other videos I've done on solve for x to know what to do in such cases. Because this right here, this is not always the case, right? Some people think that it is always like that, but I'm telling you, it is not. You need to actually check that out. And then 1.1.4, we have the square root of 2 multiplied by 1 minus x being equals to x minus 1. So it's easy to see here that we can square both sides to get rid of the square root, right? We're going to get 2 multiplied by 1 minus x being equals to x squared minus 2x plus 1, right? So we squared here, and then on the left hand side, we're going to get 2 minus 2x being equals to x squared minus 2x plus 1. Right, so if we take minus 2x to the right hand side, it is going to be plus 2x, right? And then if we take 2 to the left, to the right hand side, it's going to be minus 2, right? And then ultimately, we're going to get x squared minus 1 being equals to 0. So x squared is equals to 1. So x is equals to 1, or x is equals to minus 1. Right? So every time when you start with the square root and you square both sides, right, you're probably going to have an answer which is not necessarily true for the original equation you started with. So we actually have to go and check whether x is equals to 1 is actually a solution to the equation we started with, and then we check also for x is equals to -1 to see if it's actually a solution for what we started with. So let's go ahead and do that. We have the square root of 2, 1 minus x being equals to x -1. So when x is equals to 1, what are we going to get? We're going to get the square root of, so we're going to have 1 minus 1. So we just get 0, right? Being equals to 0 essentially. So 0 is equals to 0. So when x is equals to 1, there's no issues arising. What about when x is equals to -1? Let's see. We're going to have 2 multiplied by 1 minus x. So that is 2 multiplied by 1 plus 1. Basically 2, right? And then we're going to have minus 1 minus 1. So here on the left hand side, we're going to have the square root of 4 being equals to -2, right? So you can see that this doesn't hold. So our answer here is only supposed to be x is equals to 1, right? And then 1.2. So for 1.2, we're supposed to solve for x and y simultaneously, and then we're given 3 to the x plus y is equals to 27, and x squared plus y squared is equals to 17. Let's see if we can manipulate these first before moving to the second equation. So it's easy to see that we can write these as 3 to the x plus y being equals to 3 to the power 3. So x plus y is equals to 3, right? So what can we do? We're told that x squared plus y squared is equals to 17. Let's try squaring both sides and see what we're going to end up with. If we do that, if we square both sides, we're going to have x squared plus 2xy plus y squared being equals to 9, right? And then we can have x squared plus y squared plus 2xy being equals to 9. We know that x squared plus y squared is equals to 17, right? So let's sub that in there. So we're going to have 17 plus 2xy being equals to 9. 2xy should be equals to 9 minus 17. So that should be minus 8. Right. So that is what we have there. So 2xy is equals to minus 8, right? But we know that x plus y is supposed to be equals to 3. So if we make y the subject of the formula, we can say that y is equals to 3 minus x, right? So let's substitute this back into this equation. If we do that, we're going to get 2, and then x is x, so x is x, and then y is 3 minus x, and then this is all equals to minus 8. 6x minus 2x squared is equals to minus 8, right? Now let's take minus 8 to the left hand side. We're going to get 6x minus 2x squared plus 8 being equals to 0, right? And then if we divide everything by minus 2, we're going to get minus 3x plus x squared minus 4 being equals to 0, right? So we can write this nicely as x squared minus 3x minus 4 is equals to 0, right? So now what are we looking for? We are looking for two numbers that when we multiply, we get minus 4. When we add them, we get minus 3, right? So that is minus 4 and plus 1. So we have x plus 1, x minus 4. So x can be equals to minus 1, or x can be equals to 4. But what is y when x is equals to minus 1? We know that y is equals to 3 minus x. 3 minus x. So when x is equals to minus 1, y should be equals to, so that is 3 minus 1, y should be equals to 4. And then when x is equals to 4, y is equals to 3 minus x. So y is equals to 3 minus 4. Y should be equals to minus 1. Right, so that is 1.2. If you want to see the solution for 1.3, click this video in the screen right now. Let's look at 1.3. Determine without the use of calculator the value of whatever this is. Right. We have a series. What is a series? A series is a summation of the terms on a sequence, right? So you can see that for the first term, we have 1 divided by square root of 1 plus square root of 2, right? So that is the first term. And then the second term, we have 1 divided by square root of 2 plus square root of 3. And then the third term, as you can see, is 1 divided by the square root of 3 plus the square root of 4. So when I looked at this problem, I'm like, okay, fine. I can see the trend. I see what is going on here. We have Tn is equals to 1 divided by square root of n plus square root of n plus 1. Right. So I have the general formula for the terms of this series, right? So all I need to do now is to calculate the sum, and then I have the answer to 1.3. The question says that we must determine without the use of a calculator the value of that series that we are given there, right? So in order to determine the sum, I need to know which sequence it is. Is it arithmetic? Is it geometric? Or is it quadratic, right? It has to be one between the three under normal circumstances. And if that is the case, I can easily go ahead and solve the problem. So if it is arithmetic, then we must have a common difference. But then when I try computing the common difference, I cannot get a common difference. So it is not arithmetic, right? And then the next thing I tried is to find a common ratio. If it is geometric, we must have a common ratio. And then the same is true. When I divide T2 by T1, it is not equals to T3 divided by T2. We don't have a common ratio. And lastly, quadratic, the second difference must be constant. But when I actually compute that, the second difference is not a constant. So it is not one of the three, right? That process probably took me like 3 minutes. And then what came after that took me about an hour to solve a question that is just out of 3 marks. So ultimately, you have to realize that you have to rationalize the terms of this series. What do I mean by that? So let's look at T1, for instance. T1 is equals to 1 divided by square root of 1 plus square root of 2. So if we want to rationalize this fraction, we have to multiply it by the conjugate, right? So we multiply it by square root of 1 minus square root of 2 divided by square root of 1 minus square root of 2, right? Because that is just equals to 1. So we basically multiply it by 1. But then now our answer is going to be rational, right? So if we compute that, you're going to get T1 being equals to square root of 1 minus square root of 2. Divided by, now I want you to see something. So we have square root of 1 plus square root of 2 multiplied by square root of 1 minus square root of 2. So that is a difference of 2 squares, right? So we're going to have 1 minus 2 in the denominator, right? And then we're going to get square root of 1 minus square root of 2 divided by minus 1. If you compute that, you're going to get minus square root of 1 plus square root of 2. So this is T1, right? Let's go ahead and do the same for T2. So if you do the same for T2, we have 1 divided by square root of 2 plus square root of 3. And then again, we are multiplying by the conjugate, right? To get square root of 2 minus square root of 3 divided by square root of 2 minus square root of 3. On the numerator, we're going to get square root of 2 minus square root of 3 divided by 2 minus 3, right? So our answer here will be minus square root of 2 plus square root of 3. So that is T2, right? So let's just do the same for T3 and the last term. We don't have to do that for all the terms. It will take forever. So if we do that for T3, we're going to get 1 divided by square root of 3 plus square root of 4. You already know what we're going to do from here, right? But then ultimately, our answer will be minus square root of 3 plus square root of 4. That will be our final answer after we do all that we've been doing, multiplying by the conjugate and so on. So that is T1, T2, and T3. Now we just need the last term, right? Now we just need the last term, which is actually T99, because we can see here we have 99. So it will be T99. So if we do the same thing we've been doing for T99, we're going to have 1 divided by square root of 99 plus square root of 100. And then this will give us minus square root of 99 plus square root of 100. Right, so now we have our terms rationalized. Let's write our series again, but then now we're using the rationalized terms, right? So if we do that for T1, we have, what do we have for T1? We have minus square root of 1 plus square root of 2, right? But minus square root of 1 is just minus 1, right? So we have minus 1 plus square root of 2. That is the first term, right? Plus the second term. So let's go ahead and add the second term. For the second term, we have minus square root of 2 plus square root of 3, right? And then the third term, we're going to have plus what? Plus minus square root of 3 plus square root of 4. Right, so that is the third term. And then plus all the terms in the middle until the last term. So for the last term, we have minus square root of 99 plus square root of 100. And now we're just one step away from getting our answer. So we have minus 1 here. And then here we have plus square root of 100. Those two numbers will remain as they are. But then all the numbers between those two numbers, they're gonna cancel out. Let me show you how. Here we have plus square root of 2. And here we have minus square root of 2. And then here we have plus square root of 3. Here we have minus square root of 3. Here we have plus square root of 4. So on the term that comes after this one, we're going to have minus square root of 4, right? Whatever you have is going to be subtracted by the term that follows. The only terms that are going to remain is minus 1 and plus square root of 100, right? There is no plus 1 that is going to cancel out the minus 1. And there is no minus square root of 100 that is going to cancel out plus square root of 100. All these terms will be equals to minus 1 plus square root of 100, right? All the terms in the middle are going to cancel out. And that is just minus 1 plus square root of 100, which is 10, right? So the answer to 1.3 without using a calculator is 9. How do you know whether a geometric series is convergent or divergent? If a geometric series is convergent, then the ratio should be between 1 and minus 1. That is how we're going to answer 2.1.1. The question is saying that, is this a convergent geometric series? Justify your answer with the necessary calculations. But we have our series right here. The first term is 1 divided by 5. The second term, 1 divided by 15. And then the third term, 1 divided by 45. So in order to find the common ratio, we say T2 divided by T1. You can also say T3 divided by T2. That will also work. So let's see what we get when we say T2 divided by T1. This will be equals to, so T2, 1 divided by 15. And then everything divided by T1, which is 1 divided by 5. This is equals to 1 divided by 3. And then as we all know, 1 divided by 3 is between minus 1 and 1. So we can conclude and say that this geometric series is indeed convergent, right? It is convergent because the common ratio is in between 1 and minus 1. 2.1.2. calculate the sum to infinity of this series. Let's go ahead and do that. The sum to infinity by definition is equals to a divided by 1 minus r. The question you might be asking yourself is, what is this a that we're talking about? It is the first term, which in our geometric series is 1 divided by 5. So we're going to have 1 divided by 5 divided by 1 minus the common ratio, which we know to be 1 divided by 3 at this point. So we're going to have 1 divided by 3. And then if you put that in your calculator, you should get 3 divided by 10. So this is the sum to infinity of our series. Now, moving on to the more interesting equation, 2.2 and 2.2.1. So an arithmetic and a geometric sequence are combined to form the pattern, which is given by Pn is equals to x, 1 divided by 3, 2x, and so on. The first question says that let's write down the next 2 terms of this pattern. So let's just copy it down first. The first term, that is x, and then we have 1 divided by 3, we have 2x, 1 divided by 9, 3x, and 1 divided by 27. So the first term is x, and then the third term is 2x, right? And then the fifth term is 3x. That is our arithmetic sequence. And then on the other hand, we have 1 divided by 3, and then 1 divided by 9, and 1 divided by 27. That is our geometric sequence. So the term that is coming next here in our sequence, it is the term in the arithmetic sequence, right? So after 3x, we should have 4x, right? So in this position here, we're going to have 4x. We're going to have 4x. And then after 4x, we're going to have a term in the geometric sequence, which will be 1 divided by 81. 2.2.2 determine the general term Tn for the odd terms of this pattern. Write down your answer in terms of x. So the odd terms is the arithmetic, right? So we know that we have Tn is equals to a plus n minus 1 multiplied by d. So let's go ahead and find the difference. That is T2 minus T1. And then in the arithmetic sequence, T1 is x, right? And then T2 is 2x. So we're going to have the difference being equals to 2x minus x, which is just equals to x, right? And then, so now we have D. What about A? A is the first term. That is x, right? So we can substitute in our equation. Tn is going to be equals to x plus n minus 1 multiplied by the difference, which is also x. So we're going to have x plus xn minus x, right? So Tn is just equals to xn. That is the general term for the odd terms of this pattern in terms of x. 2.2.3, calculate the value of P26. 26 is an even number, right? So we must go to our pattern now and see which sequence. Is it the arithmetic or is it the geometric that lies on the even numbers of our pattern? You can see that the arithmetic is on the odd positions, right? And then the geometric is on the even positions. So in position 26, we are going to have a term on the geometric sequence. Although the term is in position 26, in our geometric sequence, it will be in position 13 because the other 13 positions are filled out by the arithmetic sequence. Tn is equals to a r to the n minus 1. right? This is how you find the term on a geometric sequence. So A is the first term, obviously, that is 1 divided by 3. And then R is also 1 divided by 3, the common ratio which we calculated above, to the power n minus 1. So we're looking for position 26 on our sequence, which is position 13 on our geometric pattern. So we're going to have 13 minus 1. 1 divided by 1, 5, 9, 4, 3, 2, 3. The last question, 2.2.4, actually the difficult question. If the sum of Pn from n is equals to 1 to n is equals to 21 is equals to 33.5, determine the value of x. So you have to realize something here. You have to realize that the sum of Pn is equals to the sum of the even plus the sum of the odd. We know fully well that the terms on the odd positions are given by the arithmetic sequence, and the terms on the even positions are given by the geometric sequence. The sum is 33.5, which is equals to. Let me show you something first. We're looking for the sum of the first 21 terms. So in 21 terms, 10 terms will be even and 11 terms will be odd. The value of n here will be equals to 10, and the value of n here will be equals to 11 to ultimately give us 21, right? So let's just keep that in mind. So the sum of the even will be equals to, just a reminder, Sn is equals to a multiplied by r to the n minus 1 divided by r minus 1. This is for a geometric sequence, right, or geometric series, so to say. And then the sum for an arithmetic series, that is n divided by 2 multiplied by 2a plus n minus 1 multiplied by d. So let's just put this down here because we are going to use it, right? So the sum of the even, so the first term, that is 1 divided by 3, right? And then the ratio, we know that it is 1 divided by 3 also. And then to the power 10 minus 1 minus 1, right? Everything divided by r minus 1. So we have 1 divided by 3 minus 1 plus the sum of the odd. So let's just compute that real quick. So we're going to get 33.5 being equals to 0.5 plus the sum of the odd, right? So if you take 0.5 to the other side, you're going to get 33 being equals to the sum of the terms in the odd positions. We're going to have 33 being equals to n divided by 2, right? So that will be 11 divided by 2 multiplied by 2a. So we have 2. A is the first term, so that is x, and then plus n 11, right? Minus 1 multiplied by x again. So let's multiply out by 2 so that we can get rid of that denominator there. If we do that, we're going to have 66 being equals to 11 multiplied by 2x plus 11x minus x, right? So if we divide both sides by 11, we're going to get 6 being equals to 12x. So x is equals to 1 divided by 2. In order to answer this question, I actually had to go back and watch an introduction to quadratic sequences that I had made in the past, right? But then don't worry about it. I'm going to leave the link to that video in the description so that you can understand some of the things I'm going to be doing in this question, right? So it is saying that a quadratic sequence has the following properties. The second difference is 10. The first two terms are equal to each other, right? That is T1 is equals to T2. And then T1 plus T2 plus T3 will give you 28. Alright, and then the first equation, 3.1 is saying, let's show that the general term of the sequence is Tn is equals to 5n squared minus 15n plus 16. Right. So we're given the second difference. It is said to be equals to 10. Right. So that is a good start. Why am I saying that? We know fully well that 2a is equals to the second difference. 2a is equals to the second difference. Why is that important to us? Under normal circumstances, a quadratic sequence has the following format. Tn is equals to an squared plus bn plus c. So essentially what we're trying to do, we're trying to find the value of a, the value of b, and the value of c. If we do that, then we are supposed to have 5n squared minus 15n plus 16, right? So we have said that 2a is equals to the second difference. How much is the second difference? That is 10, right? So it should be easy to see here that a is equals to 5. And just like that, we already have 5, which is part of what we're trying to prove, right? So we are sort of convinced that we are on the correct route, right? And then the other thing we know about quadratic sequences is that 3a plus b is equals to t2 minus t1, right? And then we have established what a is equals to. So we have 3 multiplied by 5 plus b being equals to 0. Why are we saying t2 minus t1 is equals to 0? That is because we are told that t1 is equals to t2, right? So t2 minus t1 should be equals to 0. And then from there on, we're going to have b being equals to minus 15. We're just taking this term to the right hand side. And then that is exactly what we have in our equation, minus 15. So what is left? What more do we need to do? We just need to find the value of c, right? Which is going to be a bit tricky. But we're going to use the third bullet point that says t1 plus t2 plus t3 is equals to 28. So let's go ahead and see how we can do that. So we have t1 plus t2 plus t3 being equals to 28, right? So t1 of a quadratic sequence will be equals to a plus b plus c, right? That is t1. You can see why that is the case from the introduction video I'm talking about, which I'm going to leave in the comment, so you should probably watch it. And then plus t2. T2 is going to be 4a plus 2b plus c. If you cannot see what is going on, it's probably time you go and actually watch that video. And then t3, we're going to have 9a plus 3b plus c being equals to 28, right? So what is the value of a? A is 5. So we're going to have 5 plus b, which is minus 15, right? So we're going to have 5 minus 15 plus c, right? That is for t1. And then for t2, we're going to have a is 5. So 4 multiplied by 5, that is 20. And then b is minus 15, right? So 2 multiplied by minus 15, so 20 minus 30 plus c. And then plus, now we at t3, right? 9 multiplied by, so now we have 9 multiplied by a, which is equals to 5. So we're going to get 45. And then plus 3 multiplied by b, so that is 3 multiplied by minus 15, which is minus 45, right? And then plus c is equals to 28. So let's see, we have plus c plus c plus c. So we're supposed to have 3c. Now we just need to add all the other constants, right? And when we do that, we get minus 20, right? And this is equals to 28. So we're gonna have 3c being equals to 28 plus 20, which is 48. And then we divide by 3 on both sides to get C is equals to positive 16. Right, so we have deduced that A is equals to 5, B is equals to minus 15, and C is equals to 16, right? So we have Tn being equals to 5n squared minus 15n plus 16, which is what we are required to prove. So we're good to go now. Let's do 3.2. So 3.2, the question is saying that is 216 a term in this sequence? Justify your answer with the necessary calculations. Right, so again, we know that Tn is equals to 5n squared minus 15n plus 16. Let's see if 216 is a term in this sequence. So in place of Tn, we're going to put 216. This will be equals to 5n squared minus 15n plus 16. Right, so if we can solve here and get a value of n, which is the whole number, then 216 is a term in this sequence. Right, so if we take 216 to the other side, we're going to have 5n squared minus 15n, not 18n, minus 15n, then plus 16 minus 216. That will be minus 200 being equals to 0. Right? It's easy to see here that we can take a common factor of 5 real quick and then divide both sides by 5 to get n squared minus 3n minus 50 being equals to 0. Right, so let's go ahead and try and factorize this. So we're going to have n, another bracket, we have n being equals to 0. We are not able to factorize this without using the quadratic formula. And as a consequence, 216 is not a term in this sequence. Is P an increasing or decreasing function? So that is 4.1.1, right? We have P of x, which is equals to 1 divided by 3 to the power x. So let's go ahead and find out whether this function is increasing or decreasing. How are we going to possibly do that? Let's start by substituting x is equals to 1 and see what we get. So if you substitute x is equals to 1 into P of x, you're going to get 1 divided by 3, right? And then if you substitute x is equals to 2, you're going to get P of 2 being equals to 1 divided by 9. And then if you substitute x is equals to 3, you're going to get P of 3 being equals to 1 divided by 27. Now it's actually easy to see that when the values of x are increasing, the values of y are decreasing, right? When x is equals to 1, we have 1 divided by 3. When x is equals to 2, we have 1 divided by 9. And then when x is equals to 3, we have 1 divided by 27. We can see from that test that our function is decreasing, right? Yeah, as the values of x increase, the values of y decrease. And then 4.1.2, determine P inverse, the inverse of P in the form y is equals to. So we have P of x being equals to 1 divided by 3 to the power of x. Instead of P of x, let's just put y in there. So we have y being equals to 1 divided by 3 to the power x. So when you want to find the inverse, the first thing you want to do is to swap x and y, right? So if we go ahead and do that, we're going to have x in place of y, right? And then in place of x, we now put y, right? And then from there on, all you just need to do is solve for y. Solve for y. As soon as you solve for y, then you're going to have the function you're looking for. So how are we going to possibly do that, right? Y is up here. We have to bring it down. by introducing log on both sides, right? So we're gonna have log of x being equals to log of 1 divided by 3 to the y. Now you just have to recall that under log loss, log of a to the b is equals to b multiplied by log of a. So if we just apply that idea right here, we're gonna have log of x being equals to y log of 1 divided by 3. So we can go ahead and divide both sides by log of 1 divided by 3 in attempt to isolate y, right? And then if we do that, we're going to end up having y is equals to log of x base 1 divided by 3. And that is the inverse of p of x. The following equation 4.1.3, let's write down the domain of p inverse. What I want you to know is that the domain of f inverse is equals to the range of f, right? So we're looking for the domain of p inverse. So actually we can find the domain of p inverse by just finding the range of p, right? And then for our function p of x is equals to 1 divided by 3 to the x. You can see that the range is going to be y is greater than 0. We are saying that to say that the domain of p inverse will be, so now we have the domain x is greater than 0, right? And then the last equation 4.1.4, write down the equation of the asymptote of p of x minus 5. So for any exponential function in the form a b to the x plus q, this q here will always be your asymptote, right? So let's go ahead and see what we're going to have for p of x minus 5. This will be equals to 1 divided by 3 to the power x minus 5. It's easy to see that in this function, our q is actually minus 5. So our asymptote is that y is equals to minus 5. Given that f of x is equals to 4 divided by x minus 1 plus 2, write down the equations of the asymptotes of f. That is 4.2.1. So you can see just from how the function looks that we have a hyperbola, right? One of the asymptotes will be at y is equals to 2, this value here, right? So we're going to have our horizontal asymptote. So we have our horizontal asymptote being at y is equals to 2. Now what we need is our vertical asymptote. Our vertical asymptote will be at this denominator equals to 0, right? Because we know that we cannot divide by 0. So if you equate the denominator to 0, you're going to find an x value for which the graph never touches, right? So if we go ahead and do that, we're going to have x minus 1 is equals to 0, and then x is simply equals to 1, right? That is easy to see. So we have our horizontal asymptote and we have our vertical asymptote. That is 4.2.1, right? The value that is in here, this value right here, will always be your horizontal asymptote. If it was minus 3, then our horizontal asymptote will be minus 3, right? That's how it works. And then now moving to 4.2.2, the equation is saying that let's calculate the x-intercept of f. We're looking for the x-intercept of f. As soon as I hear x-intercept, so we have x-intercept, I'm thinking y is equals to 0, right? So if we let y be equals to 0 in our function, we're going to have 0 being equals to 4 divided by x minus 1 plus 2. What we want to do when we have something like this is to subtract 2 from both sides, right? To get minus 2 is equals to 4 divided by x minus 1. And then if we cross multiply, we're going to get minus 2x plus 2 is equals to 4. Minus 2x will be equals to 2, and then x will be equals to minus 1. So the coordinate for our x-intercept, right, we have minus 1 and 0, right? And then now 4.2.3, we are required to sketch the graph of f and label all asymptotes and indicate the intercepts with the x's. So in 4.2.2, we only calculated the x-intercept, but then now we are required to indicate their intercepts, right? So we need to find the y-intercept. So y-intercept x is equals to 0. So let's go ahead and find the y-intercept so that we can be able to sketch our graph and indicate all that we are required to, right? So we're going to have y being equals to 4 divided by, now x is 0, right? Minus 1 plus 2. So we're going to have 4 divided by minus 1 plus 2. This is minus 4 plus 2. This is equals to minus 2, right? So the coordinate for our y-intercept, we have x being equals to 0 and y being minus 2. Right, so now we have the asymptotes, we have the intercepts, we can sketch our graph. Let's go ahead and do that. So we need our x's, obviously, right? We cannot have it any other way. So there goes our y-axis and there goes our x-axis. So the first thing we want to do is to put our asymptotes first, right? So let's just say this is 1, 2, 3. And then this can be minus 1, minus 2, minus 3. And then again for the y-axis, 1, 2, 3, minus 1, minus 2, and minus 3. So right, so let's go ahead and put our asymptotes in our graph, right? We have a horizontal asymptote at y is equals to 2. So let's just go ahead and have that there. So there goes our horizontal asymptote. And then our vertical asymptote is at x is equals to 1, right? So let's do likewise. There goes our vertical asymptote. Right, now we just need to indicate the intercepts. We have one intercept at minus 1 and 0, right? The x-intercept. So we're going to have a coordinate right here at minus 1 and 0. And then the other one is at 0 and minus 2. So we have another intercept here. And just like that, we're almost done. We just need to sketch our function, right? If we go ahead and do that, we should have something like this. So our graph should go through our intercepts, obviously, right? And then, yeah, that is one part of our function. And the other part of our function will lie in the first quadrant, right? Right, there we go. We're supposed to have something like that. We've indicated our asymptotes, we've indicated our intercepts. I think we're good to go, right? Let's do 2.4. So 2.4, using the using our graph, let's determine the values of x for which 4 divided by x minus 1 is greater or equals to minus 2, right? If we take minus 2 to the other side, we're going to have 4 divided by x minus 1 plus 2 is greater or equals to 0, right? So what we're actually looking for here, we're looking for the values of x for which our function f of x is greater or equals to 0, right? Because this is simply f of x if you look at it. Right, so let's go to our function and look for the values of x for which our function is greater than or equals to 0, right? We can see that for this entire part of the function, it is greater than 0, right? And then here from minus 1, if we go to that side, our function will be greater than 0, right? So part of our solution, we have x being greater than 1, right? When x is greater than 1, our function is clearly greater than 0, right? And then when x is less or equals to minus 1, our function is also greater than, it's greater than 0. It's greater than 0. It's greater or equals to. So here we can put in this equals to, right? It's not going to cause us any issues because our function is defined at x is equals to minus 1. But then here we cannot have an equals to because our function is not defined when x is equals to 1, right? So we're supposed to say x greater than 1, right? And then the last question, 4.2.5. Let's determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient. So what is this f of x minus 2? Let's figure it out. So we know that f of x is equals to 4 divided by x minus 1 plus 2. So f of x minus 2. So in place of x, we now gonna have x minus 2 and then minus 1 plus 2. Right, and then this will be equals to 4 divided by x minus 3 plus 2. Right, so this is what they're talking about when they say f of x minus 2. So we need the equation of the axis of symmetry that has a negative gradient. So we have two axes of symmetry, one with a negative gradient and then one with a positive gradient. So the one with the negative gradient, y is equals to minus x plus c, negative gradient. And then the one with the positive gradient, we have y is equals to x plus c. So what you're required to do actually is to just find the value of c, right? And then you have your axis of symmetry. So which point did you substitute if you want to find the value of c in your axis of symmetry? You substitute the point where your asymptote starts. So now we actually have to find the asymptote of f of x minus 2. Let's go ahead and do that. We know that 2 will be our horizontal asymptote. Now we just need to find our vertical asymptote by saying that x minus 3 is equals to 0, right? Now you're going to see that x is equals to 3 is our vertical asymptote. So they're going to touch when x is equals to 3 and y is equals to 2. Now we just need to substitute that in our equation for the axis of symmetry with the negative gradient, right? So if we go ahead and do that, y is 2, right? And then minus x is 3 plus c, right? So if we take minus 3 to the other side, the way you would say it, we would have 5 is equals to c, right? And then now we have y is equals to minus x plus 5 being the equation of our axis of symmetry of f of x minus 2. Write down the coordinates of the turning point of f. So f of x is equals to minus x plus 3 to the power 2 plus 4, right? So the coordinates of the turning point of this function will be minus 3 and 4, right? We can clearly see that in our equation. But then for most people, it's a bit confusing when the equation is like this. They like to solve it first and then use x is equals to minus b divided by 2a. So if we do that, we're going to have f of x being equals to minus x squared plus 6x plus 9. That's what you get when you solve x plus 3 to the power 2 and then plus 4, right? So we're going to have minus x squared minus 6x minus 9 plus 4. So this is equals to minus x squared minus 6x minus 5, right? If you say x is equals to minus b divided by 2a, you're going to get minus 6 divided by 2 minus 1, right? Which is equals to minus 3. And then if you substitute minus 3 into f of x, you're going to get 4.
So indeed, the coordinates of our turning point, we have minus 3 and 4, right? But this is the equation of f of x, right? We're gonna need this equation as time goes, so let's just keep it there because we're gonna need it soon, right? And then 5.2, write down the range of f. So let's look at our function here. So we've already established that the y value here at the turning point is 4, right? And we can see that our graph never goes above 4. It just touches there at 4 and then it goes infinitely down, so to say, right? So we can say that y is less or equals to 4, right? For all the values of x, y is either 4 or less than that. All right, so that is the range of our function f. And then 5.3, this is where things start to get interesting. Show that the x coordinates of a and b are minus 5 and 2. So we say that f of x is equals to, so we have our function here, minus x squared minus 6x minus 5, right? So if we want to find the x coordinate of a and b, what we have to do is equate f of x, our parabola, right, and g of x, our straight line. So the equation of our straight line, we have g of x is equals to x plus 5. So if we equate those two, we're gonna get minus x squared minus 6x minus 5 is equals to x plus 5. Right, so we're gonna have minus x squared. We take in x to the left hand side, we're gonna get minus 5x, and then plus 5 is gonna be minus 5, right? So we have not minus 5 but minus 7, right? So we're gonna have minus 7x, and then minus 10 is equals to 0, right? Just one mistake and you're gone, right? So I have minus x squared here, which is, confusing me a bit. So I'm just going to multiply everything by minus 1, right? So that I can have x squared plus 7x plus 10 is equals to 0. Now it looks clean. I can go ahead and factorize. So I'm going to have that there. And then now the equation I'm asking myself, which two numbers do I multiply and get 10? And then when I add, I get plus 7. That is 5 and 2. So I'm going to have x plus 5 and x plus 2. So it's easy to see now that x is equal to minus 5 or x is equal to minus 2. And then this is the x value of a and this is the x value of b. It's quite straightforward. There isn't really anything complicated in this one, right? Unlike 5.4 and 5.5. So let's look at 5.5. So 5.5 is saying that hence determine the values of c for which minus x plus c plus 3 squared plus 4 is equals to x plus c plus 5 has one negative and one positive root. At this point, our roots are at, let me just change the color real quick, at minus 5 and minus 2, right? That's where our roots are at the moment, based on 5.4. So now we need to shift our graph. Let's not forget that x plus something is shifting our graph, right? So let's shift our graph such that now one root is negative and then another root is positive, right? So if we have minus 2 here at b, we need to shift our graph just above 2 units to the right, just above 2 units to the right. Then one root is going to be slightly greater than 0 and the other one is still going to be less than 0, right? So that's what we want to do. So another thing to remember here is that if you have x plus 2, you are shifting your graph 2 units to the left,
right? You're shifting your graph 2 units to the left. But then if you have x minus 2, you're shifting it 2 units to the right. I know it's counterintuitive that the plus is to the left and minus to the right in this case, but that's what it is, right? So we need c to be just slightly greater than minus 2 so that we can shift our graph just more than 2 units to the right. So if c is just slightly greater than minus 2, then our problem is solved. We're gonna have one negative and one positive root. Right. I'm interested in how you guys interpreted this equation. Can you please just let me know in the comments if you don't mind? I would really appreciate that. Right. 5.6. 5.6 is saying that the maximum distance between f and g in the interval x of a and x of b. So yeah, in this interval, let me just erase this so that we can have a bit of clarity. Right, let me just put that there real quick. Right, so this is the interval we're interested in. This is the interval we are interested in. Right, so the question is saying the maximum distance between f and g in that interval is k, the maximum distance. If h of x is equals to g of x plus k, determine the equation of h in the form h is equals to. So we already have g of x, right? So to determine the equation of h of x, we just need the value of k. And then we are told that k is the maximum distance between f and g in that interval, right? So let's just go ahead and try find the maximum distance between f and g in that interval, right? So how do you find maximum distance? You say the graph on top minus the graph at the bottom is equals to 0, right? And then after that, you're going to derivate the result and equate to 0. Let me show you what I'm talking about before I just confuse you. So we have f of x minus g of x, right? That is how you find the equation for the distance between the two graphs. So f of x minus g of x will be equals to, what's our equation for f of x again? Where is it? Here it is. So we have minus x squared minus 6x minus 5. And then we're subtracting g of x, which is x plus 5, right? We're trying to find an equation for the distance between the two graphs, right? So we're gonna have minus x squared minus 7x minus 10. So this is the equation for the distance between the two graphs. So if we want to find the maximum distance, we have to derivate this equation and equate it to 0, right? So if we say distance, the derivative of the function for the distance is equals to 0, then we're gonna have minus 2x. We can just use the power rule, right? Minus 7 is equals to 0. So we're gonna have minus 2x being equals to 7, right? So x is clearly equals to minus 7 divided by 2. So let me just put minus 7 divided by 2 in the calculator. It's minus 3.5, right? And minus 3.5 is between minus 5 and minus 2. So right, that is the x value for which the distance between the two functions is at a maximum, right? Now we just need to find the distance by equating this answer into this equation, right? And then that will be the value of k, and we're gonna consequently have the function h of x. So if we sub x into that equation, we're gonna have minus 7 divided by 2 squared minus 7 divided by 2 minus 10, right? So that is our maximum distance. So let me just put that in my calculator and see what I'm getting. So minus 10, and I'm getting 2.25. I'm getting 2.25 units, right? So the value of k is 2.25 based on what I'm proposing here. So now we can go ahead and say that each of x is equals to g of x, which is x plus 5, and then plus k, which is 2.25, right? So we have x, and then what's 5 plus 2.25? That is plus 7.25. What I usually do before using first principles is using the power rule, so that when I get my answer after using the first principles, I can see if my answer is correct or not. So what do we have here? We have f of x, which is equals to minus 2x squared minus 1. So if we derivate this using the power rule, right, we're going to get minus 4x, right? So now we can go ahead and use the first principle. We are doing 7.1, by the way. And then if we don't get minus 4x as our final answer, we know that we've made a mistake somewhere. So let's go ahead and solve this question so that we can see what we have here. 7.1, so we're going to say f prime of x is equals to the limit as h tends to 0 of f of x plus h minus f of x, everything divided by h, right? So this will be equals to the limit as h turns into 0, and then here we have f of x plus h, right? So we're writing the equation of f of x, but then everywhere where we have x, we put x plus h instead. It's that simple. Let me show you how it will look like. So we have minus 2x squared. So instead of x, we're going to put x plus h, right? And then we square that, and then we have our minus 1 right there. So we are done with the first part. And then the second part, we're just subtracting f of x as it is, right? So if we do that, we're going to have minus 2x squared minus 1. And then we're going to divide everything by h. This is how you do derivation using the first principle. Now we just have to do a bit of algebra. Let's go ahead and do that. So we're going to have the limit as h tends to 0 of, so we have minus 2, and then x multiplied by x, that is x squared. X multiplied by h is xh. You multiply that by 2, you get plus 2xh, and then h multiplied by h, that's h squared, right? And then we have minus 1, and then minus multiplied by minus, that will give us plus 2x squared, and then minus multiplied by minus again, that will give us plus 1, and then everything divided by h, right? We still have our limit as h tends to 0, right? So now we just multiplying out by minus 2, right? Let's go ahead and do that. We're gonna have minus 2x squared minus 4xh minus 2h squared, and then minus 1. Let's not forget this minus 1, which is out here, and then plus 2x squared plus 1. We're dividing everything by h. Now I want to show you something. We have minus 2x squared here plus 2x squared, and then we have minus 1 plus 1. So we're only left with minus 4xh and minus 2h squared. So we're going to have the limit as h tends to 0 of minus 4xh minus 2h squared divided by h. So the limit as h tends to 0. So let's take h as a common factor in the numerator. If we do that, we're going to have f h, not f, and then multiply by minus 4x minus 2h divided by h. H and h cancel out. Now we have minus 4x minus 2, h is turning to 0, right? So this is just minus 4x. And then you can see now that we have the same answer when we use the first principle and when we use the power rule. So now we are convinced that what we did is correct. Right, 7.2. The interesting question here is 7.3. That's the interesting question. Let's just do 7.2 first, and then we're going to move to that. 7.2.1. We have f of x, which is equals to minus 2x to the 3 plus 3x squared. We want the derivative using, we're not told what to use, right? So we can just use the power rule, the faster method, right? So if we say f prime of x, we're gonna get, so the base, not the base, but the exponent, multiply the base, and then we subtract 1, right? So minus 2 multiplied by 3, that will be minus 6, and then x to the power 3 minus 1, which is 2. Then the same thing, 2 multiplied 3, we get 6, and then x, we subtract 1 from the power. So we just have x to the power of 1. Right, so that is our answer for 7.2.1, minus 6x squared plus 6x. Right, that checks out. Let's do 7.2.2. So here we're looking for dy over dx when y is equals to 2x plus 1 divided by square root of 4x. Right, so we're still trying to derivate here, but then you see we have an issue. We cannot really use a power rule when it's like this. It's a bit confusing, you know. So let me make it linear and get rid of the square root so that I can easily use the power rule. It's a bit confusing for me. I don't know about you. Right, so if we do that, we're gonna get 2x plus, and then instead of writing it as 1 divided by square root of 4x, I'm gonna write it as square root of 4x everything to the power minus 1. It is the same thing, right? And then when I have 2x plus, so instead of writing square root of 4x, I'm gonna write 4x to the power a half. That's the same thing as having the square root, right? And then this is all to the power minus 1. So 2x plus, and then we're gonna have a half multiplied by minus 1, right? So that will be 4x to the power minus a half. So if we solve that, we're gonna get 2x and then 4x to the power minus a half. So we have 4 to the power minus a half. I'm getting 1 divided by 2. So I have plus 1 divided by 2, and then x to the power minus 1 divided by 2. Right, so now we can then use the power rule. Yeah, we can only use the power rule at this point. If we use the power rule for 2x, we're just going to be left with 2. And then now we multiply the coefficient by the exponent. We're going to get minus 1 divided by 4x, and then we're supposed to subtract 1 here. If we do that, we're going to get minus 3 divided by 2. And this is almost our final answer. It's not, right? We have to get rid of this minus 3 divided by 2. Yeah, we have to get rid of that. You know, when we found our equation, it didn't have any minus exponent. So let's be kind and take it back to the form found it in, right? So if we do that, we're gonna have 2, and then we can have minus 1 divided by 4, and then x to the power 3 divided by 2. Right, we are allowed to say that. Now it looks a whole lot better, right? 7.3 is saying that the graph of y is equals to f prime of x has the minimum turning point at 1 for the x value and minus 3 for the y value. Determine the values of x for which f is concave down. Right, so to find the values of x for which a function is concave up or concave down, we have to look for the point of inflection, right? So if we have f of x and your graph is cubic, when you find f prime of x, your graph is parabolic. Right, and then at the turning point of that parabolic function, that's where you have your point of inflection. And then here we given the x value at the turning point. You can see right here we given the x value at the turning point. It is said to be equals to 1. Right, so now the question I'm asking you, is our answer supposed to be x greater than 1 or x less than 1? Can you please just let me know in the comments and why you're saying so? Write down the y-intercept of f. Right, so as soon as I hear y-intercept, I'm thinking x is equals to 0. Right, so let's go ahead and substitute x is equals to 0 into f of x. So if you substitute 0 into f of x, you're gonna get 0 to the 3 plus 4 multiplied by 0 to the 2 minus 7 multiplied by 0 minus 10. It's easy here to see that your answer is going to be equals to minus 10. Right, so that is the y-intercept of f. Y is equals to minus 10. Right, we have some coordinate of which the x is 0 and the y is minus 10. Right, that is 8.1. Let's go ahead and do 8.2. So in 8.2, we are required to show that 2 is a root of the equation f of x. Right, if 2 is indeed the root of the equation f of x, then when we substitute 2 into f of x, we shall get f of x is equals to 0. Right, so let's go ahead and see if that checks out. Right, so we're gonna have f of 2 is equals to 2 to the power 3. The question is saying that let's show that. So we already know that it is supposed to be true, right? But then we still need to write it down so that we can actually show that. And then plus 4 multiplied by 2 to the power 2 minus 7 multiplied by 2 minus 10. Right, and then if you put that in your calculator, you should get f when x is equals to 2 will give you 0. Right, so that is the root of our equation f of x. Right, moving to 8.3. 8.3 is saying that let's hence factorize f of x completely. Right, so we're gonna have something that looks like the following: f of x is equals to x, and then we know that 2 is a root of our equation, right? So we're gonna have x minus 2 multiplied by some function here, right? We're supposed to multiply x minus 2 by a quadratic function, right? So let me show you something. Here we have x to the power 3, right? We already have x here, so it would make sense to say that we need x to the power of 2 there, so that when x multiplies x to the power of 2, we're gonna have x to the power of 3. Now let me show you something. Also, we have minus 2 here, and then in our function we have minus 10. So what do you need to multiply minus 2 with so that you can get minus 10? That is plus 5. So we have plus 5 right there. Right, now we just need the middle term of our quadratic function. Right, let me show you how we're gonna get that. So when we multiply minus 2 by x squared, right, we're gonna get minus 2x squared. But then in our equation here we have plus 4x squared. You can see that we have plus 4x squared here, right? So we need to add something into minus 2x squared such that we get 4x squared. What do we need to add there? It's easy to see that you need to add 6x squared, right, so that you can get 4x squared. Right, so here we're gonna have plus 6x, not plus 6x squared, plus 6x. We're gonna get 6x squared from multiplying x and 6x. Right, so this is how you can factorize a cubic function. But then our question is very specific. It says that we need to factorize it completely, right? So we also need to now come and factorize that function that we have there, right? So f of x will be equals to x minus 2 multiplied by, we can open two brackets now. So when we factorize in a function like this, we're looking for two numbers that when we multiply we get 5, and then when we add we get 6. That is easy to see, right? That will be plus 5 and plus 1. So we're gonna have x plus 5 multiplied by x plus 1, and just like that we have factorized our cubic function completely, right? Let's move to 8.4. Let's move to 8.4. It is if it is further given that the coordinates of the turning points are approximately at this coordinate here and this coordinate here, draw a sketch graph of f and label all the intercepts and turning points, right? So when we factorize, we end up with our x-intercept, right? X is equals to 2, x is equals to minus 5, and x is equals to minus 1. And we know the y-intercept from 8.1. So the intercepts, we have those covered. And then we are given the turning points, right? So we have all we need. We just need to sketch our function. So let's go ahead and do that, right? So let's, let me draw the set of x's. So we can have our x here, and we can have our y here, right? Let's see what we get. So let's start with the y-intercept. We know that it is at minus 10. So we are interested at this point. Let me just take it a bit down. So we have minus 10 here, and then let's go to the x-intercept. We have one at minus 5, and then we have another one at minus 1, and we have another one at 2, right? So those are our intercepts. Now we need the turning points. We have this first one here, which says 0.7 and minus 12.6, right? So let's have minus 12.6 here, and then 0.7. We can put it somewhere here, right? That makes sense. And then minus 3.4 supposed to be between minus 5 and minus 1, right? And then this one, it has a y coordinate of 20.8. So let's have 20.8 here. Yeah, so this is a coordinate. This is a coordinate. And then 0.7 and 12.6, we have another coordinate there. So now we need to go ahead and sketch our cubic function, right? As you can see here, we have x to the power 3, right? So our graph should start being concave down until it changes concavity and becomes a concave up, right? So let me sketch that so that you can see what I'm talking about. So our turning point is here. We have one turning point here, right? And then we need an intercept there, and then another intercept is here. From here we need to go to minus 10, right? And then 10 at minus 12.6, and then go up and go through x is equals to 2, right? So our function is supposed to look like that. That is how our function is supposed to look like. So we have the y-axis here, and then we have the x-axis here. So right, that is 8.1. I'm pretty much sure we got the same thing. And 8.5.1. Let's determine the values of x for which f prime of x is less than 0, right? So what is f prime of x? F prime of x is the gradient of our function, right? So we need to find the values for which our gradient is negative. The gradient is a negative when our graph is sloping down, right? So we can see that it is sloping down in between our turning points. Right here, that is where, let me just use a different color. So right here, this is where our graph is sloping down, right? So f prime of x is less than 0 in that interval. So when x is between what 0.7 and minus 3.4, yeah, that is where our gradient is negative, right? The last question, 8.5.3, we're looking for values of x for which f prime of x multiplied by f, and then the prime of x, or the second derivative of our equation, is less or equals to 0. I'm very much interested in how you guys solved this question. Can you please just let me know in the comments. A wire 12 meters long is cut into 2 pieces. One part is bent to form an equilateral triangle and the other a square. A side of the triangle has a length of 2x meters. Right, so that is the information we have. Let's go ahead and conceptualize so that we can have a bit of clarity. Right, so let's start with the equilateral triangle, right? So let's say our triangle looks something like this, right? And then if this triangle is indeed equilateral, then all the 3 sides should be equal to each other, right? And then we are given the side of the triangle is said to be 2x meters, right? So now we can say that this side here is 2x, this side is also 2x, and this side is also 2x, right? So if you add up all those sizes, you're gonna get 6x, right? That is the amount of wire used to make the triangle, right? And then now from the piece of wire that is remaining, or the other piece, it is used to form a square, right? So let's go ahead and have a square. So from the 12 meters, we have already lost 6x meters, right? So we can say 12 minus 6x. So this is the amount of wire that is used to construct the square. Now we can clearly say that one side of the square will be 12 minus 6x divided by 4. The other one will be 12 minus 6x divided by 4. 12 minus 6x divided by 4. And lastly, 12 minus 6x divided by 4. If you add all those, you get 12 minus 6x. Right, so now we have a bit of clarity. We can finally start answering our questions. So let's look at 9.1. So 9.1 is saying that let's write down the length of a side of the square in terms of x. Right, so we have already deduced that the length of the sides of the square will be 12 minus 6x divided by 4. Right, so that is 9.1. And now the interesting question, 9.2. It is saying that if this square is now used as the base of a rectangular prism with a height of 4x meters, determine the maximum volume of the rectangular prism. Right, so let me just sketch a rectangular prism first before we go on and solve this problem. So at the base we have the square, right? So we need a square at the base, right? And then we have our heights there, and then yeah, another square at the top, right? So the size of the square, we know fully well that we have 12 minus 6x divided by 4. Then the other side should also be 12 minus 6x divided by 4. And then the height is said to be 4x. Right, so the question is asking us to determine the maximum volume of the rectangular prism. So what are we going to do here? So what we're going to do, we're going to determine the volume of the rectangular prism. And then after determining the volume of the rectangular prism, it's going to be in terms of x, right? Because we have a variable. We're going to derivate this volume. And then when we derivate it, we're going to find the maximum and the minimum. And then we're going to take the maximum as the maximum volume of our rectangular prism. Let me show you what I'm talking about. So we're going to say that the volume is equals to the length multiplied by the width multiplied by the height. So this will be equals to, so the length we can clearly see here is 12 minus 6x divided by 4. So we're gonna have 12 minus 6x divided by 4 multiplied by the width, which is also 12 minus 6x divided by 4 multiplied by the height, which is 4x. Right, and now we have 12 minus 6x divided by 4 multiplied by 12 minus 6x divided by 4. That is just 12 minus 6x divided by 4, everything to the power 2 multiplied by 4x. Right, so this will be equals to, so if we have a divided by b, everything to the power 2, this is the same as a to the power 2 divided by b to the power 2, right? Grade 8 mathematics. So right, if we apply that there, we're gonna have, so let's start with the easy one. Let's start with 4 squared. 4 squared will give you 16. Now we can come to the numerator. In the numerator, we're gonna say 12 multiplied by 12. That will give us 144. And then we say 12 multiplied by minus 6x, that will give us minus 72x. You multiply that by 2 and you get minus 144x. And then plus minus 6x multiplied by minus 6x, that will be 36x squared, everything multiplied by 4x. Right, so what you can do here, you can actually solve this by taking the long route, right? Literally multiplying out the brackets. Yeah, but then, yeah, my method is a bit advanced now. I know how to do it without having to do that. Right, let's move forward and see what we have. So we can go ahead and multiply the entire numerator by 4x, right? Let's not forget that we have 4x there. So let's try multiply everything and see what we're gonna get. So if we see 144 multiplied by 4x, we're gonna get 576x minus, so that will also be 576, but then now we have x squared, right? And then plus 36 multiplied by 4, that is 144 x to the power 3, right? And then we're dividing everything by 16. If we go ahead and divide everything by 16, we're gonna get 576 divided by 16, which is equals to 36 x minus 36x squared in these in the middle term, right? And then the last term we have 144 divided by 36. Oh, not 36, but 16 divided by 16. That will be plus 9x to the power 3. Right. So this is our volume. Right. So what we need to do now is to derivate this and equate to 0. Right. So if we go ahead and derivate the volume, we're gonna get 9 multiplied by 3, which is, yeah, let me not start by derivation from this side. Let me start from this side. It's fine. I was starting from the other side. So if we derivate 36x, we're going to get 36. And then if we derivate 36x squared, we're going to get 72x. And then 9 multiplied by 3, we're derivating 9x to the power 3. We're going to get 27x squared. Right, so now we can equate that to 0, right? Let me write it nicely. So we're gonna have 27x squared minus 72x plus 36 is equals to 0. If we take 9 as a common factor, we're gonna have 3x squared minus 8x plus 4 is equals to 0, right? So we can divide both sides by 9 and just get 3x squared minus 8x plus 4 is equals to 0. Right, so now we just need the x values for this quadratic function. Right, it's a bit difficult for me to factorize it when it looks like this. I always resort to using the quadratic formula. So if I do that, I'm going to add x is equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a, right? So minus 8 plus or minus, so I have b squared, that is minus 8 squared, minus 4ac. A is 3, c is 4. And then everything divided by 2 multiplied by 3, right? So let me just put this in my calculator real quick. So minus 8 squared minus 4 multiplied by 3 multiplied by 4. Everything divided by 2 multiplied by 3. So I'm getting x is equals to 2 or x is equals to. So let me find out what the other value of x is. The other value of x is 2 divided by 3, right? So one between these two values is supposed to be a maximum and the other one is supposed to be a minimum. And we're looking for the maximum. So let's go ahead and substitute x is equals to 2 and x is equals to 2 divided by 3 in our equation for the volume and see what we're going to get, right? So the equation for the volume is right here. This is where we have the equation for our volume. So when we sub x is equals to 2, let's see what we're going to have. So the volume is going to be equals to, let me just put that in my calculator real quick and see what I have. 9, right? I'm getting 0 actually when I substitute x is equals to 2. Right, let me substitute x is equals to 2 divided by 3 and see what I get. So now I just need to divide all the 2's by 3. And I'm getting 10. I'm getting a volume of 10.6667 meters. Is it meters?
This equation is only true when x is equals to 0 or 7 minus x is equals to 0. So what we need to say here is that x is equals to 0 or 7 minus x is equals to 0. And then if 7 minus x is equals to 0, then x is equals to 7. This is the answer to 1.1.1. That's all we are supposed to do. And 1.1.2 on the other hand, we have a quadratic equation, 3x squared minus 2x minus 6 is equals to 0. We're supposed to find the value of x correct to 2 decimal places. So as soon as we see correct to 2 decimal places, we know we're going to use the quadratic formula. So that is x is equals to minus b, which is minus 2, plus or minus the square root of b squared. So we have minus 2 squared minus 4ac. The value of a is 3 and the value of c is minus 6. And we are dividing everything by 2a, which happens to be 3. So if you put that in your calculator, you're going to get x is equals to minus 1.12 or x is equals to 1.79. That is the values of x correct to 2 decimal places. 1.1.3 is quite an interesting one. We have 3 minus x multiplied by x plus 7 being less than 0. This inequality is already factorized, so we don't have to do much here. We can go straight to the critical values. We can say that 3 minus x is equals to 0 or x plus 7 is equals to 0. And then here we're going to have minus x being equals to minus 3. So x is equals to 3. And on the other side, we're going to have x being equals to minus 7. And just like that, we have our critical values, 3 and minus 7. So let's see if x lies between 3 and minus 7. If it doesn't lie between 3 and minus 7, then it will lie outside. So how do we then test if it lies between minus 7 and 3? We take a number that is between minus 7 and 3 and substitute it in our inequality. If our inequality holds, then we know that our solutions lie in that range. So between minus 7 and 3, let's take 0. So we're substituting it here. we're going to have 3 multiplied by 7 being less than 0. So 21 is not less than 0. So we can see that our solution is not between -7 and 3. So it must be outside that range. What do I mean by that? X needs to be greater than 3, or X needs to be less than -7. For these values of X, our equation, our inequality is going to hold. Let's move to 1.1.4. We have the cube root of 32 being equals to 8 to the power 3x multiplied by 2 to the power 6x. So when you have an equation like this, the first thing you should be looking at is writing all the numbers with the same base. We have 2, 8, and 32. If we want to write those numbers with the same base, then the number to go for is 2. Let me show you how. Here we're going to have 3, and then the root of 2 to the power 5. 32 is just 2 to the power 5. Being equals 2, instead of 8, we're going to have 2 to the power 3 multiplied by 2 to the power 6x. So on the left hand side, we're going to have 2 to the power 5 divided by 3 being equals to 2 to the power 3 multiplied by 3x, that is 9x, multiplied by 2 to the power 6x. So 2 to the power 5 divided by 3 is equals to 2. Same basis, we can just add the exponents, 15x. So obviously, we're going to drop the basis and equate the exponents. 5 divided by 3 is equals to 15x. So x will be equals to 5 divided by 3 divided by 15. So the value of x here in 1.1.4 is 1 divided by 9. And just like that, we have the answer to 1.1.4. 1.1.5, let's take a look at this one. We have x minus 4 minus 2 square root of x minus 1 being equals to 0. Let's take these to the right hand side. We're going to have x minus 4 being equals to 2 square root of x minus 1. And then because we have this square root, it's better we square both sides. So on the left hand side, we're going to have x minus 4 squared. And then on the right hand side, we're going to have 4 multiplied by x minus 1. And then let's solve the left hand side. That will give us 8 squared minus 8x plus 16 being equals to 4x minus 4. So x squared minus 8x minus 4x, that is minus 12x, and then 16 plus 4, that is plus 20 being equals to 0. Factors of 20 that when we add, we get minus 12. That is minus 10 and minus 2. So we're going to have x minus 10 multiplied by x minus 2 being equals to 0. It should be easy to see now that x can be equals to 10 or x can be equals to 2. But we need to check here whether all this solution holds. Why am I saying that? We had a square root initially here, and then we squared both sides. So that introduces solutions that might not be necessarily true on the original equation. If we substitute 10, we're going to have 10 minus 4 minus 2 square root of 10 minus 1. So that is 9. So this is 10 minus 4, which is 6, and then minus 2 multiplied by 3. This is equals to 0. So 10 holds. Let's see if 2 is also going to hold. If we substitute 2, we're going to have 2 minus 4 minus 2 multiplied by 2 minus 1. So that's the square root of 1. So we have 2 minus 4, that is minus 2, and then minus 2, which is not equals to 0. So 2 is not a solution to this equation. Yeah, we need to be aware of that when we square both sides. We introduce solutions that might not necessarily be true. Let's move to 1.2. We're supposed to solve for the following equations simultaneously. The first equation, we have x, so that is 1.2. We have x minus 2y being equals to 1. So x is equals to 1 plus 2y. I can call this equation 1. Why am I writing x in terms of y? Because if I write y in terms of x, then I'm going to divide by 2, which will get messy. So it's better I just make x the subject of the formula. And then the other equation, we have x squared minus xy plus 2y squared being equals to 2. So I'm going to substitute, I can call this equation 2 and say that I'm substituting equation 1 into equation 2. So that will look like the following. In place of x squared, I have 1 plus 2y squared minus, in place of x, 1 plus 2y multiplied by y plus 2y squared being equals to 2. So what is 1 plus 2y squared? That will give you 1 plus 4y plus 4y squared, and then minus y minus 2y squared plus 2y squared minus 2 being equals to 0. So I have 4y minus y, that is 3y, and then minus y squared plus 2y squared, that is 0. So here I'm going to have 4y squared plus 3y, 1 minus 2. So that is minus 1 being equals to 0. So that is what I need to factorize. If I do that, I'm going to have 4y, and then here I have y, and then we're going to have 4y minus 1, y plus 1 being equals to 0. So it is easy to see here that y is equals to 1 divided by 4, or y is equals to minus 1. What is the value of x when y is equals to 1 divided by 4? X is going to be equals to 1 plus 2 multiplied by 1 divided by 4. So x here is equals to 3 divided by 2. On the other hand, x will be equals to 1 plus 2 multiplied by minus 1. So x is equals to minus 1. That is the answer to 1.2. Let's do 1.3 in a separate video. It will cost 3,500 for X number of friends to go on a trip. 4 friends do not have money to pay. The remaining friends have to pay an extra 43 rand 75 cents each to cover the cost of the taxi. And 1.3.1, let's calculate X, the number of friends who want to go on the trip. Let's make sense of our situation. When we have X number of friends, they pay 3,500. And when 4 friends don't have money to pay, then the friends that are remaining, the remaining friends agree to pay an extra 43 rand 75 cents. Let's look at how much each person pays when we have X friends that are going on the trip. So here the cost per person will be equals to 3,500 divided by X. The total amount paid divided by the total number of people. But 4 friends decided not to pay. So now instead of having X number of friends, we have X minus 4. So the cost per person when we have X minus 4 will be 3,500 divided by X minus 4. Now the friends are paying slightly more because the 4 friends do not have money to pay. We can say that initially the X friends were paying Y amount of money, And then when the 4 friends don't have money to pay, they now pay y plus 43.75. This is how we can break down this equation. The money x minus 4 friends pay minus the money x friends pay must be equals to 43.75. That is to say that 3,500 divided by x minus 4 minus 3,500 divided by x should be equals to 43.75. Let's go ahead and find the value of x. We're going to start by multiplying out by x minus 4. So if we multiply that first term by x minus 4, we're going to be left with only 3,500. And then now we multiply in 3,500 on the middle term with the x minus 4. So if we multiply it by x, we're going to get minus 3,500x. And when we multiply it by minus 4, we're going to get plus 14,000. Everything divided by x. This will be equals to 43.75 multiplied by x. So we're going to have 43.75x. If you multiply it by minus 4, you should get minus 175. We still multiply it out, but this time with x, so that we can cancel out that x on the denominator. 3,500 multiplied by x, that is just 3,500x minus 3,500x plus 14,000. X and x are going to cancel out, so we don't have a denominator anymore. Well, we have a denominator of 1. On the right hand side, we're going to have 43.75x squared minus 175x. 3,500x minus 3,500x, that is 0. If we group the like terms, we're going to get 43.75x squared minus 175x minus 14,000 being equals to 0. If we divide every term by 43.75, we're going to get x squared minus 4x minus 320 being equals to 0. So now we just need to factorize. How are we factorizing this? Which two numbers do we multiply and get minus 320, but when we add them, we get minus 4. That is minus 20 and plus 16. So we're going to have x minus 20, x plus 16 being equals to 0. X is equals to 20 or x is equals to minus 16. Obviously, we cannot have minus 16 people. So our answer here is x is equals to 20. 20 friends want to go on the trip. Let's look at 1.3.2. Calculate the total amount that each friend pays for this trip in order to cover the cost. The cost per person when the 4 friends don't have money to pay is equals to 3,500 divided by x minus 4. We know that x is 20 and we just subtract 4 there. The friends are going to pay 218.75 rands to cover the cost of the trip. The sum to infinity of a geometric series is 6, and the sum to infinity of the squares of the terms of the series is 6. 3.1.1, write down the second term of the series of squares in terms of a and r. The second term of the series will be given by a multiplied by r to the power 2 minus 1. So T2 is equals to a multiplied by r. But we're looking for the second term of the series of squares. All the terms are getting squared. So T2 squared will be equals to AR squared. This is just equals to A squared multiplied by R squared. So this is the second term of the series of squares in terms of A and R. Let's look at 3.1.2. Calculate the values of A and R. This equation is for 6 marks, by the way. The sum to infinity of a geometric series is a divided by 1 minus r. We are told that the sum to infinity is 6. So we have 6 being equals to a divided by 1 minus r. We want to find the value of a and the value of r. Let's cross multiply. If we do that, we're going to get a being equals to 6 minus 6r. We have two variables, a and r. We need at least another equation. So we can let this be our equation 1. And then another information we are told that the sum to infinity of the squares of the terms of the series is 6. The sum to infinity, let's just put 2 here to show that it is the sum to infinity of the squares of the terms of the series. But what you need to realize is that instead of having a, if we are squaring all the terms, then the first term will be a squared divided by 1 minus. Instead of r, we're going to have r squared. This makes sense if you look at the second term in 3.1.1. I think 3.1.1 is setting us up to be able to answer 3.1.2 to make that realization. We know that the sum is 6, and this is equals to a squared divided by 1 minus r squared. If we cross multiply, we're going to get a squared being equals to 6 minus 6r squared. We can let this be our equation 2. What we want to do here is to substitute equation 1 into equation 2. In place of a, we are replacing it with 6 minus 6r. So we're going to have 6 minus 6r squared being equals to 6 minus 6r squared. So what is 6 minus 6r squared? 6 multiplied by 6, that is 36. 6 multiplied by minus 6r, that is minus 36r. You multiply that by 2, you get minus 72r. And then minus 6r multiplied by minus 6r, we're going to get plus 36r squared. This is equals to 6 minus 6r squared. Let's take 6 to the left hand side. We're going to get 30 minus 72r. And then 36r squared plus 6r squared, that will be plus 42r squared being equals to 0. We can write this nicely and get 42r squared. This is minus 72r and not just minus 72. And then minus 72r plus 30 being equals to 0. If we take a common factor of 6, we're going to get 7r squared minus 12r plus 5 being equals to 0. So now we can go ahead and factorize. Well, factorizing this is extremely difficult, so it is better if you use the quadratic formula. But anyway, we're going to have 7r minus 5 multiplied by r minus 1. So r is equals to 5 divided by 7, or r is equals to 1. Well, r cannot be equals to 1 if our series is converging. That is the value of r. Now we can find the value of a. We know that a is equals to 6 minus 6r. So we're going to have 6 minus 6 multiplied by 5 divided by 7. So the value of a is 12 divided by 7. Let's go ahead and do 3.1.3. Write down T6 of the series of squares. Under normal circumstances, T6 is equals to AR to the power of 5. But we want T6 of the series of squares. So T6 of the series of squares will be equals to AR to the power 5 squared. So we have A to the power 2, R to the power 10, 5 multiplied by 2. So what is A? A is 12 divided by 7. we square that, and we multiply by r. What is r? R is 5 divided by 7 to the power 10. This is equals to 0.1. Let's look at this. Let's look at the last question, 3.2. We're not going to waste a lot of time here. There are 50 liters of water in a container. Water evaporates from this container at the rate of 1% per hour under certain weather conditions. How much water will be left in the container after 8 hours if left under these weather conditions? So the amount of water that is going to be left after 8 hours will be equals to 50 multiplied by 99% to the power of 8, which is equals to 46.14. In an hour, we are left with 99% of the water because it is evaporating at a rate of 1% in an hour. But we have 8 hours, hence that 8 is up there. We are left with 46.14 liters of water. Determine the values of P and Q if the asymptotes intersect at x is equals to 1 and y is equals to -3. So we are given the equation of f of x. It is said to be equals to a divided by x plus p plus q. In order to find the value of p, we let x plus p be equals to 0. But we already have the value of x. It is equals to 1 at the vertical asymptote. So 1 plus p is equals to 0. It is now easy to see that p is equals to -1. The value of q, on the other hand, is just equals to the horizontal asymptote, which is -3. P is equals to -1 and q is equals to -3. So f of x, now at this point, we know that it is equals to a divided by x minus 1 minus 3. In 4.1.2, we are looking for the value of a. How are we going to possibly find that? We're going to substitute the y-intercept or any other point on the graph. So the y-intercept, x is 0 and y is -5. So let's go ahead and substitute that in our graph. We're going to get -5 being equals to a divided by 0 minus 1 minus 3. If we take -3 to the left hand side, we're going to get -2 being equals to a divided by -1. It should be easy to see now that a is equals to 2. So that is 4.1.2. Let's go ahead and do 4.1.3. If f of x is translated to g of x, describe the translation from g to x. So let's go ahead and take a look at this. In f of x, we have x minus 1. In g of x, we have x minus 3. So when it comes to the x values, x minus shifts the graph to the right, and x plus shifts the graph to the left. We had x minus 1. On g of x, we have x minus 1 minus 2, which is just x minus 3. So we have moved 2 units to the right. We can go ahead and write it down as moving 2 units to the right. On f of x, we have -3. On g of x, we have +3. From -3 to +3, you need to add 6. So we have shifted our graph 6 units up. So here we're going to have 6 units up. 4.1.4, write down the equation of the horizontal asymptote of g. The horizontal asymptote is this value here all the time. So for 4.1.4, we can easily say that y is equals to 3. We are supposed to show that f of x is equals to x squared plus 6x plus 5. What information are we given? We're given the intercepts of f of x, which is p and t. So finding f of x should be relatively easy if we have the intercepts. We can just say that f of x is equals to a multiplied by x minus x1 multiplied by x minus x2. In place of x1 and x2, we are substituting the x-intercepts. So f of x is going to be equals to a multiplied by x plus 5 multiplied by x plus 1. So f of x is equals to a multiplied by x, that is x squared, and then plus x plus 5x plus 5. So we have f of x being equals to a multiplied by x squared plus 6x plus 5. We just need to substitute any point on a graph except from the x-intercepts to find the value of a. We can substitute w, which is our y-intercept. If we do that, we're going to have 5 being equals to a multiplied by 0 squared plus 6 multiplied by 0 plus 5. 5 is going to be equals to a multiplied by 5. It will be easy to see now that a is equals to 1. So f of x is just equals to x squared plus 6x plus 5. That is 5.1. Let's look at 5.2. In 5.2, we're supposed to calculate the coordinates of Q. So let's look at P and Q. At P, our two functions, f of x and g of x, they intersect. The same is true at Q. The two functions intersect. So in order for us to find the value of Q, we need to equate these two functions. So we can say that f of x is equals to g of x. If we do this, we're going to be able to find the x value of P and the x value of Q. We already know the x value of P. It is minus 5. So we're just going to find the x value of Q. F of x, that is x squared plus 6x plus 5. G of x is 2x plus 10. So let's take 2x to the left-hand side together with 10. We're going to get x squared plus 4x minus 5 is equals to 0. So we just need to factorize this. Which two numbers do we multiply and get minus 5? But when we add them, we get 4. That is 5 and minus 1. So we're going to have x plus 5 multiplied by x minus 1 being equals to 0. So x is equals to minus 5 or x is equals to 1. But we know that at x is equals to minus 5, this is where we have the x coordinate of P. So x is equals to 1 must be the x coordinate of Q. So now we just need to substitute x is equals to 1 in either f of x or g of x to find the y value of Q. So let's substitute it into g of x. So g of 1 will be equals to 2 multiplied by 1 plus 10, which is equals to 12. So the coordinates of Q, we have 1 as our x value and 12 as our y value. That is how we're supposed to answer that question. Now we're supposed to show that in 5.3, we're supposed to show that f of x is not equals to minus 5 for all values of x. Let's try showing that it is actually equals to minus 5. And in failing to show that it is equals to minus 5, we would have sort of proved that it is not equals to minus 5. So 5.3 f of x is equals to minus 5, right? So what is f of x? That is x squared plus 6x plus 5 being equals to minus 5. So we're going to have x squared plus 6x plus 10 being equals to 0. In order to factorize this, we need the aid of the quadratic formula. So x is equals to minus b plus or minus square root of b squared minus 4ac, everything divided by 2a. So there's no way issues are going to arise with 2a or minus b. What we need to focus on is square root of b squared minus 4ac. If that number is negative and we cannot take the square root of a negative number, then it would simply imply that f of x can never be equals to minus 5. So let's go ahead and compute that. So the square root of b squared, what is b? B is 6 in our instance, right? So 6 squared, that is 36, minus 4ac. A is 1, c is 10, so minus 40 essentially. As you can see now, we have square root of minus 4, and we cannot compute square root of minus 4. So f of x can never be equals to minus 5. Now we know for sure. Let's move to the following question. 5.4. Consider point R when SR is at its maximum in the interval x is between x at P and x at Q. And then let's do the following. 5.4.1. The gradient of the tangent to f at R. The gradient of the tangent to f at R. So let's look at this statement, this opening statement, and see if it can help us to find the gradient of the tangent to f at R. So let's consider point R. Point R is right here. And then when SR is at its maximum in the interval x is between x of P and somewhere here x of Q, and determine the gradient of the tangent to f at R. So they're saying that SR is a maximum. It is the maximum distance between x of P and x of Q. So what we can actually do, we can find an equation for the distance between the two graphs. The graph that is above is g of x, right? And the graph below is f of x. So we can say g of x minus f of x. And we're going to have an equation for the distance here. After finding the equation for that distance, we can derivate it and equate to 0 in order to find the x value for which it is a maximum. And that will be the x value at R. So that will look something like the following. So we're going to have the distance being equals to g of x minus f of x. G of x, that is 2x plus 10, minus f of x, which is x squared, plus 6x plus 5. So we're going to have 2x minus 6x. So we have minus 4x, and then 10 minus 5 plus 5 minus x squared. This is our distance. Now let's go ahead and derivate. If we do that, we're going to have minus 4 minus 2x. And then we are equating to 0 in order to find the x value for which that distance is a maximum, which will be the x value of R and the x value of S. If we take minus 4 to the other side, we're going to get 4 is equals to minus 2x. We divide both sides by minus 2, we get minus 2 is equals to x. So this is the x value at point R, and we want the tangent at R. So if we have the x value, what we can do is derivate f of x and then equate that x value. In derivating f of x, we're going to get 2x plus 6. When we substitute minus 2, we're going to get 2 multiplied by minus 2 plus 6. This will give you 2. So the gradient at R when x is equals to minus 2 is 2. We have answered the first question. Now let's go ahead and answer the question that follows. It is saying, let's find the equation of the tangent to f at R. So the equation of a tangent, it is a straight line. We're going to have y is equals to mx plus c. M is the gradient, so y is equals to 2x plus c. We need to substitute point R into this equation so that we can find the value of c. For point R, we have x of R, which is equals to minus 2. So we can say f of minus 2 in order to find the y value at R. So we're going to have minus 2 squared plus 6x, not 6x, but 6 multiplied by minus 2 plus 5. So minus 2 squared, that is 4, 6 multiplied by minus 2 minus 12. So we have minus 8 plus 5, which will be minus 3. The coordinates of r, we have minus 2 and minus 3. So if we equate it into our equation, we're going to get minus 3 being equals to 2 multiplied by minus 2 plus c. So minus 3 is equals to minus 4 plus c. So 1 is equals to c. Then y will be equals to, what is the gradient? 2. So we're going to have 2x plus 1 being the equation of our tangent. The last question, 5.5. Consider x being greater than x at p, and then for which values of x is g of x minus the inverse greater than 15. Right, so g of x is equals to 2x plus 10. Let's see if we can find g inverse. So in order to find g inverse, we need to swap x and y and solve for y. If we do that, we're going to have something like the following: 2y plus 10. So 2y is equals to x minus 10. So y is equals to a half x minus 5. This is g inverse. So now we're looking for g of x minus g inverse being greater than 15. So let's go ahead and substitute. We're going to have 2x plus 10 minus a half x minus 5 being greater than 15. So 2x minus a half x, that will be 3 divided by 2x, and then 10 minus 15, that will be plus 15 being greater than 15. So we can take 15 to the right hand side. We're going to have 3 divided by 2x being greater than 0. 15 minus 15 is 0. So if we divide both sides by 3 divided by 2, then our answer is just x is greater than 0. F of x is said to be equals to 4x squared minus x. If we use the power rule, f prime of x is equals to 8x minus 1. So in using the first principle, if we don't get to 8x minus 1, then we made a mistake somewhere. So let's go ahead and derivate this function using first principles. First, we're going to compute f of x plus h. We are replacing x with x plus h on our equation f of x. We're going to get 4 multiplied by x plus h squared minus x plus h. If we solve this, we're going to get 4 multiplied by x plus h squared, that is x squared plus 2xh plus h squared minus x minus h. This will be equals to 4x squared plus 8xh plus 4h squared minus x minus h. We have f of x plus h. Let's go ahead and subtract f of x. So f of x plus h minus f of x will be equals to 4x squared plus 8xh plus 4h squared minus x minus h. Everything minus 4x squared minus x. So we have 4x squared minus 4x squared, that is 0. And then we have minus x plus x, that is also 0. So f of x plus h minus f of x will give us 8xh plus 4h squared minus h. Now we just need to divide by h. So we're going to have f prime of x being equals to the limit as h tends to 0 of 8xh plus 4h squared minus h divided by h. We can take h as a common factor on the numerator. We're going to have the limit as h tends to 0 of h multiplied by 8x plus 4h minus 1. Everything divided by h. H and h cancels out, and then now we are letting h tend to 0. So we're going to have 8x minus 1. The same answer we got when we used the power rule. Let's look at 7.2. 7.2.1. Determine dy dx if y is equals to, so we have y being equals to minus x to the power 3 minus 16x squared plus 6x. dy dx will be equals to minus 3x squared minus 32x plus 6. And just like that, we have answered 7.2.1. No trickery whatsoever. Let's do the question that follows. 7.2.2. This one is a bit interesting. F of x is equals to 4 divided by 5x to the minus 3 divided by the square root of x squared. Well, the cube root of x squared. Let's write f of x in our usual format. We're going to get f of x being equals to 4 divided by 5 x to the power 3. If it is x to the power minus 3 and it is on the denominator, when you put it on the numerator, it's going to be x to the power of 3. We have the cube root of x squared. This is just equals to x to the power 2 divided by 3. So we're going to have x to the minus 2 divided by 3. Now we have our equation in our usual format. We can go ahead and use the power rule. So we're going to have 3 multiplied by 4 divided by 5, x to the power 3 minus 1, minus 3 multiplied by minus 2 divided by 3, x to the minus 2 divided by 3 minus 1. This is equals to 12 divided by 5, x to the power 2 plus 2x to the power minus 5 divided by 3. We're supposed to sketch a cubic function given these following properties. The first property is that f of minus 2 is equals to f of 1 is equals to 0. So if f of minus 2 is equals to 0, when x is equals to minus 2, we have our x-intercept. So let's go ahead and put that in our graph. So here at minus 2 and here at x is equals to 1, we have our intercepts. The next property is that f prime of 1 is equals to f prime of minus 1 is equals to 0. So at x is equals to 1 and x is equals to minus 1, the gradient is 0. Here at x is equals to 1, we have an intercept and turning point at the same time. Right, and then f of minus 1 is equals to 4. So we have a coordinate here. F of minus 1 is equals to 4. And then f of 0 is equals to 2. That is our y-intercept. So f of 0 is equals to 2. The gradient of our graph is less than 0 when x is between minus 1 and 1. Let's try connecting these points and see what we have. So here at x is equals to minus 1 and 4, we have a turning point. And then the same is true with x is equals to 1. We have a turning point right here. So we're going to have something that looks like this. Let's answer the following question. 8.2. Determine the equation of f in the form y is equals to. Because we have the x-intercepts of our function, it will be easy to determine the equation. F of x is equals to a multiplied by x minus x1 multiplied by x minus x2 squared. So why do we have x minus x2 squared here? We squared the intercepts, that also serves as a turning point. So when we substitute here, we should have f of x being equals to a multiplied by x plus 2 multiplied by x minus 1 squared. This is what we need to solve. So f of x is equals to a multiplied by x plus 2. X minus 1 squared, that will give us x squared minus 2x plus 1. So f of x is equals to a multiplied by x to the power 3 minus 2x squared plus x plus 2x squared minus 4x plus 2. If we solve that, we're going to get f of x being equals to a multiplied by x to the power 3 minus 2x squared plus 2x squared. So that is 0. X minus 4x, that is minus 3x plus 2. This is our equation. We just need to find the value of a. How can we possibly do that? We can substitute a coordinate into this equation. We know that f of 0 is 2 from our properties. So we can say that 2 is equals to a multiplied by 0 to the power 3 minus 3 multiplied by 0 plus 2. So 2 is equals to a multiplied by 2. It should be easy to see that a is equals to 1. So if we substitute 1 back here, then we're going to get f of x being equals to x to the power 3 minus 3x plus 2. This is our equation. Let's move to the following equation. 8.3. If g of x is equals to f of x minus 3, write down the x-intercepts of g. Right, before we break down this equation, let's write down the x-intercepts of f of x first. We have minus 2 and 0. We also have 1 and 0. Now let's make sense of this transformation. G of x is equals to f of x minus 3. So x minus 3 shifts the graph of f of x 3 units to the right. If it was plus, then it would shift it to the left. It is counterintuitive, but it is what it is. So we just need to move these x values 3 units to the right to get the x-intercepts of g of x. So minus 2 plus 3, that is 1, and we have 0 as our y value. And then 1 plus 3, that is 4, and we still have 0 as our y value. So this is the intercepts of g. If you instead substitute x minus 3 in place of x in f of x, you will probably get to the same answer, but that will take the entire day. So it is easier to do it like this. Let's look at 8.4. Determine the values of p for which x to the power 3 minus 3x plus 2 is equals to p will have exactly one root. Exactly one root means exactly one x-intercept. So if we write this nicely, we're going to get x to the power 3 minus 3x plus 2 minus p is equals to 0. So minus p is shifting our graph up and down. P is greater than 4 or p is less than 0. If you want to know how this comes about, then click this video on your screen right now. Show that the total area of the square and the circle formed is given by this equation. A boy uses 12 meters of wire to form a circle and a square. Each side of the square is x meters long. So on each side of the square, we're supposed to have x meters. So we're going to have something that looks like this. So the amount of wire used to make the square is 4x, as each side is x meters long. Amount of wire used to make the circle will be 12, the total amount of wire, minus the amount of wire that was used to make the square, which is 4x. The wire used for the square and the wire used for the circle. As soon as you miss this, there's no way you can answer this problem. You need to realize that this is the case. So for the area of the square, we're going to have the area being equals to x squared. And then now comes to the area of the circle. The amount of wire used for the circle is 12 minus 4x. This is the circumference of our circle. It is 12 minus 4x. So we can say that 2 pi r is equals to 12 minus 4x. 2 pi r is the formula you use to get the circumference. In this case, it is equals to 12 minus 4x. We want to find the area of the circle. So I'm doing this so that I can find the radius, because as soon as I have a radius, I have an area for that circle. If I divide both sides by 2 pi, I'm going to get r being equals to 12 minus 4x divided by 2 pi. I think I can factor out 2 here on the radius. If I do that, I'm going to get 6 minus 2x divided by pi. I took a 2 as a common factor on the numerator and then on the denominator, and I cancelled out. So the radius is 6 minus 2x divided by pi. Now we can go ahead and find the area of our circle. So the area of the circle will be pi r squared. So we're going to have pi multiplied by the radius, which is 6 minus 2x divided by pi squared. This will be equals to pi multiplied by, so 6 minus 2x squared, 6 multiplied by 6, that is 36. 6 multiplied by minus 2x, that is minus 12x. You multiply that by 2, you get minus 24x. And then minus 2x multiplied by minus 2x, we're going to get plus 4x squared. Everything divided by pi squared. We can cancel out pi and pi. So we're going to get 4x squared minus 24x plus 36 divided by pi. This is the area of the circle, and this is the area of the square. We want to find the total area, so we can just easily add those two. We're going to have the area being equals to x squared plus 4x squared minus 24x plus 36 divided by pi. So I can rearrange this and get pi x squared plus 4x squared minus 24x plus 36, everything divided by pi. I have x squared and x squared, which I can take as a common factor of those two terms and get the area being equals to 4 plus pi multiplied by x squared minus 24x plus 36, everything divided by pi. And this is what I'm required to prove. The total area of the square and the circle formed. 9.1. Let's move to 9.2. Determine the value of x for which the total area is minimum. So the area is equals to 4 plus pi x squared minus 24x plus 36, everything divided by pi. We need the value of x for which this area is a minimum. So we need to derivate at some point. It looks like it will be very difficult to derivate, but it is actually not. Let me show you how. Let's give every term on the numerator its own base of pi. So if we do that, we're going to get 4 plus pi multiplied by x squared divided by pi minus 24x divided by pi plus 36 divided by pi. So we want to derivate and equate to 0. Here we just simply apply in the power rule. So we're going to have 2 multiplied by 4 plus pi divided by pi x minus 24 divided by pi. 36 divided by pi is a constant. So this will be equals to 0. So now we can say that x is equals to 24 divided by pi with everything divided by 2 multiplied by 4 plus pi divided by pi. The value of x for which the area will be a minimum is 1.68 meters. How many 4-digit codes will be formed using these digits? with the following conditions. The code must be an even number. The first digit must be less than 4, and the digits may be repeated. 4-digit codes, so we have 4 spaces that we need to fill. The code must be an even number, so on the last position we need an even number. If the number on the last position is even, then the code itself is even. So how many even numbers do we have here? We have 0, 2, and 4. So only 0, 2, and 4 can occupy that last spot. The first digit must be less than 4. If it is less than 4, then only 0, 1, 2, 3 can occupy that first spot. We need to put that in mind. So in the first position, one of the 4 digits can occupy that spot. And then on the last position, one of the 3 digits can occupy that spot. What about the second and the third spots? 1, 2, 3, 4, 5, 6, 7. So we're going to have 7 here, and we're also going to have 7 here if repetition is allowed. The answer here is 588. So this is the number of digits that we can generate using those digits and having those conditions. The answer to 10.2. Let's look at 10.3. The letters of the word leopard are randomly arranged into different 7 letters words. Letters may not be repeated. And then the first question, 10.3.1, in how many different ways can the letters of this word be arranged? So let's go ahead and look at our word. We have 1, 2, 3, 4, 5, 6, 7 letters. In how many ways can we arrange 7 letters? All the letters are distinct. There's no repetition on the letters. So the answer here is 7 factorials because there is no repetition. If there was a repetition, then we would have to account for that. And then the following question, 10.3.2, determine the number of different ways in which a word formed will start with a vowel and end with a consonant. Right, let's see how that will look like. We need 7 spaces as we have 7 letters. So we're going to have 1, 2, 3, 4, 5, 6, 7. We need to start with a vowel. How many vowels do we have on the word leopard? We have E, O, and A. So we have E, O, and A. And then the other condition is that it ends with a consonant. And then our consonants here is L, P, R, D. The first position is going to be occupied by one of the 3 vowels. So we're going to put 3 here. And then the last position is going to be occupied by one of the 4 consonants. So we're going to put 4 here. We started with 7 letters. Now we have used 2. One to occupy the first spot and another one to occupy the last spot. We are left with 5. So we're going to have multiplied by 5. Now we are left with 4, 3, 2, and then 1. This is all equals to 1,440. The last question, which is a bit tricky, 10.3.3. Calculate the probability that in the different words formed in 10.3.1, all vowels will not follow each other. It's very difficult to count will not compared to counting will. The probability of an event not occurring is equals to 1 minus the probability of that event occurring. So what we can do instead, we can calculate the probability of the vowels following each other. And then the probability of the vowels not following each other will be 1 minus the probability of the vowels following each other. So let's go ahead and do that. We have 1, 2, 3, 4, 5, 6, 7 spaces that we need to fill. Let's say that our vowels follow each other. So we have A, E, and O. And then the consonants L, P, R, D. So if the vowels are following each other, then we can sort of bind them together, so to say. Wherever they are, they need to be close to each other. Even though the vowels are next to each other, there's still 3 factorial ways of arranging them. We can start with E, we can start with O, so on and so on. So we're going to have 3 factorial. This is for the arrangement of the vowels among themselves. They're still close to each other. So now we have vowels that are moving as one, and we have 4 consonants. The vowels can be in between 2 consonants. There is no problem as long as the vowels are close to each other. So there is 5 factorial ways consonants and the 3 vowels that needs to be next to each other can be arranged. This is equals to 720. So the probability of the vowels not being close to each other will be 1 minus the probability of the vowels following each other. This will be 720 divided by our sample space, which is 7 factorial.